In this video, we're going to read about so many different PyTorch questions, but roll that intro first. Here we have it, the PyTorch forum. All right, so what we're gonna do is we're gonna take all categories, we're gonna take the top questions, and we're gonna take the top questions of all time. So I'm gonna put good timestamps so that you can see the questions that interest you the most. All right, let's do this. So the first question is guidelines for assigning num workers to DataLoader. So I'm not familiar with this in detail, but essentially you can use multiple workers. You can send that as an argument to the DataLoader. And essentially this will do some multiprocessing so that while your model is training, it's going to pre-process the data and so on. So I think it's by default, it's 0 or 1. So the question is, how many should we set it to? All right, so I realize that to some extent this comes down to experimentation, but are there any guidelines on how to choose num workers for a DataLoader object? Should it be equal to the batch size, or the number of GPU cores in my machine, or the number of GPUs in my data parallelized model? Is there a trade-off with using more workers due to overhead? Also, is there a reason to leave num workers as 0 instead of setting it to at least 1? All right, and there's a lot of answers to this one, so let's go through it. Having more workers will increase the memory usage, and that's the most serious overhead. I just experiment and launch approximately as many as are needed to saturate the training. It depends on the batch size, but I wouldn't set it to the same number. Each worker loads a single batch and returns it only once it's ready. Num workers equal to 0 means it's the main process that will do the loading when needed. Worker equal to 1 is the same as any n, but you only have a single worker, so it might be slow. All right, so far, there's no real guideline. It's up to experimentation essentially, but perhaps we can find some guideline. I use multi-subpros to load the data, number of workers equal 8, and with the increase of epoch, I noticed that the RAM, but not GPU memory increases. All right, I thought maybe I can kill subprocesses after a few epochs and then reset new subprocesses to continue to train the network, but I don't know how to kill the subprocesses in the main processes. All right. So there are many questions. I'm just going to scroll and see which ones are the best. So this guy is pretty good, gives good answers. The more data you put into the GPU memory, the less memory is available for the model. If your model is data, it shouldn't be a problem. Otherwise, I would rather use DataLoader to load and push the samples onto the GPU and then to make my model smaller. All right. I don't think it's ever possible to tell if it's optimal. Just try things, and once it stops improving, just use that. I mean, I would like some kind of, like, I don't know, 2 times the batch size or something that is an approximation of how we should set the number of workers. I guess it's not that simple. Is there anyone has met this in setting num workers could make the training stop? Recently, all right, I've never encountered that. All right, so this question has a lot of answers. We're not going to read through all of them, I think. All right, let's see. So far, there haven't really been any answers to the general guidelines, in my opinion, just that we should experiment. I find that num workers equal to batch size per GPU works well for my model. For example, if you have 2 GPUs and your batch size is 6, then set number workers to 3 may work. All right, there should be some type of some numerical experimentation depending on the batch size, etc., so that we can have like, so that, for example, we can say that 4 is a pretty good number or 8 is a pretty good number, but you should pretty much never go beyond, I don't know, 30 or something like that. And I think in a common case, the batch size is quite large, such as 32. And if you have 2 GPUs, then you may set the batch size as 32. However, if you consider the thread numbers of CPU, then it sees that 32 might be large than the CPU thread number, which is not reasonable. So the batch size is not a good guideline, the batch size, and we should probably use something that also encompasses the CPU threads. So again, this is a bit over my level. I'm not sure really how, like, why it should matter depending on these two factors, but that's what they say. All right. I mean, people are still answering this thread, so there should probably be some type of good responses, since this is also the most top thread of all time on PyTorch forum. Here's an example. The best performance from pin memory equals true and num_workers equals 5. All right, so this is if you pin the memory and num_workers equal. All right, num_workers equals 5. That's when he finds the best result. But I guess this is also dependent on the batch size and so on. When pin memory is false, num_workers is 6 or 8. All right. When I keep number of workers, it doesn't work. If I understand correctly, this formula works for data loaded into GPU. For loaded data in CPU, would you happen to have the corresponding formula too, e.g. k times number of CPU? All right, let's read this one. This seems a good one. I have received some bad advice on this, and I would like to make the learning experience easier for others. Here's my process of identifying suitable values for CPU cores, num_workers, and batch size. Please extend and critique as necessary. My particular case is on data that is in a NumPy array in RAM, 25 million samples and 20 float features. All right, it does not fit on the GPU with the model, hence I'm using a data loader. I'm running my experience on a computational cluster, but effectively I'm only reserving 1 GPU and at most 3 CPU cores that is on the same physical server. All right, we're just gonna skip that one. So CPU num_workers. Increasing num_workers reduced training time, but I saw no improvement whatsoever after num_workers exceeded the number of CPU cores. All right, there's quite a lot of bad advice, or rather, there's quite a lot of advice indicating that the num_workers should be twice as large as the number of CPU cores, but this was not the case for me. All right, so if we're going to answer this question simply, just set it to, I mean, it's up to experimentation, obviously. That's sort of what the answers indicate. But setting it to something like 4 is probably a good guideline, 4 or 8, because that should be, most people have 4 or 8 CPU cores. So I think that's a good guideline. So if you don't know, set it to 4 or 8. I guess that's very much a simplification, but that's how I view it right now. And if you have a better response, then leave them in the comment section, and I'd be happy to change my opinion. All right, that was the first question. So these ones have a lot of replies. That means we can't read the entire thing, because that would, well, I guess we have time. We don't have to, but some of the responses are specific to some kind of project they're doing or something. And we just want the, I'm kind of scanning for good answers to the question. I think we have a good estimate for this question, at least for now. So the next question is, why do we need to set the gradients manually to 0 in PyTorch? Right, that's an interesting question. Why do we need to set the gradients manually to 0? E.g. w1.grad.data.0. Why do we need to do that? What happens if we don't do that? feels that needing to ask this question means that there's something conceptual, fundamental about the design of PyTorch that I do not understand. All right, so I think normally, at least in my experience, I don't normally do specific weights and zero the gradients of specific weights. Normally, you would do optimizer.0grad, and that would zero the gradients for all of the parameters in the model. But let's see. So every time a variable is backpropagated through, the gradient will be accumulated instead of being replaced. Every time a variable is backpropagated through, the gradient will be accumulated instead of being replaced. I don't know if I understand. This makes it easier for RNN because each module will be backpropagated through several times. All right. Yeah, that makes sense. If we're reusing a RNN cell several times, the gradients will be accumulated. But that doesn't answer really why the gradients are not zero after the computational graph. I still don't understand though. Is there a link I can just read to understand this? Is there no link to understand how PyTorch works? And so I can form a mental model of it. Like something like this seems very strange to someone coming from TensorFlow. All right, that's a fair point. Since the backward function accumulates gradients and you don't want to mix up gradients between mini batches, you have to zero them at the start of a new mini batch. This is exactly like how a general additive accumulator variable is initialized to 0 in code. By the way, the best practice is to use 0grad function on the optimizer. All right, so this is a good answer, I think. So when we, the gradients that we calculate is specific to the batch, right? So the gradients tell us in what direction we should move the weights so that we can minimize the loss function. But the gradients are specifically calculated for the batch that we send in. So that might tell us to go in one direction, and the next batch might tell us to go to another direction depending on the data points. So you wouldn't want to mix up what you get for the one batch with another. So you want to zero them in between. But I think a good question here is in TensorFlow, I think they would be zeroed automatically. So why isn't, I guess we'll keep on reading. So a more explicit example is the ability to add gradient from several forward passes, for example, in GANs. All right. I guess, so in GANs you have two optimizers, but yeah, there might be a point to this, but I'm not seeing it. So if you wanted, you could also achieve mini batches that are larger than fit in your memory by combining several sub-mini batches into one gradient step. But I've not really seen that done. All right, that's also an interesting point. So for example, if you have a GPU that's not particularly large, then you can have sort of a mini batch of one, but you don't want to take a gradient step for just a single example. So perhaps you could send in, go through 8 mini batches in that case, or 16 mini batches, all of size 1, and then do an optimizer update. So that way you can accumulate by combining several sub mini batches into a single gradient step. Yeah, that's an interesting point actually. But I think you could still have it by default. The loss.backward would just come at a later point. So you can still accumulate, you could still have a for loop that accumulates multiple and then do loss.backwards. So I don't, perhaps, I mean, the question is really now, why isn't it by default? And even if you use several sub mini batches, you can still do it by default, in my opinion. You just have a loop and then you do loss.backwards. Perhaps I'm missing something. We'll continue reading on. So I don't even know what accumulating gradients even means though. So I'm not sure what are we even talking about. So accumulating gradients would be that you add up the gradients for several things, for several steps. You mean like, why doesn't backward just zero out the gradients before doing the backpropagation? I somewhat agree on this point actually. I would have to really struggle to think of a time when I've called backward without first zeroing out the gradients. Yeah, that's my experience too. I mean, I always do 0grad, although I haven't done that many I guess, complex things. So there might be scenarios that I'm not seeing. Like it seems like what we could have an option in backward to not zero out the gradients, like backward preserve grads true, but by default seems like zeroing out the gradients could be the default action. Yeah, and this is the sort of the point that I agree with. All right, let's see. Hi, I think the big difference with TensorFlow is the following. Since you use a static graph, you define exactly what should be done to make one gradient computation update, and then you just tell it to do it using a given input and target. In PyTorch, it is significantly more flexible, as the Autograd engine will just remember how to compute the gradient for a given variable while you are performing computations with this variable. This means that you can get the gradients with respect to a variable, then perform computation with it again, then recompute the gradients corresponding to these new operations. In this scheme, there's not a single point where you stop performing forward operations, and you know that the only thing that is left to be done is compute the gradients. So it is trickier to automatically set the gradient to 0 because you don't know when a computation ends and when a new one starts. Wow, that's a very good point, actually. I mean, that's sort of the big difference between TensorFlow and PyTorch, is that we have these dynamical computational graphs. So when does PyTorch know that you're going to start doing, when is the computational graph done or finished? But I still agree with this point above, in that why don't we just have preserve grads equals true? Sort of an argument to backward, and in that we can have the, sort of an argument saying that we should zero grads and they should probably default with true. But yeah, I feel like we have the question is answered in that we don't want to mix up different mini batches, but then there's this sort of a follow-up question in why isn't it default? And they brought up a few good points here, in that it differs in the computational graph. But when you call loss.backward, that should be when you're finished with the forward pass, right? Maybe I'm missing something. An example where the gradient accumulation is useful, for example, if you share some part of a network for two different tasks. All right, you have some input, get the features, get the gradients. You retain the graph. I'm not familiar with retain graph, but I guess you have the same computational graph, I guess. Perform the second task. All right, so you have some task 1, you compute a loss, and then you do loss 2 is task 2 of features, and then loss 2 to backwards. This will add gradients in task 2 and accumulate in feature extractor. This will add gradients in task 2, accumulate in feature extractor. All right, so are we adding when we're doing backward here, are the gradients for the loss 1 still there, and they're the gradients computed for loss 2 are sort of accumulated with loss 1 gradient? All right, now each parameter in feature contains d loss 1 dw plus d loss 2. Yeah, all right. Yeah, okay, so that makes sense. That's I think as I explained it. Yeah, all right, but if you yeah, okay, that makes sense. I can still see the argument that you would want to have a default of 0 grad, and then you could have an additional argument in this one that you want to retain the graph and yeah, but that's what we have. So what am I missing here? Loss.backward, and you'd retain the graph. This adds the gradient with respect to loss1 in both the task1 net and the feature extractor net. All right. So each parameter w in feature extractor has its gradient, d loss1 dw. Oh, okay. Because we've sent in that through some input. There's some feature extractor as well. This might be a bit advanced for me. I need to sort of understand what this retrain graph is doing. All right, so let's just read it. An example where the gradients accumulate is useful, for example, if you share some part of a network of two different subtasks. So the fact that the gradients are accumulated allows you to get the correct gradient for all the computations that you do with the given variable, even if you use it at multiple places in convoluted ways. The drawback here is that you have to manually reset the values so that the gradients computed previously do not interfere with the ones you are currently computing. All right, so I guess the high level idea, I don't really understand the details in that one. I need to go through it a little bit more detail, but the high level thing is that you can build on the computational graph and you can reuse it. But then PyTorch needs to know when are you actually done with the forward pass. So and then you need to manually zero the gradients. Yeah. All right, that's a sort of get it. There's some details that I don't understand about it. That's interesting. I would have thought that the sharing would have been multiplicative since RNNs are a composition of functions and not a mere addition. I think I am more confused. The addition comes from the rules of differentiation, then the gradients for a parameter in both branches is the sum of the contributions of each branch. Yeah. Yeah, okay. Yeah, so if you... Yeah, but that's sort of just the... I guess that's just the how computing gradients works. If you have gradients incoming from multiple places, then you would add them up. If you use it for a parameter in multiple branches, then you would add up the gradients for each branch. So that's sort of just how gradients, computational gradients work. All right, it's not a huge point. We understand why we need to zero out the gradients. We don't want it to impact between different batches, and we could have a discussion of why exactly you don't have it by default. But there seems to be some way. So there, he brings up a point where use case where you actually want to not zero out the gradients, so you would use it for different branches, and that makes sense. But you could still have it by default true, in my opinion, and then you could just not do the default by zeroing out, and you can do it manually. But I mean, it's not really a problem to do it manually, so I mean, it works fine. Yeah, we're gonna move on from this one. So that was the second question. Why? So the third one, model.eval versus with torch no grad. All right, interesting question. So when I test my model, do I have to use model.eval even though I'm using with torch.nograd? Okay. Hi, these two have different goals. Model.eval will notify all your layers that you are in evaluation mode. That way, batch norm or dropout layers will work in evaluation mode instead of training mode. All right, so that makes sense. Let's sort of unpack that model.eval. When you're using batch norm, you're computing what is it? I don't know what the coefficients are called, but essentially for standardizing the data set. You're computing what you should, how you should, the mean and the standard deviation as a running average of your training set. And then, if you're in evaluation mode, you don't want to keep doing that. So you would want to use the values computed for your training set. And model.eval lets batch norm know that that's the way it should now be computed. Or dropout layer, for example, when you're doing at test time, you don't want to drop 50% of your nodes in your network. So and also there's some more complex things to drop out in that we then need to readjust the scaling of the weights. But sort of the overview is that model.eval makes sure that those layers know that they're in evaluation mode so that they work properly. Torch.nograd impacts the Autograd engine and deactivates it. It will reduce memory usage and speed up computations, but you won't be able to backprop, which you don't want in an eval script. Yeah, that makes sense. So if you use with torch.nograd, you're making sure that it's not computing any gradients since you don't want it to impact your weights. So that would be test time or for your validation set or your training, or rather your evaluation and validation or test set. Those are the ones you would use with torch.nograd for. All right. Thank you very much for your quick and clear explanation. Yeah, that was a good explanation. Hey, this implies I should definitely do model.eval while validating. And if memory and speeds are not constrained, torch.nograd can be ignored, right? Let's see answers to that one. With torch.nograd, you'll have much higher speeds and can use large validation batches, so it's not useful if not recommended. Why do something that takes 5 times more memory? The 5 here is for the example, not actual numbers in practice, and is slow, and you can just add 1 extra line to avoid it. All right, so model.eval, you would also, okay, so model.eval freezes the weight parameters. Yeah, that should make sense. So I think model.eval also freezes the model parameters, and then, torch.nograd. So, I mean, if you don't use torch.nograd, you're computing the gradients, but loss.backward won't do anything since the model is in evaluation mode. So this comment kind of makes sense. Why wouldn't you just add 1 line and it would be more efficient? Yeah, all right, I meant to write if not compulsory. Yeah, so it's not, you don't have to, it seems like. Does torch.nograd also disable dropout layers? No, it does not. All right. Yeah, so you would have to do model.eval to disable the dropout layers. So why is torch.nograd not enabled by default inside model.eval function? Is there a situation where we want to compute some gradients when in evaluation mode? Even if that's not the case, it seems like nograd method should be made an optional argument to eval and set to true by default. Okay. Some users can have a use case for this. The problem with doing this, I guess, is that nograd is a context manager to work with the Autograd engine, while eval is changing the state of an nn.Module. I mean, yeah, I definitely understand sort of the question better now, in that they are very... Why wouldn't... Okay, so the question is, why wouldn't we if the model is in evaluation mode, so you're not gonna change the weights of the network, why wouldn't you do torch.nograd automatically? Well, I think sort of in my last video, I did neural style transfer, and that in that video, we're changing the input rather than the model parameters. And you would freeze the model by doing model.eval, but you wouldn't use torch.nograd since you still want to compute the gradients and do loss.backwards, only that you're now changing the input rather than the model weight. So, I mean, that's a use case where you wouldn't want to have it by default. So in that sense, it makes sense to separate them. I think, honestly, yeah. So I understand this point. Why is it not enabled by default, and we could disable it if we want? But I mean, I don't see why that wouldn't change that much. I mean, if this was more convenient to do for some reason, which I don't know, then this definitely, you know, it's still clean and a good way to do it, I feel. And I guess, yeah, as he mentions, there are different things. Nograd is a context manager that works with the Autograd engine, and the other one works with nn.Module. And I'm not sure exactly how these differ. I haven't spent too much exploring the source code. But I mean, the PyTorch people, they're pretty smart people. So, I mean, if they've done it that way, they have a good reason to do it that way, I feel. Do you know how exactly the eval mode affect the dropout layer in the test? What are the differences of the dropout behavior between the eval and the training mode? All right, during eval, dropout is deactivated and just passes its input. During the training, its probability P is used to drop activations. Also, the activations are scaled. Yeah, they are scaled because, yeah, we don't have to go into that. 1 over P, as otherwise the expected values would differ between training and eval. Yeah. Thanks a lot. Your answer is the same as what I thought. I'm just going to scan through these. All right, I understand that eval changes the batch norm and dropout layers behavior. Torch.nograd deals with the Autograd engine and stops it from calculating the gradients, which is the recommended way of doing validation. But I didn't understand the use of with torch.set with torch set grad enabled. Yeah, I don't understand. I've never used that one. Can you please explain what it's used and where exactly can it be used? Thanks. Torch set grad enable lets you enable or disable the gradient using a bool argument. Yeah, I mean, that's fair. That's what it does. But where is it used? Okay, torch.nograd just disables the gradient calculation, while torch.setGrad enable sets gradient calculation to on or off based on the passed argument. Are you saying that torch.nograd and torch.setGrad enabled false are the same? Yes, if you're using it as a context manager, torch.setGrad enable can globally enable disable the gradient computation if you call it as a function. All right, I mean, we understand the the overview of the question. I feel like these are details that are a bit going over my head anyway, so let's go back. Now we've answered, so next question, how to load part of pre-trained model. How to load part of pre-trained model. Will the unused parameters be auto-deleted if I load the whole model but only use part of it? Let's see, is the camera good? I should do it like this. See me a little bit better. Will the unused parameters be auto-deleted if I load the whole model but only use part of it? Okay. Unused parameters auto-deleted if I load. All right. So, I mean, if you don't use it, then... Okay. Yeah. But the weights of the model needs to be something anyway, so... All right, let's see what the answers are. I'm afraid not. The keys of static must exactly match the keys returned by this module static function. Yeah, so... Yeah, I mean, that makes sense. So when you, to load the model parameters of something that's pre-trained, you need to have exactly that model. You can't have anything else or it won't be able to load. So you need to have that exact model, and I've done videos on this too, that after you've loaded the model parameters, then you can actually modify the network. But it needs to be exactly the same in the beginning. If name not in new model, it will raise key error, but I guess this may work for you. Yeah, okay, so you could load the dictionary in some special way. Yeah, I can check if that layer, you can go through the names of the ones in the model dictionary, and if name is not in the own model, then you can just skip it, and otherwise you load it. You could do that, but I think it's easier to just define the entire model, load it, and then remove certain layers. I feel like that's an equally good way of doing it, and perhaps could be a bit simpler. You can remove all keys that don't match your model from the static and use it to load the weights afterwards. So you do pre-trained dictionary, you would load that, and then you would filter out unnecessary keys, pre-trained. All right. All right, okay. So you could sort of load it, but you would load the entire thing, and then you would remove the ones that you don't want. You would override entries in the existing state dictionary. Okay. And then you would load the new state dictionary. Oh, okay. Right. Wow, thanks a lot. But model.load pre-trained dictionary gives me an object has no attribute load. I think it should be model.load state dictionary of model.dict. Yeah. Yes, it should. I edited this snippet. Thanks. I'm looking for it. It seems awesome. Consider the situation where I would like to store all the weights till the last layer. Shouldn't we also be checking if the sizes match before restoring? It looks like we're comparing only the names. If the sizes are wrong, I believe the copy involved in load will complain. Yeah, that makes sense. So if we're loading in linear layer weights and the shapes don't match, then it won't be possible. Load the new state dictionary. Okay. Hello, what if the net2 is a subset of net1 and I want to load weights from net2 to net1? Can directly use load static dictionary. As of 21st of December 2017, load state dictionary takes the Boolean argument strict, which set to false, allows you to load only the variables that are identical. Oh, okay. When we set to false, allows to load only the variables that are identical between the two, irrespective of one is a subset, superset of the others. Can we do it like this? All right. All right, I don't want to go into source code, so let's just go back. Thanks, it's really helpful. By the way, if the key are the same but size are different, can't handle it, we need to remove the variables. Yeah. I mean, I haven't seen that one. So we can use load state dictionary and we can use the argument strict and we can set it false. It's going to load a variable that are identical between the two models. That could simplify quite a few things. After model dictionary update pre-trained dictionary, the model dictionary may still have keys that pre-trained model doesn't have, which will cause an error. Okay, assume the following situation. Pre-trained dictionary have A, B, C, D. Model dictionary have A, B, C, E. After pre-trained dictionary, in pre-trained dictionary, oh yeah, so we take that one if it's in. Yeah, okay, and model dict update pre-trained, they are pre-trained A, B, C. Model dictionary A, B, C, E. Yeah, because we're only checking the ones that are inside the model dictionary. So when performing model.load state dictionary, model dictionary still has a key E that pre-trained dictionary doesn't have. So what about using model.load state dictionary, model dictionary instead of model? What is the difference? Oh, okay. Model.load state dictionary, model dictionary instead of model.load state dictionary of pre-trained dictionary. It says, this is very useful. Thanks, genius. This is a useful solution for frequent cases, e.g. when you want to have different class fully connected in your model, say because you want to train on different number of classes. Thanks. This seems to work well for people. All right, so I want to just go back because I want to understand that example a little bit better. So we have a pre-trained dictionary. We load it into our model. Model.state dictionary. Then we do pre-trained dictionary. K for K. Key is value for key comma value in pre-trained dictionary items if key in model dict. All right. Okay. I get it. So we have a model. We're looking at the model dictionary. We're checking which are what are the layers associated with this model. Then we're looking in our pre-trained dictionary. We're seeing take that pre-trained dictionary, take the values of it if it exists if it actually exists in our model, in the model dictionary. And then at the end, we sort of have the pre-trained that are the same for our model and the pre-trained dictionary, and then we'll write those to our model. Yeah, we'll update it, and then we'll load the model. Okay, but he brought up a point where what if you have something that doesn't exist in the pre-trained dictionary? What do you want to do then if you have it like this? But I mean, if they don't match, so if you have A, B, C, D and you have A, B, C, E, what is it you want to do here? You want to load these three. So when performing model dictionary still has key E, then pre-trained doesn't. All right. Okay, I get it. Yeah. Because then we can't load it, right? Because these are not the same. So we need to have A, B, C, but then we still want to have that E1 to be able to load it, I think. But that should just be initialized to some initialization. So our pre-trained dictionary, we have model dictionary. We filter out unnecessary keys. Filter unnecessary keys by doing the same thing as before. Override entries in the existing state dictionary. Yeah, that makes sense. So we're taking the original model dictionary, we're updating it with the pre-trained, but that still has the last one, the E1 in his example, right? So we're just updating ABC, and then we're loading it, and the E just has what it had originally. Yeah, that's a good addition to the discussion. Yeah. All right, so let's see. How can I load model with its weights? Have a look at the serialization, or do you have a specific issue? All right. All right, we're gonna move on from this discussion. I think we have a lot of a lot of different angles to view this problem, and there seems to be multiple ways of doing it as well. All of them are different than the way I did it. So the way I did it is so what we did in that video, if I remember correctly, we took the entire model and then we just removed the last layers. So we took the entire model and then we just removed the specific, just by indexing as if it were a list. And yeah, so and if we wanted to remove a specific layer, all we would do is what I did is I mapped it to an identity function. So in that one, it would just let it pass. And I feel that's a way of doing it too, but I guess that's a lot cleaner in that you would set up the one exactly as you want it, and that wouldn't incorporate the identity mappings, which it makes more sense, I think, but the one I did it is sort of a simple solution. All right. How are optimizer.step and loss.backward related? Hi, I am pretty new to PyTorch, and I'm surprised with the performance. I have followed tutorials, and there's one thing that is not clear. How are optimizer.step and loss.backward related? Does optimizer.step function optimize based on the closest loss.backward function? Yeah, so the question is, how are optimizer.step and loss.backward related? Let's see what they say. Optimizer.step performs a parameter update based on the current gradient stored in .grad, attribute of a parameter, and then the update rule. As an example, the update rule for SGD is defined here. Calling .backward multiple times accumulates the gradients by addition for each parameter. This is why you should call .0grad after each .step call. Note that following the first backward call, the second call is only possible after you have performed another forward pass. Yeah, so this is how I kind of view it as well. We do loss.backward that calculates all of the gradients through the computational graph, and that sort of stores the gradient values in .grad of the specific tensor, and then optimizer.step uses those gradients so for example, if you just use simple gradient descent by subtracting the weight of specific weight of the model, subtracts it with some learning rate times the gradient of that parameter that was computed in the loss.backward. So optimizer.step simply does the gradient update step. Of course, this is more complicated in using sort of Atom optimizer and all that, but the principle is the same. Note that following the first backward call, a second call is only possible after you have performed another forward pass. This is certainly not true if you specify retain graph e equals true. Yeah, I sort of need to understand what retain graph equals true does. We saw that in another question too. Alright, and in some simple cases, it seems to be possible to backpropagate multiple times even without specifying retain graph equals true. Note that nearly, so where was I? It seems to be possible to backpropagate multiple times, but I don't understand what else of them docs for backwards say about retain graph. Note that in nearly all cases, setting this to true is not needed and often can be worked around in a much more efficient way. All right, so I think he incorrectly said that you can only do a second call on .backward after you have performed another forward step, but if you retain the graph, you can do multiple loss.backwards. Yeah, I think so. Okay, so just without reading documentation, I really should do that. I think a retain graph just makes it so that we don't reset the graph. We still have the same graph and we can call loss.backwards again. I don't see the use case right now, but I'm sure there are many different use cases. So yeah, I mean, the question was sort of asked on a fundamental level, and I think this answer right here did a pretty good explanation. But there are more advanced use cases where you can actually call backward multiple times after, even if you just do one forward pass by using this retain graph equals true. And then he answers on this guy. He says if you have two different loss functions, finish the forward for both of them separately, and then finally you can do loss one and loss two backward. It's a bit more efficient, skips quite some computation, I believe. Yeah. Okay. But this assumes the different loss functions are used to compute grads for the same parameters, right? It doesn't work in a GAN-like situation, although if the two loss functions are literally the negative of each other, there might be some shortcut. I don't understand this. Yeah, in GAN, we would have two separate networks. So all right, we're gonna ignore this. I feel like this, they're sort of taking the discussion to something more advanced, which is fine, but I think the original question didn't have to be this complex. I'm just scanning so that if there are anything that we missed, but it seems like that was the answer to the question. So let's go to the next one. Saving and loading a model in PyTorch. I've made a video on this. If I have a model class and a training class, I create an instance of the model and train it. how can I save the model to a file after it has been trained, and how can I then reload it and continue training? Guide just links to some documentation. Fortunately, that tutorial is incomplete to resume training. It only will allow saving a model, but it does not save the optimizer, epoch, score, etc. You can check out the ImageNet example where you call some function, save checkpoint, and then you just so you send in the epoch, the arguments, the state dictionary, the best precision, the optimizer. So these two are the most important. You need to send in the model parameters and you need to send in the optimizer parameters. Maybe if you use something simple like stochastic gradient descent, there are no parameters. But if you use Atom or anything like that, that's keeping track of a sort of an exponential average of the gradients. And so you would need to store that. And then the function would be torch.save and then just the state. And that would be the state, a dictionary of these things. And the file will be checkpoint.pth.tar. And I think this is exactly what I did. Well, let's see, maybe there's something I could have missed. Loading / resuming from the dictionary is there. If args.resume, so you would do it in this way. You would have the checkpoint, you would index it as a list, and you would get the string of the one you're looking for. So for example, for the model, you do model.load state dictionary, and you would do checkpoint and then in brackets state dictionary. And that's how I explained it in the video as well. And I might even have gotten it from here, I don't remember. The best and safe way to save your model parameters is doing something like model.save state dictionary and to load. This doesn't save the optimizer. Unfortunately, this has the same issue as the tutorial. It won't save the epoch and the optimizer state, so you can't resume training, which was what the original poster needed. Instead of save state dict, shouldn't it be torch.save? So it won't save the optimizer. I think what the first guy did was pretty good. I feel like the question has been answered, to be honest. When you load the model back again via state dictionary method, remember to do my model.eval. Okay. Why will the result differ without calling my model.eval? I don't use this because your batch or dropout layers by default are in train mode on construction. But I'm assuming that when you're so whatever it was before you saved it, that's what it is after you load it. So if it was in training, you're loading it in training. If it was in eval, you're loading it in eval. Or is that what he was explaining in that that's not the case? All right, I'm not really... I'll go back up. Let's see. I guess, to be safe, load a model using that and then do model.train. but I think it should be default. If you saved it that way, then when you load it, it should be in that way. And then, but I guess after, I mean, this should be quite easy to check. And if anyone of you knows that's watching the video, then please leave a comment and explain this. But I mean, to be safe, do model.train before, after loading. And if you want to evaluate it, do model.eval. That should be fine. Okay, what is the difference between view and unsqueeze? Use of unsqueeze. Input is some tensor size 2, 4, and 3. We do unsqueeze and we add an additional dimension at the first one. So we would have another of 1, 2, 4, 3. Yeah. And then use of view. Yeah, if you do view and he uses it in a quite different scenario, I guess. Input.view and he does 1 and then just keeps the dimensions the same. And that also adds in a dimension. So, but then unsqueeze. So I guess in that case, what he's arguing is that unsqueeze is a special case of view. All right, what view does is clear to me, but I'm unable to distinguish it from unsqueeze. Moreover, I am not understanding when to use view and when to use unsqueeze. But all right, so I'll just do my interpretation first, and I might be completely wrong, but unsqueeze sort of makes sense when you want to add a dimension. View, for me, is more related to reshaping tensors. But I guess you can view it in that way. But let's also say that, I mean, this example is not really, I clearly prefer the first one here, right? If we do .unsqueeze 0, since let's say that we would have 10 dimensions of the tensor, which is not common, but then you would do 1, -1, -1, -1 for all of them. That doesn't make too much sense to me. You cannot use the view function as you have written it. Only one of the missing dimensions can be inferred. Not more than one as you have written. This means that when adding a new axis to a tensor using view, you have to specify all the other dimensions manually, except maybe one. That means that when adding, a new axis to a tensor using view, you have to specify all the other dimensions manually. Yeah, so is that the point I brought up, that you would have to do -1 for all of them? Squeeze and unsqueeze pair of functions are utilities that make this very convenient when we just specify where we want to add or remove an axis. Also, in the latest version of PyTorch, you can add a new axis by indexing with none. Or you could use expand. All right, so you could use expand. Expand seems more like repeating the elements, not adding a new dim. Yeah, but it works too. You can repeat a tensor along a new dimension as well. All right, so you can do unsqueeze or you can do expand, but using view as a way of adding dimensions doesn't seem like that good of a choice. But so all right. Sorry for scrolling. I'm just scanning the questions, and if I see anything that's interesting, I'll bring it up. But I probably should sort of say every answer out loud and then discuss it. But so the thing is, if I have a tensor S that's 300 and I want it to be 1, 1, 300. Yeah, okay, so you can do that view 1, 1, -1. Because otherwise you would have to do unsqueeze 2 times. You would do unsqueeze 0 and then .unsqueeze 1, and that would be the same result. But this is, so in that case, this is cleaner. I agree. So what is the difference between s.view and s.resize in this? But I think also the thing is, when do you want to add multiple? I mean, I've never used unsqueeze I've never done that unsqueeze and then repeat it like more than 3 or 4 times. I've mostly just done it once or twice. You usually want to just add 1 or 2 dimensions. But I guess view can be used if you want to do it, I don't know, more times. And you don't want to do dot unsqueeze multiple times. But maybe you can also use dot expand, as he said right here. Yeah. Yeah, expand makes more sense maybe, but you can also use view. All right, a little bit confusing. How can you unsqueeze a 2+ dimensional tensor at once? All right, so he has torch tensor 40 by 40. He does im size, im.view. 1, 1 minus 1 works, but im view 1, 1 minus 1 minus 1 throws an error. Why does it throw an error? And that was the end of the... I don't see why that should throw an error. All right. I don't know. Sort of the thing I get from this post is that you should use unsqueeze, and if you really don't want to use unsqueeze, you can use expand. But it seems like using view is not a good choice. But it seems that you can use view. But in this case, it doesn't seem like you can use view. I'll need to look up this in more detail. Again, if you have more details on this, then please write it in the comment. All right, so yeah, all right, I guess we got some clear idea of the difference between view and unsqueeze. How to cast a tensor to another type. I've made a video on this too, the complete tensor tutorial. I wrote complete for clickbait, but it's pretty complete. It's like 1 hour, and I went through a lot of different use cases of tensor operations and how to convert between types and all that. So if I got a float tensor, but the model needs a double tensor, what should I do to cast the float tensor to double? You just do .double. All right, tensor.double. Yeah, that's what you do. You can also do tensor.type toward a double tensor or type as a string. I wouldn't do that. I would just do tensor.double. I feel the question is answered, so maybe I'm just gonna scroll and see if there's anything we're missing. But yeah, all right. So, but if your tensor is tensor.cuda.floatTensor, oh, by the way, so we can have tensor.floatTensor that will be on the CPU, and if we have .cuda, that would be on the GPU. So converting using tensor.doubleTensor removes CUDA. It's better to use tensor.double because that's going to work for both the CPU and the GPU cores. I agree. So just use .double. It's going to work no matter if you're in the CPU or the GPU. And similarly, if you wanted to convert it to a long tensor, do .long, float.float. And yeah, okay, so could you explain how to convert from long tensor to float while keeping the CUDA property intact? Yeah, but you should be able to do .float. Just if you have a long, you would do dot float, and it will make it float. And that would keep the Cuda property. What if we're talking about variables instead? I haven't tried that on variables, but I feel like it should work. But you could also do exatype. Yeah, I guess you could do dot Cuda. Yeah, I think it should work. If it doesn't work, then you could just do yeah. All right, the .to method will also work on models and D types. E.g., you can do model.to towards a double. Yeah, that's cool. So if you don't want to, yeah, okay. So if you have a model incorporating a lot of multiple tensors, you would do model.to, and then you would set it. I wonder if you can also do model.float. I don't think that's possible. Yeah, I don't think that would be possible, but you can do that on tensors. All right. Yeah, that makes sense. Model.to and then torch.float. If you're going to use on multiple tensors, sort of a model that incorporates multiple tensors. If you're just going to use it, if you're only going to use it on a tensor, then just do .float, long, whatever it is, .int. Okay, how many questions have we done so far? 1, 2, 3, 4, 5, 6, 7, 8. All right, let's go. The next one is weight initialization. How can I initialize variables, say with Xavier initialization? Hi, I think you can extract the network's parameters list and then not network of parameters, and then apply the initialization you may like. Okay, that seems a little bit complicated way of doing it. And let's see, we can go through on that. Oh, I don't want to do that. Let's open it, tab. All right, that's transforms, right? Yeah, that's transformations. And then here, oh, okay, the code has been modified. Scroll and see what they did. Probably they wrote more code, right? So they should be, yeah, okay, here. Custom weight initialization called on netg and netd. And you can do if class name dot find conv -1. If I remember correctly, I did when I researched this, I found that you can send in a net model and you go through each module in the model and you would check if it's in conv layer or if it's a linear layer, if it's a whatever batch norm, and you can do this. You can do m.weight, for example, but that's not. So I guess you can also use .find. Let's keep reading. Another initialization from PyTorch Vision ResNet. And this code seems to have been modified as well. Yeah, and this is how the way that I did it. I think this is more clear. For m in self.modules. What is self.modules? Where is self.module? Can you do that? Oh, okay. It's from the okay, we're gonna, yeah. So this is in the nn.Module, and we don't have they haven't specified this. We can just do it self.modules. So we can go through for each module in self.modules. Then we can do if is instance m, that specific module. If it's an nn.conv2d, we can use some specific initialization like Kaiming. And you can use Xavier, whatever you like. And you can do similar for batch form. You can do similar for linear layers. Yeah. All right. Let's go back. I believe fmos is a cleaner solution. See, who was that? Michael K. I believe fmos is a cleaner. You traverse all modules, and upon class.name matching, you initialize the parameters with what you prefer. Who is color? Oh, okay. Act cold. Yeah, so I think that, yeah, this, I feel there are cleaner ways to do it than the first one. And I haven't seen that you traverse, that you do .find, but I guess that's possible too. Yeah, I just feel it makes sense for me to do is instance and then just check, is that specific layer or module, is it in the conv layer, and then just choose specifically what we want to initialize it to. Yeah. A less Lua way of doing it would be to check if some module is an instance of a class. This is the recommended way. If is instance M and then com2d, then we do Xavier. Man, that feels so good. That's the way I did it. I just feel like the question has been answered, but I'll scan and see if there's anything that we might have missed. But I don't feel like I need to read all of these. Snälla, vad håller du på med? Jag hör att det låter jättemycket. Ska du ut? Gå ut. Inte. I can pause on this. All right, where were we? So, yeah, I feel like the question has been answered, and we can probably move on. Yeah, we're gonna move on from that one. So that's weight initialization. Next question: when should I use? Should I raise this a little bit, maybe? When should I use nn.ModuleList and when should I use nn.Sequential? That's an interesting question. I'm new to PyTorch, and one thing that I don't quite understand is the usage of nn.ModuleList and nn.Sequential. Can I know when I should use one over the other? Thanks. nn.ModuleList is just like a Python list. It was designed to store any desired number of nn modules. It may be useful, for example, if you want to design a network whose number of layers is passed as input. Okay, so he has sort of a nn.ModuleList for an nn-linear, and then he extends that by having multiple linear layers, and then he also appends one at the end. nn.Sequential allows you to build a linear net by specifying sequentially the building blocks and modules of the net. Here's an example. You can do nn.Sequential of com2d, ReLU, flatten, and then nn-linear. Okay. From what I see, it is interchangeable then. Unless there is some order to be followed, then we should use sequential. Am I right? Not really. Maybe there are some situations where you could use both, but the main idea is the following. In nn.Sequential, the nn modules stored inside are connected in a cascaded way. For instance, in the example that I gave, I define a neural network that receives as input an image with 3 channels and outputs 10 neurons. That network is composed by the following blocks in the following order: comp2d, ReLU, linear layer. Moreover, an object of type nn.Sequential has a forward method. So if I have an input image x, I can directly call y equals simple CNN of x to obtain the scores for x. Okay, yeah. So when you have sequential, that's let's see. Okay, so the nn modules are stored inside it so that it's viewed as a single block. Essentially, it's a combination of blocks, but you can just run. It has its own forward method, so you can do as it does here, simple CNN of x, and that would obtain the scores when you run it through the entire block. So in that way, yeah, it's sort of viewed as a single layer. You send in through the sequential and you get out from the sequential. When you define an nn sequential, you must be careful to make sure that the output size of a block matches the input size of the following block. Basically behaves just like an nn module. Yeah, okay. On the other hand, an nn.ModuleList does not have a forward method because it does not define any neural network. That is, there is no connection between each of the nn modules that it stores. You may use it to store nn modules, just like Python list, to store other types of objects, integers, strings, etc. The disadvantage of using nn.ModuleList instead of using conventional Python list to store nn modules is that PyTorch is aware of the existence of the nn modules inside an nn.ModuleList, which is not the case for a Python list. If you want to understand exactly what I mean, just try to redefine my class LinearNet using a Python list instead of an nn.ModuleList and train it. When defining the optimizer, you'll get an error saying that the model has no parameters because PyTorch does not see the parameters of the layers stored in a Python list. Okay, so essentially, model list is a list, is the PyTorch equivalent of a list, where the Autograd will know that will know of the parameters inside of that module list. But the thing is that to send them through each of those in the module list, you would have to do a for loop where you go through each layer by layer, which can be good in some cases, right? I don't know. Let's say for ResNets where you have identity skip connections, then you might want to do a module list because you're going to just add an additional identity. But if you're doing it sequentially, that's going to be seen as a single block, and you can't just modify it in the middle of it, if that makes sense. Thanks for the great explanation. I noticed we can pass a module list as an argument to sequential. Does that mean the layers in the module list are then connected in the cascading way as they would have been if we passed them as argument to sequential directly and unlisted? Oh, okay. What? We can use module list as an argument to sequential. If not, then how can we pass multiple layers as arguments to sequential, like as a list or set, and have them cascade as the way as... I'm not sure what this cascade means, to be honest. I've seen it like 5 times now. Connect in the cascading way as they would have been if we passed. I'm not sure. Honestly, I'm not sure if it's legal to pass a module list directly to a sequential, but you can give it a try. And if that doesn't work, there's a simple, you may define a module, and the module whose init method receives a module list and connects it each module in the module list sequentially. I'm not sure, that it seems like it's a bit advanced now. I'm not really sure why you would want to do it that way. I mean, if you want to have similar, so there's probably some use case that I'm not seeing, but it feels like I see the difference between sequential and ModuleList. If you're going to use, if you want to iterate through the layers, using ModuleList, and that's it. I'm not seeing why you would want to pass a ModuleList to sequential. Thanks for the super fast response. I get the idea. Simple enough. I guess I could also define the forward method in the class that receives a ModuleList and adds sequentially. Yeah, I'm not sure why you, I mean, why would you want to do that? There's probably some way that I'm not seeing, but why would you want to do it that way? All right. I feel like we understood the differences between those two, and that was the original question. Now it feels like we're just doing something unnecessarily complicated, which if you have if I understood the use case, then this would make more sense. But, and I guess I'm not reading it in that much detail now. Scanning to see if there's, yeah, I mean, the first answer was pretty good. I think it explained everything. Yeah, all right, let's move on. Why can't I see .grad of an intermediate variable? Okay. Hi, I am loving this framework. Since I am a noob, I am probably not getting something, but I'm wondering, why can't I get the gradient of an intermediate variable with .grad? Here's an example of what I mean. We have a variable requires grad or true. We have y that is 3 times x, so that's the intermediate variable. We have z that is y times 2. We have z backwards and y.grad. This gives 0. All right, so how do you have to perhaps do the requires grad as well in that one? Since perhaps y in this case will be initialized to not have requires gradient to be true. Let's see. Hi, column. By default, the gradients are only retained for leaf variables. Non-leaf variables, gradients are not retained to be inspected. This was done by design to save memory. Yeah, that makes sense, right? Because if we view the forward pass as a computational graph, the weights are all leaf variables, right? And it makes no sense to store the intermediate gradient values. They're only useful when applying the chain rule to compute the leaf variable. However, you can inspect and extract the gradients of the intermediate variables via hooks. You can register a function on a variable that will be called when the backward of the variable is being processed. Okay. Here's an example of calling the print function on the variable y to print down its gradient. Okay, you can do y.register hook and then print, and then z.backwards. All right, yeah. Thanks. The only way I've been able to really extract the gradient, however, is via a global variable at the moment. This is because the function I pass in apparently only allows me to pass in one argument, and that is reserved for the y.grad. To be honest, I've never encountered example scenarios where I want to register these hooks, and it seems like more of an advanced question. But at least it's good to know that we can see the gradients of intermediate variables, but we need to register them through hooks. And exactly how to do that, I guess we would need to go through more examples of hooks. But one good thing about sort of going through like this is that at least we see the problems, and then we see this is a way to solve it. We don't know exactly how to solve it, right? But when we encounter this problem in the future, we'll know, okay, yeah, I remember using hooks is a good idea in this case. And then you could explore that further. Yeah, I think we're going to move on. I don't have that much to input on this question. And I feel like I don't want to spend too much on this hook thing. All right, how to debug causes of GPU memory leaks. Hi, I've been trying to figure out why my code crashes after several batches because of Cuda memory error. I understand that probably there are some variables that is not freed because I keep it in the graph. The question is how to debug that kind of thing. I have wrote a simple line profiler that examines amount of GPU memory on each step, and it seems like on each loss.backward step there was a massive memory allocation and not all of it is freed. And that piles up for a couple of absolutely identical iterations, leading to a crash. It always crashes on backwards. I understand PyTorch reuses memory, and that is why it seems like it's not freezing memory, but here it seems like something is indeed leaking. Okay, I tried explicitly deling variables to mark them for reallocation by torch, no help. I also used Cuda launch blocking 1 to force it to execute things in place. All right, great question. Hope someone answers. This will be useful to me too. In Python, you can use the garbage collector's bookkeeping to print out the current resident tensors. Here's the snippet that shows all the currently allocated tensors. Okay, so for object in gc.getObject, if torch is tensor, all right, so that means you can just print the current tensors in the graph, and I guess you can manually try to check, are they used or are they, so which of them are stacking up and not using the computational graph. Thanks seems to work with a try except block around it. Some objects like shared libraries throw exception when you try to do has attribute on them. I extended my code that tracked memory usage to also track where memory allocations appeared by comparing set of tensors before and after operation, and results are somewhat surprising. I stopped execution after first batch. It breaks on GPU memory allocation on second batch, and memory consumption was higher in the case where less tensors were allocated. Here is the difference between sorted two things below, i.e. the one thing that has more allocations ending up having less memory consumed. Only possible explanation is that in model that requested more memory, single model was applied twice and the gradient was computed, whereas in the less consuming, the train model is applied once and then a fixed model is applied once. Whoa. May I ask, what did you use to generate your GPU memory trace? Perhaps Python's trace with added py3 nvml calls. Whoa, this is over my head. I don't really get this stuff. All right, let's see this one. Thank you for your reply. Yes, that was set trace with the following trace function. Py and all right, so that. All right, he uses some library and can trace somehow. I must have figured out the source of the leak, by the way. It was due to the fact that significant portion of the code, like variable allocation and intermediate computations, was located within a single Python function scope. So I suspect that those intermediate variables were not marked as free, even though they were not used anywhere further. Putting a lot of dels kind of helped, but just isolating each individual step of computation into a separate function call so that all intermediate variables are automatically freed seems to be a better solution. Does that sound reasonable in the context of PyTorch? I wonder if there could be some sort of semantic garbage collection. I wonder also, this was September 2017. They've probably done quite extensive work on memory leaks. And I haven't encountered memory leaks problem, to be honest. The most common error I get is Cuda out of memory, right? Since trying to load a too large of a model, that's pretty much the only error I get. So this is I guess since I haven't experienced it, all of these things feel a bit advanced for me. So let's try and scroll and see if there are more recent replies. Yeah, because all of these stuff feels like they're a bit advanced for me. But if I ever encounter this problem, this is probably the first thread that I'm gonna read. Oh yeah. Yeah, we're gonna skip this one. I didn't feel like I got that good of a understanding of it. Maybe I'm getting a bit tired too. Let's go. Feedback on PyTorch for Kaggle competitions. All right, that's interesting. Hello team, great work on PyTorch. Keep the momentum. I wanted to try my hands on it with the launch of the new multi-labeling Amazon Forest satellite images on Kaggle. Note, new users can only post 2 links in a post, so I can't direct link everything. I created the following code as an example this weekend to load and train a model on Kaggle data, and I wanted to give you my feedback on PyTorch. I hope it helps you. All right, so he's not actually asking a question. He's just giving feedback to the PyTorch developers, it seems like. So we can read it anyways. Loading data that is not from a regular dataset like MNIST or CIFAR is confusing and hard. I'm aware of the image folder dataset, but that forces an inflexible hierarchy and just plain doesn't work for multi-label or multi-class tasks. First of all, it is confusing because of the dataset and DataLoader distinction, which is non-obvious. Yeah. I do think there is merit to keep those separated, but the documentation must be improved on the rule of both. If possible, I would rename dataset to data storage or data location to make it obvious that we have a pointer to a storage and an iterator to that storage. Yeah. Yeah, the dataset class just points to the storage location, and then DataLoader creates an iterator to that storage. Secondly, it's hard because none of the examples shows a real-world dataset, a CSV with a list of image paths and corresponding labels. This is kind of interesting because this is from April 2017, and I've made a video on this on how to load image paths and a custom dataset with images, and that's sort of the exact same use case he's talking about here, which is interesting because it's definitely been improved, right? In 2020, this is quite easy. Let's see. The second point he brings up, there is no validation split facilities. An example of how to use subset random sampler to create something like similar to scikit train test split would be great. And they've implemented this as well, so they have a train test split now. And let's see, should accept a percentage and a random seed at least, or sklearn fold object at best. Yeah, and they've done this since then. There's no documentation about data augmentation. The following post mention it. However, as far as I understand documentation, if you have 40,000 images, even if you use pill transforms, you still get 40,000 training samples. Data augmentation would be to get plus 40,000 training samples per transformation done. Yeah, as a side note, I believe data augmentation should be done at the DataLoader level as mentioned. Yeah, and this is exactly what they do now. So you in the DataLoader, you do transforms equals whatever transformations you want to have. And you would do that by using transforms.compose to do multiple transformations to the dataset. This is kind of interesting, seeing that they implemented everything that this guy said. Computing the shape after a view is non-trivial. I mean, you can just do 2304 in the following code. Okay. Points 5 or 6 would probably be best in a PyTorch wrapper, but I will mention them. Early stopping would be nice to combat overfitting when loss doesn't decrease for a certain number of epochs. And then pre-printing of epochs accuracy loss. Yeah, and I think they have early stoppage you can use. And this one I don't think they've done actually. There probably some library you can use, but I haven't. So Keras or TensorFlow does this in a much cleaner way, I think. The pre-printing of the epochs and the loss. And he says, thanks a lot for the detailed feedback. A tutorial on writing custom dataset with samplers and using transforms seems to be in order. And they've done that since then. Yeah, I mean, I don't feel like we need to read this. So we can move on to the next one. This wasn't even a question, but was interesting nonetheless. Clone and detach in version 0.4.0. I'm currently migrating my old code from 0.31 to 0.40. During migration, I feel confused by a document about clone and detach. Yes, a clone, I think, just copies it, and detach detaches it from the computational graph. Meaning it won't be used. to, when we do the backward propagation, it won't be used to calculate gradients. I think that's how it's, what are the differences? I will provide a migration code when 0.4.0 is officially released. Here are the answers to your questions. Tensor.detach creates a tensor that shares storage with tensor that does not require gradient. Tensor.clone creates a copy of tensor that imitates the original tensor's requires grad field. You should use detach when attempting to remove a tensor from a computational graph, and clone as a way to copy the tensor while still keeping the copy as part of the computational graph it came from. Yeah, that's pretty clear. So we should just use detach if we don't want it to compute gradients on that specific tensor. Tensor.data returns a new tensor that shares storage with tensor. However, it always has requires grad equals false. False. Oh, okay, so we can do tensor.data and we can copy the data from that, but that's going to have requires grad to be false if default, as default. You should try to not call tensor.data. What are your use cases for tensor.data? And I've read this somewhere else as well, in that we, whenever we use tensor.data, we should ask, is there a better way to do this? Tensor.data is not a good way to do it. From my understanding. Tensor.clone makes a copy of tensor.variable.clone. Yeah. Honestly, I feel the question has been answered already. I feel like there's no point to... Yeah, and he says it here as well. You should not try to call tensor.data. It's going away soon. You can replace it with .detach or with torch.nograd. All right, but I felt like the first answer was pretty well in that in the differences between cloning and detaching. So I'm going to take a quick break and we'll continue with zero grad, optimizer, or net. All right, let's continue. So the question is, should we zero grad the optimizer or the network? What should we use to clear out the gradients accumulated for the parameters of the network? Optimizer.zeroGrad or net.zeroGrad? I've seen tutorials use them interchangeably. Are they the same or different? If different, what is the difference, and do you need to execute both? If optimizer equals optimizer of net of parameters, they are the same. Yeah, and that, I mean, that's what we always do, right? We initialize the optimizer and then we send in model parameters. So if we do optimizer .zeroGrad, so in other words, they're identical. We're supposed to clear the gradients each iteration before calling loss.backward and optimizer.step, correct? Yeah, that is the suggested usage. I'm trying an example. All right. Hi, I'm trying to use an optimizer only on a part of the module parameters. Should I call module.zeroGrad instead of optimizer.zeroGrad if there are other layers between the loss and layer that I'm training? And what if I need to train only the last layer right before the loss of a module? The gradients for the previous layer wouldn't be computed at all. So there is no difference between calling module.0grad and calling optimizer.0grads, right? And yeah, he didn't get an answer. Any solution regarding this question? I also think there's no difference. And then he, Peter, I think his name is Peter. Yeah. If you pass all the parameters of your model to the optimizer, both calls will be equal. However, there might be use cases where you would like to use different optimizers for different parts of your model. In such a case, model.0grad will clear all parameters of the model, while the optimizer will just clean the gradients of the parameters that were passed to it. Yeah. But pretty much they're the same, and there might be use cases where you would want to just zero out specific parameters, either of the network or if you call that are called to the optimizer. But that would depend on the that would be different for the use case, and for most of the cases they're going to be identical. So let's continue. How to choose between torch.nn.Functional and torch.nn.Module. All right, so I think a good example of this is, do you want to use f.ReLU or do you want to use nn.ReLU? Because the functions are included in both. So this is a good question. Hi everyone, I am new to PyTorch from Keras. I find PyTorch has sufficient existing modules and functions that I would like to use in my work. It is great. I have a problem understanding the codes about examples for the MNIST example. And here they use, so they use f.ReLU here. And also f.maxpool 2D. And yeah, f.dropout and all of that. I guess they're going to explain it, but I wouldn't use f.dropout like this, because then you would need to specify if the network is in evaluation or the training mode. But anyways, let's continue reading. I see some functions like dropout used in both init and forward methods. However, in init we use dropout from torch.nn.Module, while the latter is from torch.nn.Functional. Is there any reason for this configuration? Why not the same dropout twice? Also, can we use nn.ReLU instead of f.ReLU in forward part? Hope someone can help me distinguish the same function for convolution dropout activation. When should I use nn.Module and when is nn.Functional better? All right. In PyTorch, you define your models as subclasses of torch.nn.Module. In the init function, you're supposed to initialize the layers you want to use. Unlike Keras, PyTorch goes more low level, and you have to specify the sizes of your network so that everything matches. In the forward method, you specify the connections of your layers. This means that you will use the layers you already initialized in order to reuse the same layers for each forward pass of data you make. Torch.nn.Functional contains some useful functions like activation function on a convolution operation functions, a convolution operation you can use. However, these are not full layers, so you want to specify a layer of any kind. You should. So basically, torch.nn.Functional has things without parameters, right? Torch.nn.Module, that's nn basically have everything related to neural networks. So nn.Functional is just for functions, essentially without parameters. You would use the torch.nn.Functional conv operator to define a custom layer, for example, with a convolution operation, but not to define a standard convolutional layer. Let me know if it is clear. I feel like that didn't really explain if, so for example, let's say the ReLU. Should I do f.ReLU or nn.ReLU? Should I do f.dropout or nn.dropout? Should be clear, like which one should be used as default. Although nn.dropout is not a trainable layer, it is still an nn module, so you should initialize it in init first and then use it. I think it will raise an error otherwise. And I think perhaps there will be some answers to explain this as well. But I think nn.dropout, if you use f.dropout, so the functional package, then you would need to specify if the network is training or not. If you and also you wouldn't use to you would need to use it after you would need to do f.dropout for every time you want to do it. If you define a dropout layer and you use the same, you specify the dropout rate, and you want to reuse that one, you can just send it through the exact same that you defined. And also from the nn module, it's gonna know if the model is in training or evaluation mode. So you don't need to do something like this, f.dropout and then self.training. You wouldn't have to do anything like that. Hi, I've just tried to modify codes and no error were raised. From model.name.Module, I can see the difference of these two networks. There is a dropout layer missing, but both network models works and should be the same. Didn't really understand where that came from. I mean, he changed something here, right? All right, let's just continue. I'm just guessing here, but I would say based on the documentation that only nn.dropout changes the behavior when doing model.eval and model.train, while f.dropout is a standard dropout operation. You should probably keep using nn.dropout. Yeah, that's what I've read as well, and that's the reason I always use nn.dropout. Just another point here, a nn module is example A. I'm not sure what that is. OO wrapper around the functional interface that contains a number of utility function methods like eval and parameters, and it automatically creates the parameters of the modules for you. You can use the functional interface whenever you want, but that requires you to define the weights by hand. Okay, so if you use an nn module, it has a number of utility methods, which functional doesn't have. nn.dropout is exactly the layers needed to be added into the neural network, while functional.dropout will not behave different in train and evaluation mode. Yeah. But for ReLU, I guess you could use either, since it doesn't depend on the mode of the model. I tend to always use ReLU, nn.ReLU, simply because I feel if I can use a single package and I don't have to include nn.Functional, if I don't have to, then I feel that's simpler in a way, just having everything in a single package. It seems using existing nn modules is a better choice for building networks, while nn.Functional are basic building blocks of those layers. If some custom layers need to be defined, then nn.Functional may be used. Yeah. That makes sense. You can have the functional dropout be aware of training, by doing training equals self.training. Your comment is very important. Would it be correct to say that you don't need your layer parameters to be optimized? If you don't need your layer parameters to be optimized, define them using the functional class. That can be done manually as well. For things that do not change, like sigma, ReLU, 10H, I think it makes sense to use functional. For others, like dropout, I think it's better not to use functional and use the module such that you get the expected behavior. Yeah, but I also feel that I don't feel there's any harm to doing nn.ReLU. And the only argument I have for why I want to do it that way is I want to use a single package. So if I can use nn.ReLU, nn.sigmoid, everything through the nn module, then that seems as a cleaner way to do it, rather than including the functional package. But with that said, I think nn.Functional has a lot of additional functions that nn.Module does not have, right? And you would probably, if there would probably be cases where you can't choose, right? I'm just saying, if you can choose, I like to use nn. All right, he says, you can use the function API. I haven't worked with training eval by doing the training equals self.training. However, as the usual advice goes, I think it's clearer to use modules for stateful function. In this case, dropout can be considered stateful because of this flag, functional for everything else. And yeah, so I guess I'll disregard what I just said. If this guy says use a functional, then I should probably start using functional as well. I mean, I don't know why I haven't. I think it's just a habit of using, if I can't use nn. But yeah, everything doesn't actually depend on the model state in the evaluation or so on. Then we can use functional, it seems, or that seems to be the default go-to. Yeah, so the module of PyTorch is built on top of functional. So there is a bit more overhead, but it is completely dwarfed by the time spent on computing linear convolutions, RNN. We're speaking into seconds versus minutes, hours, days here. Yeah, all right. So yeah, I mean, that's perhaps why you why the advice is to use a functional if you can. Yeah, I feel like we understood the question. So let's go back. And another question: how to perform fine-tuning in PyTorch? Can anyone tell me how to do fine-tuning in PyTorch? Suppose I have loaded the Resident 18 pre-trained. Now I want to fine-tune it on my own dataset, which contains, say, 10 classes. How to remove the output layer and change it to as per my requirement? And I have some ideas on this, but let's read the answers. You can find an example at the bottom of this section. Should we check that? All right, let's check it. At the bottom. Yeah, no, we'll go back. I don't want to read this entire thing. I have another doubt. While fine-tuning, should we not use a smaller learning rate for the whole network? Here the example says us to fix the network and only learn the weights in the newly added layers. Which one is recommended? Okay, so in that snippet, the only last layer is optimized so that the rest will be frozen. I mean, should we read that one then? Feels like. Yeah, okay, so he loaded, okay, here it was. He loaded the model. He does a pre-train. He goes through each model parameters. He sets requires gradient to be false. And then he does model.fully connected. And that's, yeah, so there's a fully connected layer associated with Resident 18. And what it does here is he's just going to replace the last fully connected. So instead of going 512 to 1000 as an ImageNet, let's say we just have 100 classes. And yeah, so everything else is frozen here. And I guess this would also work if you wouldn't want to freeze the other ones. You could still just replace the last one. All right, so here he's asking, is there a way of defining different learning rates to different layers? That's an interesting question. Or is there any other optimized way to do it? And he says this should do it. Ignore parameters. Yeah, this is a little bit complicated, but yeah. All right, so that's just interesting to know that you can do it. Yeah, let's not go into that in depth. This may also help to learn how to modify layers without changing. By the way, am I recording? Yeah. All right, great. This may also help to learn how to modify layers without changing other layers' parameters and construct a new model. Yeah. That's interesting. You can also do model dot, you can do model as a list of a model dot classifier dot children. And you can do model.pop because it's a list, and then append, and then you can do torch and then sequential. All right. Guess you can do that, yeah. As for fine tuning, it's more easy. Yeah, you can just do it that way. That's the exact same case. How do I add new layers to existing pre-trained models? Here the last layer by name is replaced by a linear. How to add another flat linear after that? So you could do, yeah, my model, you just create a new class and then create layer and you would, yeah, you could do something like nn.Sequential there or anything so that you just, you first run through the pre-trained model and then run through the, and some additional layers. And that's probably how you would fine tune as well. You would add a few layers at the end, and they would freeze the entire thing so that you sort of view it as the as in initialization essentially to your model. And so you would create your model something like this, and then you would just run it through the pre-trained model first to extract relevant features and so on, and then you would run it through the last layer, and you would only actually optimize those last linear, or I mean, not linear, those last layers. Another question, I am not able to see classifier attribute when loading a pre-trained ResNet 18. However, I can directly access the children attribute without needing classifier. Is the classifier attribute part of an old version of PyTorch, or am I missing something? ResNets don't have a classifier attribute. They only use a single fully connected layer, and it's available as their FC attribute. Okay. Yeah, so ResNet has an FC attribute. Some might have a .classifier attribute instead. But this kind of depends on how they created the model. May you add a more complete example to illustrate how to fine-tune VGG on a custom dataset? But I feel like this is pretty clear, right? How you would do it is you would just create your layers in that class, and then you would run it through the pre-trained model, which you have set all of the gradients to 0. Essentially you've set it to evaluation mode, and then run it through your model so that you have, yeah, and then your model could be multiple layers. It could be 1, 2, how many layers you want. So I feel that kind of makes sense. And we don't have to check that pull request. Yeah, and then they went into some specific examples of, but I think we got the gist. So let's move on. Understanding transform.Normalize. Hi all, I'm trying to understand the values that we pass to the transform.Normalize. For example, the very scene 0.5, 0.5, 0.5, and then again 0.5. So I actually can try to explain this, and let's see how my explanation compares to the answers. So you would normally have 3 channels, right? This is R, G, B, and the first list that you send in, or I guess in this case the tuple, you can send in a tuple or a list, that would be the mean values, and then the next list would be the standard deviations. So this would be the mean value for that specific channel, which is the red channel in this case. So what this does is it's going to take the input and it's going to subtract it by 0.5, and then it's going to divide that by 0.5. And so essentially, if you know some statistics, and what this would do is it would make it 0 mean and 1 standard deviation. So, and that has been, shown empirically to give pretty good results and lend to faster training and so on if the data set is 0 mean and standard deviation of 1. Let's see, is there anything else to say here? And of course, these values here. Oh, right. So first of all, before you run it through this, you would probably do 2 tensor, and 2 tensor actually divides by 255. So, normally you would have values between 0 and 255 for each pixel value. When you do it to a tensor, it's going to be normalized by just division by 255, and that's why you would normally see this right here as subtracting by 0.5 by default, so that these are sort of the default values. That's because you run it through 2 tensor first and then run it through this one. Anyways, that was just my thoughts on it, and let's see if I'm correct or if there are better answers on it. Is that the distribution we want our channels to follow, or is that the mean and the variance we want to use to perform the normalization operation? If the latter, after that step, we should get values in the range of -1 to 1. Yeah. Is this for the CNN to perform better? If we want to visualize, however, one sample image on matplotlib, we need to perform the required transformation, right? Is there a way I can get my values in the range 0, 1? Will that reduce? All right, let's just see the answers. Normalize, and is that the answer? In that one right here, yeah. So normalize does the following for each channel. It's going to take the image, it's going to subtract the mean, and it's going to do the standard deviation for each channel. The parameter mean, standard deviation are passed as 0.5, 0.5 in your case. This will normalize the image in the range -1 to 1. For example, the minimum value 0 will be converted to -1. The maximum value 1 will be converted to 1. And yeah, so why the minimum is 0 and the maximum is 1 is because 2 tensor divides by 255. If you would like to get your image back in the 0, 1 range, you could use image. Yeah, okay, you can do that. About whatever it helps in and to learn faster, I'm not sure, but majority of the papers I read employ some normalization scheme. And yeah, so I'm assuming it does, right? Otherwise, there's no reason why we would do it. Or actually, sorry, not learn better, but perhaps learn faster. So better or faster, I guess those are 2 different things. It might improve the speed at which it learns, but it might not improve the total the accuracy after training, so to speak. So answer above question: yes, normalization does help CNN perform better. Normalization helps to get it within the range and reduces the skewness, which helps learn faster and better. Yeah, all right. Is there a sequence? The mean value of image is generally in the range 127.5, but you wouldn't do this because you would do it to a tensor first. So, but let's see if they answer that question. There are 3 parameters written twice. I recently started Python with deep learning, so it's confusing to me. As you mentioned, it is defined as the mean and standard deviation. Then it should to mention 0.5, 0.5. Oh, okay. Yeah, so it's confusing. The first is for the mean here for each channel RGB, and the second is for the standard deviation. Why do we have 3 values? What's the third 0.5 shows? And secondly, why we have these values twice? All right, if you read documentation, you will see that both parameters are sequences for each channel. Color images have 3 channels, red, green, blue. Therefore, you need 3 parameters to normalize each channel. The first tuple, 0.5, 0.5, 0.5, is the mean for all 3 channels, and the second is the standard deviation for all 3 channels. But why minus 1 to 1 when a transformation was already applied on a normalized set of 0 to 1? And this is well explained by above. It depends which normalization method you are using. Using normalization transform mentioned above, it will transform data set into normalized minus 1 to 1. If data is already in the range 0, 1 and normalized, you can choose to skip normalization in transformation. Yeah, I guess, yeah, you can choose, but doing it in this range has benefits in that it's been shown empirically, and I can't cite the papers, but they've shown that it should make the network at least learn faster. All right. And so, of course, using 0.5 and 0.5, I don't know if I said this before, but using 0.5 and 0.5, that would as a good default, I guess that works, but you would obviously want to check this for your specific data set. So you would send in some data and you would compute what is the mean for this channel, what is the standard deviation for this channel, and that would make sure that it's exactly the correct value, so that you actually get 0 mean and standard deviation 1. Yeah. Yeah, and he kind of summarizes. He says, for image sensor with value 0, 1, the transformation will standardize it so that is the mean of data should be 0 and standard deviation 1. This is also known as standard score or Z-score in the literature and usually helps your training. Yeah. Yeah, let's move on. What is the proper way to do gradient clipping? All right, that's an interesting question. So, I mean, you would normally do gradient clipping. I've seen it used a lot with RNNs and sequence models in general. Not really sure why it's more common with RNNs than with anything else, but that's the scenario where I've seen it used the most. Anyways, is there a proper way to do gradient clipping? For example, with Atom, it seems like the value of variable.data.grad should be manipulated, clip before calling optimizer.step. I think the value of variable.data.grad can be modified in place to do gradient clipping. Is it safe to do? Also, is the reason that Autograd RNN cells have separated biases for input to hidden and hidden to hidden? I think this is redundant and has some overhead. Man, all right. Aren't those like 2 completely different questions? But let's stick with the first one. You can safely modify variable.grad.data in place after the backward pass finishes. The reason for that is that it has a nice user-facing API where you have both weight tensors exposed Also, it opens up a possibility of doing batch matrix multiply on the input for all steps and then applying the hidden to hidden weights. If you measure the overhead and prove to us that it can be implemented in a clean and fast way, we'll happily accept a PR or change for it. All right. I have tested nn LSTMs. Found almost no difference in the performance. Maybe I overestimated the overhead of the additional addition with simple guess. Thank you. All right, let's see if we get some more, because these are answers from 2017, and I've seen other methods to do it, and so I'm hoping they can explain those methods as well, because I remember doing something which clips if the norm of the gradients are large, and yeah, so that hopefully we can see some sort of straightforward method on how to do that. Let's see. Yeah, so this is how you would go through all of the parameters, and you would do okay. So you would go through the gradients of each data. I mean the gradient of each parameter, and then clip it if it's too large. I'm sorry, but I don't understand the question. Optimizer never calls backward itself unless you give it some callable argument. See torch up for more details on that. By the way, you might want to use torch.nn.utils.clip grad norm now. Yeah, and that's the one I used and felt pretty straightforward. It's just one line, and it's gonna go through every parameter in the model. So then maybe I'm doing something wrong by using gradient clipping, but I think if you use this one, you don't have to use that one. But yeah, makes my network train much slower than with optimizer.step. Maybe you're clipping them to very small values. It's a possible effect. All right. Anyways, just use for people trying to get an answer quickly. Yeah, just use this. nn.utils clip grad norm. Send in your parameters, and then the clip value that you want to clip it to. Or in place clamp, you can do grad data.clamp, and you can just do -clip to clip. But then you would have to do for loop to iterate through all of the model parameters. Yeah, let's move on. Detach, no grad, and requires grad. This should be the same. Haven't we gone through this? Let's see. Hello, it's a general question, but currently I'm looking at tutorial for reinforcement learning. Why in optimized model function we have detach, and in selection we use with torch.nograd. Okay, but so all right. Okay, so this is different because yeah, detach will just detach a single tensor, right? And this would do all of the computation with not requiring gradient. All right, let's see the answer. And does this post answer your question? Yeah, exactly. That's the one we looked at. That's the one I was thinking about. But let's see. Is this question a bit different? Because I feel like this could be different. In that one, let's see the other one again. I can feel this question is a bit different. So let's see what he says. This answer you mentioned helped me understand the general idea, but I still don't understand the difference between torch.nograd and detach. Can I use it exchangeably, or are there any limitations? Can you use detach on an entire model? Detach detaches the output from the computational graph, so no gradient will be back propagated through this variable. Torch.nograd says no operation should build a graph. Yeah. Yeah, and this is sort of how I view it as well. Detach will detach the specific object you want to detach. So a tensor, for example, or like a variable. But torch.nograd, that would mean that no operations are included. And you could, but I'm still wondering, can you detach the entire model? We could probably just Google that, but yeah, I still feel like we can understand it. So the difference is that one refers to the given. Yeah. Good explanation. Can you give us some use cases for both? I'm guessing you'd use torch.nograd during evaluation phase, but what would you use detach for? Torch.nograd, yes, you can use it in evaluation phase in general. Detach, on the other hand, should not be used if you're doing classic CNN-like architectures. It is usually used for more tricky operations. Detach is useful when you want to compute something that you can't or don't want to differentiate. Like, for example, if you're computing some indices from the output of the network, and then you want to use that to index a tensor. That indexing operation is not differentiable with respect to the indices. Yeah. Yeah, I think we understand the idea. Okay, so here's might be an interesting question. So what if you do .detach and then .clone on a tensor versus .clone and then detach? Are they the same? Let's think about this. They should be the same, right? If you detach it from the graph and then clone it, I feel like they should be the same. Yeah, all right. Let's move on to the next question. Efficient distance matrix computation. I have no idea what this question is. Efficient distance matrix. Okay. So like, all right. For the project I'm working on, I need to compute distance matrix over large batches of data. And we're going to compute the Euclidean distance. All right. So, I mean, this is not very interesting. We're going to skip this one. I mean, this is more like how you would optimize the, how would you do it in the most efficient way? And, yeah. But yeah, I also remember doing this when doing k-nearest neighbor. Then using an efficient implementation would calculate the Euclidean distance by the I don't know what this formula. I don't remember what this formula is called. Anyways, this formula right here. You could use that for matrices as well, and you could do it. You could utilize broadcasting and do it in a very, very efficient way, but can be quite tricky. Anyways, we're gonna skip that one. How does PyTorch freeze network in some layers and only use the rest for training? And I think this is a sort of a similar question as a previous one, but we can read it. Each parameter of the models have requires grad flag. For an example, in the doc, this loop will freeze all layers for a parameter in model parameters. Parameter that requires grad equals false. Yeah. That's how you can freeze it. But I also wonder, can you use .eval? Oh, I'm wondering whatever to set eval or for those frozen layers, since it may still update its running mean and running variance. Try this, reduce your learning rate drastically. Try viewing your gradients with respect to input and see if there's any place. Let's Google this. So model.eval, PyTorch, and then what is it that we wanted to check? Requires grad. Where's the search? Model.eval. Right. Eval. Sets the module in evaluation mode. This has any effect. This has an effect, I guess. This has an effect only on certain modules. See documentation of particular modules. Okay. So that eval doesn't actually. But I mean, evaluation mode should set it so that it doesn't obtain the gradients. Okay, but maybe so I remember reading this before, but maybe eval just my interpretation was that eval also freezes it. But yeah, that's obviously not the case then. Yeah. Right. So model.eval. Yeah, all right. So I'm actually not sure. But I guess, yeah, you could do it this way, and that would be the safe way. But I feel like if you could simply do model.eval before and then add some additional layers, but that would be fine tuning. But that would be pretty simple. Didn't I make a video on this? I feel like this should be something I should be able to. Transfer learning and fine tuning. Yeah, that's the way I did it as well. Yeah, we need to do param that requires grad equals false. All right, and that's what they said in this thread as well. All right, let's move on to the next one. What does torch.backends.cudnn.benchmark do? What's the difference when setting it to true or false? This flag allows you to enable the inbuilt Cuda auto tuner to find the best algorithm to use for your hardware. That's interesting. That's pretty cool. And I guess this is the true by default. All right. I mean, I haven't found anything that changes our opinion or from the first answer, so just trying to scan if there's anything that we might have missed. All right, interesting. I mean, this should be by default. I'm assuming, right? And one thing that would be interesting then, I mean, if you want to sort of be able to get the same results on another computer, you would probably, I don't know if that would impact anything. I'm just trying to think of use cases where you wouldn't want to use the benchmark equals true. But yeah, I think it's probably by default. All right. Understanding deep network visualize weights. Are there any existing implementation of understanding what it is learning in the networks? For example, weight visualization, deconvolution for visualization, gradient ascent, etc. Yeah. Okay. But I feel like there are, I mean, this should probably be a separate, this is a research area, I'm assuming, that they want to know and understand what are the neural networks actually learning. And you can do that by figuring out what each respective neuron is activated by. So if there's a certain color, if there are certain patterns in the image, if we're talking about images, or text, if for certain words they might activate and so on. But I feel like that's a separate thing from weight visualization, which might be used as a way to debug the model. If certain weights are not changing according to some curve or whatever, then that might be sort of flags indicating that there's something wrong with the implementation. So I sort of view those as two separate things. But are there any implementation of understanding what we're learning in the networks? Yeah, so this is from a long time ago. They use something called Wisdom, and you can do this now with TensorBoard. Yeah, and I have a video on TensorBoard as well, and in that one I show how you can visualize the weights. I'm just looking to see if people are mentioning TensorBoard, because I feel like this is done with the TensorBoard now. No. All right. All right, let's move on. DataLoader for various length of data. So I'm assuming this is text or something. I've been working on implementing a sequence model and try to use DataLoader to batch data following the data loading and processing tutorial. It seems DataLoader cannot handle various length of data. Yeah, it can't. So you would have to, the only variable that changes in the DataLoader is the number of examples in the batch, and everything else has to be the same. Because since I'm thinking that it concatenates along that dimension, and then everything else needs to be the same. And so the solution here is that you need to pad your input so that all of them are equal length. And that's probably the answers we're going to get. You could create a transformation that trims pads each sample to a specific length and then use padded sequence function. You need to customize your own data loader. What you need to is basically pad your variable length of input and torch.stack them together into a single tensor. This tensor will then be used as an input to your model. I think it's worth to mention that using padded sequence isn't absolutely necessary. Yeah, so I think padded sequence sort of lets your RNN know that these operations are now padded elements, and essentially, you know, they can skip those operations for those specific examples. But yeah, they aren't necessary, but can save on compute. But let's see. So the question that we're kind of wondering now is there a simple way to pad the sequences in a simple way? And there probably is. But the thing I've used so far, at least, is torch text, which does it for you. But it would be interesting to know how would you actually do it by yourself if you're not using torch text. Yeah. I meant to create your own dataset class and then do a transform to pad to a given length. An example of a custom dataset class below. The idea would be to add a transform to that which pads to tensors so that upon every call of getItem, the tensors are padded and thus the batch is all padded tensors. You could also have the getItem function return a third value, which is the original length of the tensor, so you can do masking. I was wondering if there's a more efficient way of padding sequences. The easiest way option is just to pad all sequences to the max length. Currently, I implement my own dataset object and use a transform that pads all sequences to the same length. But is there a way to do it per batch and not globally for the whole dataset? Yeah, I think you want to use the collate fn function in the DataLoader class. Yeah. Yeah, so there's a collate fn function that you can use, and not exactly sure how you use it, but I know that you can use this function. That's I've seen that used before. But yeah, and that would pad it per batch, which is how you would want to do it. You wouldn't want to, I mean, if most of your examples are length 10, and then you have one example which is length 10,000, you wouldn't want to pad every example to 10,000 if most batches are just 10 in length. Yeah, then you would just want to pad according to the maximum length in the batch. All right, and you can use this. All right. Yeah, I mean, to really understand this, I would kind of have to go deeper explore the collate fn function in more detail and do some examples on it. But at least we know sort of what to do. We just don't know how to do it. And in many cases, that's how it's going to be when we read these posts. We understand, okay, that a rough guideline, and then you would need to spend some more time on the exact implementation and perhaps read this implementation and then spend some time on it. And it seems like you can create your custom collate function, and you would do something like pack the sequence there. You would return the data and the targets, and you would just in your data loader do call it fn and then send in your function right there. And I'm assuming that would get the batch, send them through the call it function, and then that's what you return from the data loader. But yeah, that's sort of how you would do it. Yeah, I can perhaps, I mean, I'm probably gonna do more of these things in the future. I feel torch text is a good start, but I also feel I can see the lacking parts of torch text. So learning to do this by yourself is probably a good thing. Okay, the next one is runtime error, trying to backward through the graph a second time, but the buffers have already been freed. Specify reaching graph equals true when calling backward the first time. Yeah, okay, so this is the this is an error, and I'm not sure if I have had this error before. Yeah. Let's try to understand this. He's had some train iteration. He is doing some prediction, is doing 0 grad, calculating the loss function, and he does want to do loss.backwards. To reduce memory usage during the backward call, all the intermediary results are depleted when they're not needed anymore. Hence, if you try to call backward again, the intermediary results don't exist and the backward pass cannot be performed. You can call backward retain graph equals true to make a backward pass that will not delete intermediary results. And so you will be able to call dot backward again, all but the last call. Trying to backward through the graph a second time, but the buffers have already been freed. Specify retain graph equals true. To reduce memory usage during the backward call, all the intermediary results are deleted when they're not needed anymore. I mean, that makes sense, but is he calling it 2 times? Let's read the question. I keep running into this error. Can someone explain what it means? Context, it happens the second time I call loss.backwards in a function where the model's function execute one step of a recurrent neural network, which updates its hidden state in the forward pass. This is still unclear to me and may impact my particular use case. To demonstrate, I'm building a very simple recurrent neural network, one node, and unrolling it for training. At the start of each gradient descent iteration, I need to reset the output estimate vector to initial values. I want to do this in an efficient way that doesn't require allocating new GPU memory. Yeah, this is This is a bit advanced for me. I don't know. I don't understand what this buffer, what this what we refer to when we say buffer. I'm gonna have to skip this question, to be honest. I don't understand what they're asking, but it seems to be a very common question, so probably spend some time to learn what buffers mean. Print Autograd graph. Is there a way to visualize the graph similar to what TensorFlow offers? And now you can use TensorBoard and visualize the model as well. So yeah, there will be a TensorBoard integration in the future, and they've done that. So let's just scroll and see. I'm just looking at the time, so we should probably. So I mean, in this case, they're using custom tools that someone's built, but you can actually use it. Yeah, you can use TensorBoard for visualization. TensorBoard is now fully supported in PyTorch version 1.2.0, and yeah, that's you can just do .build graph. I have an example on it on my GitHub, but it's pretty simple. I can actually show you. So we can go back here, and we can do TensorBoard. And let's see here. So you have your you first have your writer. You first define your writer right here, which is a summary writer, and then you just do writer.add graph model, and then you send in some example. So here I just take a single batch and image this.toDevice, and then that would give the graph for you. Yeah. Next question. How can we release GPU memory cache? And again, hopefully I can understand this, because these questions have been difficult for me so far. I would like to do a hyperparameter search, so I train and evaluate all of the combinations of parameters. But watching NVIDIA SMI memory usage, I found that GPU memory usage value slightly increased each after a hyperparameter trial after several times of trials. Finally, I got Cuda Out of Memory. All right. Hi, torch.cuda.emptycache, edited fixed function name, will release all the GPU memory cache that can be freed. If after calling it you have some memory that is used, that means that you have a Python variable, either torch.tensor or variable that reference it, and so it cannot be safely released as you can still access it. Yeah, okay. You should make sure that you're not holding on to some objects in your code that just grow bigger and bigger with each loop in your search. Yeah, that makes sense. So you would kind of check which variables am I actually using, print those shapes, and see are they increasing or decreasing. And the next step is figure out why are they doing that. And maybe you can do Cuda empty cache first, and you can sort of in some way print everything that's in memory and see which ones are still there. I don't know. Really, I don't have any idea of this, but that's just, I'm just thinking out loud, basically. So the variables no longer referenced will be freed using torch.cuda empty cache write. And I started to locate the memory consuming object, but I couldn't locate what variables gave me a bad effect. So any variable that is no longer referenced is freed in the sense that its memory can now be used to create new tensors. But this memory is not released to the OS, so will look like it's used using NVIDIA SMI. Empty cache forces the allocator that PyTorch uses to release to the OS any memory that is kept to allocate new tensors. So it will make a visible change while looking at NVIDIA SMI, but in reality, this memory was already available to allocate new tensors. Right. Yeah, and this is an interesting point as well, in that we shouldn't use loss.data. That we saw that in another post. We should use loss.item instead. And I don't think they actually said what to, all we learned from that previous post is that loss.data is bad. And here an example is that we can use loss.item instead. Yeah. Again, I haven't really encountered that many problems using this. I mean, these memory problems, in that we have variables that are sort of stacking up and taking up more and more memory, and then finally we get this error. Yeah, I wish I would have had more of those errors so I can sort of share my thoughts. But yeah, let's move on to the next question. Convert int to one hot format. Hi all, I am trying to convert the Y labels in MNIST data into one hot format. Yeah. Okay, so now he does it in now he just does it using NumPy one hot, and then does torch from NumPy, but there should be a PyTorch way. Yeah. It depends on your loss function, but some PyTorch loss function takes class labels as their targets, and then NLL loss. So if you use them, you don't need to convert targets into one hot vectors. And yeah, that's actually an interesting point, because I don't convert to one hot encodings or one hot vectors very often, or rarely. I mean, there are most likely a lot of examples of where you want to do that. I'm just saying, in my experience, I haven't done that because these loss functions are so good that you don't have to do any of them. And actually, like if you do cross entropy loss, for example, you don't even have to do softmax as your output of the network. The softmax is already is computed inside the cross entropy loss and stuff like that. So PyTorch loss functions really they do a lot of work for you, and you don't need to do that much thinking. But yeah, thanks for advice. I have seen such examples in the examples branch. However, I use such Y as input so that can't solve my case. All right, so let's see. Maybe he's saying that his Y is already one hot vectors. And then he would need. All right. You can use the scatter method to achieve this. I would also advise to create the one hot vector tensor once and then just fill it. Let's say batch size is 5, number of digits is 10. it has to be 2D for the scatter with batch size on 1. Okay, so that's the target labels, and then you would do one hot, you would initialize that as well, and then you would do scatter, right? That's one way you could do it. I'm not sure exactly how scatter works, but I mean, he says that it works, so it probably works. Perhaps, since this was in 2017, if we scroll down, perhaps there is a one-hot encoding, one-hot encoding layer in PyTorch now. All right, and then someone comments, just a note, from my understanding, it is not advised to follow this approach of creating the variable and then filling it each time. And also for future readers, just to reiterate what cross entropy and negative loss like losing parts do not require one-hot encodings, so you can just use the normal target vector. Yeah, and that's sort of what I said as well, in that I rarely do these things. Or I've never actually done these things. All right, and yeah, so they're still talking about the scatter. And here someone creates a function that you can use do one-hot encodings of some input y. Yeah, we don't have to go in depth on how that's done. Yeah, and this feels like a very, I mean, this implementation I feel is kind of clean, in that you do torch.I of the number of classes, and then you just return y and then index those labels. And yeah, I like this implementation, but it might not be efficient. I'm not sure. Yeah, it might not be efficient. But yeah, anyways, that's clean. I mean, it looks clean. As the reply suggests, this is not a good method, since you might need to create large weight matrices every time and store it in memory. Yeah. All right, so it might not be efficient. I'm not sure why it wouldn't be efficient, but you can also do this. That doesn't look as clean as the other code we saw, but all right, finally, torch.nn.Functional one-hot has been added. So that was a long way of saying just use functional one-hot. And I mean, that's kind of the thing that's nice when reading such old posts. We'll see the gradual improvement, and in this case, it seems quite nice. All right, let's go to the next question. How do I check the number of parameters of a model? When I create a PyTorch model, how do I print the number of trainable parameters? They have such feature in Keras, but I don't know how to do it in PyTorch. All right, for parameter in modular parameters, print parameter. But that just prints the parameter. It doesn't print the number, right? Okay, so let's just see two replies. How does one make sure that model parameter is not empty? It seems to be empty for me. Can I see what you're trying to do? The parameter should not be empty unless you have something like yeah, I'm not sure either. It should have parameters, but yeah, okay, so you would, yeah, exactly. So to check the number of parameters, you would have to do something like this, although there should be probably a cleaner ways of doing it. But you could go through in list of model parameters. You can do for each in that size and times it. Oh yeah. Yeah, because it's yeah, that makes sense. Yeah, it's going to be multiplied since if you have a linear layer or something like that and you have 10 to 10, you're going to have 10 by 10, 10 times 10, so 100 parameters. And then you will return pp. And yeah. All right, to compute the number of trainable parameters, model parameters is filter lambda p, p requires grad model.parameters. All right, so you would take the one that requires gradients because those are the trainable parameters. Then you would do sum of numpy product p size for p model parameters. There should probably use, you can use torch.prod here, I think. But yeah, this seems like a nice one. To add my 50 cents, I would use numal instead of np.prod. Yeah, that's a lot cleaner. Yeah, I like this one. So this is how you would do it. Return sum of p.numal. Numal, if you watched my Tensor tutorial, you know that's checking the total number of parameters in that tensor, and then you would just go through each model parameters, and then you would just check if it requires gradients. Then those are the trainable parameters. Yeah, this was a nice one. All right, let's go to the next one. What is the difference between register buffer and register parameter? Oh, I don't like these questions. Register buffer. I don't understand what a buffer is. I was reading the code of mask RCNN to see how they fix their batch norm parameters. I noticed that they use self-register buffer to create the weight and bias, while in the PyTorch batch norm definition, self.register parameter is used when affine equals true. I'm gonna skip this one. I've never encountered anything of this kind. So when you would actually need to register some parameters, yeah, I'm gonna skip this one. Next one. How to extract features of an image from a trained model. So does this mean just sending in an image and then just taking the specific features from a specific conv layer or something like that. Let's see. I try examples of ImageNet, of PyTorch. You can use the torch vision models. Let's see. What was this question actually? How can I use the forward method to get a feature like FC7 layers output of AlexNet of an image with this model? I think you can just print model and then just index it as it were a list, and you would get, well, actually, yeah, you would need, for that specific input, you want to get the output. That might be, yeah, let's see what they say. And you get, so you can do models resnet pretrain equals true. Yeah, that's a simpler way than doing with the model and load the specific state dictionary. To complement, once you have a train model, if you want to extract the results of an intermediate, you have a couple of possibilities. You can either reconstruct the classifier once the model was instantiated, as in the following example. So he loads AlexNet. He removes the last fully connected by doing nn.Sequential of, all right, a list of the classifiers and then children, and then takes up all to -1, so that doesn't include the last one. All right. Shouldn't you also just be able to index in that model as if it were a list, and then just don't include that last layer, that last fully connected layer? Maybe there's some point to doing this. Let's see if they improve on this answer. Or instead, if you want to extract other parts, you might need to recreate the model. Yeah, and then you stop at conv4. All right. Thank you guys so much. Is there a way to get value from multiple layers with one forward pass for neural style transfer, etc.? Yeah, that's interesting, because I just did neural style transfer, and what I did is I then reconstructed the network by creating a class, then loading that pre-trained model, going through each in a loop, and checking if this is this layer a specific layer that I want, then take out the features of that one. But let's see if there are other ways of doing it. And I can show you just exactly what I mean. Here. And if we go to neural style transfer, right here, I reconstruct the VGG model, and I take self.model is models VGG19, and then I have some chosen features that I want to extract, and I go through. Here I did layer number in enumerate self.model and just send through that layer, and then check if string of this layer is in self.chosen features, then append those append that X to features, which is an empty list. And that's one way. That is one way how you could do it. But I'd be curious to know, are there other ways that's better? And we can see what they say. Yes, it's possible and very easy in PyTorch. All you need is to return the multiple outputs that you want to retrieve. I mean, yeah, that's pretty much what I did, kind of. Is there a convenient way to fetch the intermediate values? Is there a convenient way to fetch intermediate values when the forward behavior is defined by nn.Sequential? Seems like right now the only way to compose multiple responses would be to split of all the individual layers and forward the values manually in forward. Yeah. This is the way I did it. Yeah. Essentially, what I want to do is take an existing network, e.g., for example, VDG, and just pick some responses of some layers and concatenate them into a feature vector. And I think you would have to do what you said here. At least that's what I needed to do. You could write your own sequential version that keeps track of all intermediate results in a list. Something like selective sequential. This is also interesting. So you can do something like self.module iter items, and then you will get the name rather than what I did in enumerate. And this would probably be a more general way of doing it. Another way to extract features layer by layer of pre-existing neural network is to recreate a new network, adding one by one all the layers from the pre-trained plus some transparent layers, then just extract features. Yeah. So model.AlexNet, take the and you would go through, you have some specific ones you want, and you do for layer in list of CNN if it's come to the, and then you would do, yeah, okay. But I feel like, yeah, sure, you can do it that way. Feels like there should be a simpler way, so I wouldn't want to. Yeah, let's see what this says. I wouldn't recommend that. It's better to keep your model stateless, I not hold any of the intermediate states. Where does it do that though? Yeah, I'm not sure. All I saw here is that this didn't look very clean, so I wouldn't recommend that. Otherwise, you don't not hold any of the intermediate states. Otherwise, if you don't pay enough attention to them, you might end up with problems where you'll have references to the graph you don't need, and they will only be taking up memory. If you really want to do something like that, I'd recommend this feature extractor, and you would, for name, module and self submodule, and then module items, x of module, if name in self extracted layers, outputs, yeah. That looks good. This is still from 2017, so they're probably done changes since then, so we should probably keep on reading. And all is well for simple networks like AlexNet, but what if I want to use something a bit more fancy like ResNet, and I wish to extract some intermediate representation? I can fetch the model with torch vision.model.resnet18, and then pretrain equals true. I think the graph can be reconstructed by forwarding a variable. Let's see. Can we get to these hooks? And I feel like this feels like a bit more advanced for me, so let's see. Yeah. At least I know what I need to learn. These register hooks, and they're really, I don't understand anything about them, so I'll just ignore them for now. Yeah, let's move on. All right, I think I'll take a break and let's see where we were. We were on this one. So next thing we're gonna try to figure out is how to build your own loss functions in PyTorch. I'll take a break and I'll come back in a few minutes. So build your own loss functions in PyTorch. So I started using PyTorch today, and it seems to be more natural than TensorFlow. However, I would need to write a customized loss function. While it would be nice to be able to write any loss function, my loss is a bit specific. All right, so how do we write a custom loss function? You don't have to write any Lua code when you're using PyTorch. The gradients will be computed automatically. Let's see a second question. Can the gradients of this be computed in an automatic way? Can a loss function be given as input in optim.s to an optimizer? And 2, yes, the gradients will be computed automatically as long as you use variables all the time without any .data unpacking or NumPy conversions. It won't work in your example because you're doing calculations on NumPy arrays. All right, so if you're using torch variables, then it's gonna be automatically tracked with Autograd. And 3, optimizers don't need to know anything about your loss. The only thing you need to call is .backward of the loss on the loss variable so that they can see the gradient. And this is sort of his for his specific use for his specific example. So he says, I rewrote everything using torch now, so it should work if I use loss.backward. Advices about writing my own Autograd function and or computing the similarity more efficiently are very welcome. It is definitely something that I need to do later, but for now, I need just a simple version of this working. It looks like that it works by rewriting the final function as so he's using variable, he's using torch sum multiply, torch sum, yeah. And that's his customized loss. All right, and he says, no, this will not work. As I said, if you want your computation to be compatible with Autograd, it needs to be executed on variables from the start onto the very end. All right, yeah, so you can't use this similarity matrix. In your snippet, no grad will be sent to X and Y because the backward will end on X similarity and associate they are graph leaves, their dot creator is none. If you want to operate on raw tensors and have them wrapped in variables in a way that ensures connectivity, you have to write a new function. Otherwise, you have to pass in variables to your similarity matrix, but it might be very slow like that. I think that I got lost. and he tried. So essentially he tried to write everything in variables. We're given x and y, which are variables to the function, and then everything is done in variables. All right. All right, let's see what he did then right here. Yeah, so in his similarity matrix here, he didn't just use tensors. He had for loops and all of that stuff, which I guess won't be tracked by Autograd if he does his own customized loss. So, but he can rewrite it using something like that, which only uses the inbuilt functions. If you're not backpropagating through y, there's no need to wrap it all in variables, just wrap the last result. All right, so now the post is becoming more of his specific example that he wants to solve rather than the idea of building your own loss functions in PyTorch. But the general idea seems to be that you need to wrap everything using torch tensors and basically inbuilt functions. And then you don't have to create your own backward function. You would then just use Autograd and everything would be good. Yeah, and again, this is his specific example, which we're not that interested in. And these hooks, which I'm not really sure how they work. Let's try to Google that. What are hooks by Torch? Yeah, this is gonna take a lot more time than I thought, so I'm gonna have to do this at some other point. But yeah. Let's just try to see the overall goal that you're trying to accomplish. I mean, everything they're trying to do really is making everything using these tensor operations, it seems like, and they could probably make a tutorial on just in depth on how to actually build your own loss function, and you know, if you can't, so how if you can't use these variables and tensors inbuilt, how would you keep track of the backward and so on? I think we'll leave it at that. So, I mean, what you want to, I mean, I feel like this is a topic that could be explored in much more detail and could be presented in a nice tutorial that makes much more sense than following all of these things. But I mean, the basics is that use torch variables for everything, and just do loss.backwards on the final loss that you computed using your customized loss function. Yeah. Next, how are layer weights and biases initialized by default? So if we create a linear layer, let's say torch.nn.linear, how are the weights and biases for this layer initialized by default? Linear layers are initialized with 1 over square root of weight size, and then uniformly from that 1 over the square root of the weight size, and similarly for the bias. But yeah, can check that just quickly. So they have a linear class right here, and then where do they have? Yeah, they have it right here. Yeah, and this is a chiming initialization. So it seems like they're doing chiming, which is not exactly what he's doing here. It's very similar, but, or is it? Maybe that is the same, yeah. Yeah, I guess that's the same. You can also do Xavier initialization. Yeah, and this goes back to a previous post, pretty much, how to do weight initialization that we also looked at. So that's why I'm kind of skipping this right now, because this is pretty much exactly as the other post. But yeah, the question was which initialization do they use, and they seem to use chiming initialization, at least for the linear layers. But I guess that's also what they use for the others. And if you want to know how to choose it specifically for you, then you can go and check that other post for weight initialization. And we looked at that in a little bit more detail. All right, has this answer changed? Looking at the current linear, we see init chiming uniform. Where does the squared 5 come from? That's a good question. According to the source, it's supposed to be the negative slope of the activation function used after this layer, which makes no sense because square root of 5 is positive. Upon looking at it again, it seems to be for leaky ReLU. Still, square root 5 is positive, and I think most models still use ReLU. Not sure why this is how initialized by default. Yeah, that's a fair point. Let's see if they answer that. they didn't find any answers to that. Yeah. So it seems as if there might be some questions here too as why it's square root of 5, since that's not what they said in the original paper, and I don't remember doing this. When I initialized chiming, I don't remember doing any square root of 5, so yeah. So simple answer, they're doing chiming initialization, but with some small twist with doing this math.square root of 5. But yeah, pretty much chiming. And then next, how to normalize embedding vectors. Right? Hi, I'm using a network to embed some entity into vector space. As the length of the vector decreases during training, I want to normalize its length to 1 in the end of each step. Is there any tool I can use to normalize the embedding vectors? I think the best thing you can do is save the embedded indices and normalize the row manually after the update. I haven't seen people normalize embedding vectors. At least not when I've done it. So should you normalize them? If you want to normalize a vector as part of a model, this should do it. Assume Q is a tensor to be L2 normalized along dimension 1. We can do torch.norm, so we can find the norm, and then we can do .detach. We can divide by that one. Right. Can I use it to normalize the embedding after each update and training? Yes, it can be used to normalize an embedding. I suggest not using the detach, though. I found it degrades performance. All right, so not use the .detach here, just do torch.norm. But I mean, perhaps I'm missing something, but why would you want to normalize the embedding vectors? Does that make for better embeddings? All right, so it seems like you can do x.norm and then you need to do keep dims equals true on newer PyTorch versions. And now PyTorch has a normalize function, so you can just do f.normalize and then just choose the dimension. That's clean. All right, so it seems that you can use f.normalize. But again, I'm missing the overall idea of normalizing embedding vectors. I haven't encountered this idea. But that's, I guess, how you would normalize them. You would find a norm by using f.norm, and then you would divide by that. Next, adaptive learning rate. How do I change the learning rate of an optimizer during the training phase? You can use a learning rate scheduler for that. So I think that's what they're going to say. If you want to change the learning rate, we recommend reconstructing the optimizer with new parameters. Okay. Things move fast. So now we can do adjust learning rate. All right, so we have a function adjust learning rate. We're going to do learning rate is some decay with some depending on the number of epochs. So we decrease the learning rate as we increase the number of epochs, and then we just do for parameter group in optimizer the group. We do param group is set the new learning rate essentially. But again, this is an old way, I think. I mean, you could probably do this still, but normally we just use a scheduler. Let's see, learning rate decay is a common need during model training, right? So we don't have this in current PyTorch optim. As you recommend, I wonder reconstructing the optimizer with new parameters would bring in some performance overhead, although it would be very small compared to the whole training time. Creating optimizer is nearly free, especially that you do it at most once per epoch, and you only have a few epochs in job that take a number of days to complete. Don't optimize prematurely. However, if you create a new optimizer, the previous momentum or other states will be discarded, and that's true. So if you use Atom and you replace it with a new optimizer, that's going to be replaced. That's why we, for example, want to save the optimizer state dict so that we keep those. But that's the point. Maybe there's a good way to save current state of optimizer, call the constructor for optimizer with new value of learning rate and assign old states. In this case, we will have just a copy of old optimizer with learning rate adjusted. Keras provides two functions, which are fairly straightforward to implement, and everyone loves them. Reduce learning rate on plateau and early. So essentially, they have learning rate schedulers, and this is from 2017. They have implemented them since then, so we're probably gonna find later on in this thread. We are 11 out of 38 posts, so I'm just gonna scroll down a little bit until we find what we're looking for. I am also porting reduced learning rate on plateau. This should be pretty light and straightforward. I know that it is better to remain silent and be thought a fool than to speak and remove all doubt, but I still don't know how to save the optimizer internals along with the method so everything resumes as if nothing had happened. I would appreciate an answer with code. So this is really about how to save and load a model, and this is we saw this in a previous post. APR has been merged to implement learning rate schedulers, but it is not part of a release yet. For now, you can use the learning scheduler like this. Yeah, and that's pretty much like what we saw previously, and that you can do it in this way. And that makes sense. And yeah, and now you have learning rate schedulers in the latest versions of PyTorch. So you wouldn't have to use these functions right here. Yeah, and that's how you do it. So you can just Google the docs for learning rate schedulers. This was really an old post where they went through how to do it if you don't have those schedulers, if you want to create your own, essentially. Next question, what does the backward function do? And I feel like this is, we've covered this, but let's do it again, I guess. I have two networks. Let us say loss1 and loss2 represent the loss functions of the classifier's loss. Let's say the optimizer1, optimizer2 are optimizer of both networks. Net2 is a pre-trained network, and I want to backprop the gradients of the loss of net2 into net1. Some grade. Okay, that's a very confusing. I mean that doesn't have anything to do with the question. Well, I guess it has. It's like a more advanced use case of backward where you have. All right. So I do loss.backward retain graph. What happens when I write this? All right. So what happens when he does loss.backward of retain graph equals true, and then loss.backward and optimizer.step? What is the difference between backward and step? I mean, there are so many questions he's asking here, right? He's asking, what does the backward function do? He's asking, what if I use multiple loss functions? He's also asking, what is the difference between backward and step, which is an entirely, completely different thread, right? We saw that in the beginning, where they explained the difference between those two. Let's see. Okay, this seems like a good answer. Loss.backward compute for every the derivatives essentially for every parameter, which requires grad equals true. These are accumulated into x.grad for every parameter x in pseudocode. Yeah, so I mean this is if you use a parameter multiple times, then when you do the backward prop from the multivariate chain rule, you should add the gradients together. So that's where this comes from. Optimize.step updates the value of x using the gradient x.grad. Yeah, so optimize.step uses a gradient descent rule where you have computed these gradients and then does an update step. Optimize.0grad clears x.grad for every parameter x in the optimizer. It's important to call this before loss.backwards. Otherwise, you will accumulate the gradients for multiple passes. I mean, okay, so, I mean, this guy sort of, I feel like he understood that the guy was missing some basic information, and but I still think that this thing here, when retain graph equals true, exactly what happens could be explained in a little bit more detail. Yeah, and if you have multiple losses, you can sum them and just call backward once. And Autograd is going to know exactly what to do from this. Thanks for your illustration. I have one more question. Let's say I want to backprop loss3 into net1 and do not want to backprop loss2 to net2. In that case, I should not write let's say I want to backprop loss3 into net1. And do not want to backprop loss2 to net2. I don't understand this question. In case I have written loss2 to backwards and have not written optimizer to that step, will that affect my gradients when I compute loss3 backward? Yeah. So he didn't get a response. So I kind of understand why. I don't understand his question. Does backward update the weights if we do not use the optimizer? No. Just compute the gradients. Very clear explanation. If I have two losses, loss 1 get data from DataLoader 1 with batch size of 4, while loss 2 get data from loader 2 with batch size of 4, then what is batch size? What? I mean, it has nothing to do with the batch size, right? Loss will just be a scalar value, which are dependent upon some parameters that are built on that computational graph. And the only thing that's going to happen when we do this is we're going to try to optimize this loss and this loss separately. And so I guess it won't be anything associated with the batch size. The only thing that's going to happen when we have multiple batches is that we're going to get an average of the gradient step rather than, yeah. All right, 22 days later. No, it does not update, happens only when you call .step. I feel like these sorts of things are, I mean, it can be very hard asking questions when you don't really know. You don't really know what questions you want to ask, right? And this is sort of an example of this, I feel. And I mean, there's nothing. It can look strange when reading these sorts of questions because they are not. It feels like he's sure that it has something to do with the batch size, and I guess it does, but the loss doesn't have a batch size, so the question is sort of confusing, and no one answers it. But I don't feel like. I mean, I guess there's a way to ask good questions, but I also feel like if you don't even know what the question you want to ask, that can also be one of the most difficult parts. And then I guess your only way is to just ask what is on your mind, and hopefully that someone can help you out. And in some cases like this, no one can. And yeah, I don't know where I was going with that. Anyways. Okay, so now I was reading here that in the next, a fresh new graph is created and ready for back propagation. When exactly is the fresh new graph created? I'm guessing. I'm thinking. Not sure. It is created during the forward pass when you write something like criterion of model of input and target. The graph is accessible through loss grad fn and the chain of Autograd function object. The graph is used by loss.backward to compute gradients. Okay, so the computational graph is built when we run forward. Yeah, all right, let's move on. We've had a lot of questions about this backward and stuff, and I feel like there's been a lot of good answers to them. Next up, when to set pin memory to true. And this is an interesting question because I've had problems, or I've wondered about this as well. And I don't believe I've set it to true. I've just disregarded this argument. But this is a good question for optimization because probably if you use pin memory, it's going to be faster in some way. But let's figure it out. So in the ImageNet example, both data loaders set pin memory to true. Are there any good reasons to do this? If you load your samples in the data set on CPU, and that would be that's the common use case, right? You normally load the samples and do the pre-processing on the CPU. And would like to push it during training to the GPU, you can speed up the host to device transfer by enabling pin memory. Okay. So when we do the processing of the data on the CPU and want to push it to the GPU, we can do that faster by enabling pin memory equals true. I have no idea what pin memory does, but I mean, well, I have some idea, but I guess it's more, there's a lot under the hood, I guess, of such a function. But that's the good thing with abstraction, is that we don't really need to know the exact details. We just need to know, should we use it or not? This lets your data loader allocate the samples in page-locked memory, which speeds up the transfer. You can find more information on the NVIDIA blog. Thanks. This means pin memory should always be true if you're training on NVIDIA GPU, right? Generally, yes, if you're loading your data on the CPU. It won't work if your dataset is really small and you push it already on the GPU in the dataset, but that's pretty obvious. If I store the paths to my image in my dataset, as I can't fit my dataset into RAM, and only load images in the get item, is it still beneficial to use pin memory? Yes, as far as I know, that's the exact use case for speeding up the transfer between the host and device. All right, fair enough. That's a good answer. So we should use pin memory as true, as default. It seems like that's simplifies things. Surprisingly, I'm getting better speed up with pin memory equals false. Also, the CPU memory usage has been reduced by 2 or 3 folds with pin memory equals false. Just curious, what might be the reason? All right, something with the PyTorch version. All right. All right, and yeah, all right, that was the answer to the question. You should use it, and so this is some weird error. We're just gonna skip that. We're gonna go to the next one because it's not really a question. On a CPU device, how to load checkpoint saved on GPU device? That's an interesting question. I've seen examples of how to do this. I trained my network on a GPU. Loading this gave an error. Torch not compiled with Cuda enabled. You can remap the tensor location using the map location argument to torch.load. For example, this will forcefully remap everything onto CPU. Map location lambda storage location CPU, while this will only map storages from GPU 0. All right. Okay, so you can use a map location. You can use the map location argument, and you can set the location to the CPU. Someone tried this and he got an error. And okay, so he wrote map location lambda storage location storage. All right, out of curiosity, I'm not sure why that, I mean, the first one made sense because we use okay. So can you explain what this does? I'm not sure I would remap storage to CPU since the lambda returns the storage it got as an argument. Sure, map location can be either a dictionary or where the locations corresponding to keys are remapped to their values. Alternatively, we support passing in a function that will get a CPU storage and its serialized location, and it should Alternative, we support passing in a function that will get a CPU storage and its serialized location, and it should return some storage that will replace the CPU one. If you just want to load everything onto the CPU, you can just return the first argument, but you could do some more crazy stuff like sending all CUDA tensors to the next GPU. All right, this is a bit advanced for me. All right. And yeah, all right. I would need to do some more research on this and do some code and see how it works in more detail. But there seems to be a way to do it using this map location. You can perhaps scroll down and see. All right, that's interesting. So you can use map location, you can just set it to CPU. And you don't have to use the lambda. And that's interesting, which simplifies the argument call. So yeah, map location, set it to the CPU. That seems to be the answer. Next question. I'm sorry if that hurt your ears, by the way. I wasn't thinking. All right, anyways, multi-label classification in PyTorch. Hi everyone, I'm trying to use PyTorch for multi-label classification. Has anyone done this yet? I have a total of 505 target labels. Wow. And samples have multiple labels, varying number per sample. I tried to solve this by banalizing my labels by making the output for each sample a 505 length vector with 1 at start position I if it maps to label I and 0 if it doesn't. Then I tried to use multi-label margin loss. All right. Do you have a small data set? 505 might not just train well. Maybe add weight decay. All right. I used BC loss. It is stand for the multi. Let's I'm not familiar with this too much. Binary cross entropy. Okay. Oh, okay, yeah. So you could use the binary using it for 0 and 1. But I feel like this is he sort of fit his example to match this, and that maybe works, but there should be some other loss function, I feel like. Yeah, okay, so licensing number plate dataset. Then you would have multiple label classification. And you could use multi-label margin loss. Check that one as well. Remove all of these other tabs. So the multi-label margin loss. All right. Crazy criterion that optimize a multi-classification hinge loss, margin-based loss between input X So it takes the max of 0 and then 1 minus X of Yj of Y. All right, so the correct label I'm a little bit confusing what the indices are for. What are we looping through? I mean, if we're looping yj, yj must be for the number of classes, right? Or rather, the number of examples. So input is the number of examples, and C, number of examples and number of classes. And the target is okay, number of. Let's see the example, because I'm thinking the target is just one of those classes, right? Multi-label margin loss to float tensor for X. Target Y, only consider labels 3 and 0, not after label. Yeah, I would have to spend some more time on this loss function. But at least we know that it exists, and it's something that can be used for multi-label classification, or you could use that binary cross entropy and just create a long array with binary values. Yeah, I probably need to do some more research on loss functions, to be honest. I haven't done that many projects where I've had to use that many labels. So yeah, I feel like my knowledge in loss functions is kind of lacking. So I need to spend some more time on that. I might make a video on it if I feel like I understand it well. So yeah. So, writing some example. I mean, who's reading that? Whoa. Oh my God. Like, I mean, imagine like, you're like, all right, I've written a bunch of code. And by the way, if you watch my videos, don't do this. And you have a question for me or something like that, or anywhere else, to be honest. He just he prints. I mean, he writes the entire code for everything, which is, I mean, nobody got time for that. And then I'm stuck here. Wait, am I missing something? Is this for like some specific? All right. Anyways, I can't get multi-label, but yeah. I mean, so it seems to be a little bit tricky, and it felt like it could be tricky just reading the documentation. Yeah, I would need to do some more investigation on this. But yeah, so sorry for not giving that good of an answer on this one, or being able to interpret the explanations that well. Felt like it was a little bit all over the place. But yeah, this BCE loss, I understand that one. But I didn't understand the multi-label. We're still in 2017, so maybe there's a simpler way of doing it. All right, this is what I need. Here's a very simple dummy example. We have predict large for 5 classes. We have y, that is the correct label. No. Okay, so we have just a simple linear layer as for our model. We have some 20 features and we map it to 5 classes. Then we have y, 1 for each. Yeah, okay. We just have 1 and 0 if the class is active, and then we use the binary cross entropy with logit. I mean, that seems like a very that feels very, I guess, simple to use, and it makes sense. And that's the first example that we saw too. And I think, but I feel like there should be better ways also. And let's say that also if we have a class that can be multiple labels, so we don't just have 0 and 1, can we use, so that we have this here we have, for example, we have class A, and there can be class A. Yeah, okay, so I kind of, I understand it a little bit better now after thinking about it. So we would, for example, in the license plate example, we would need to choose, so for the first one, there can be A to Z, and then we would have all of those classes, and there can be one of them for the first one. But it being that specific, that being a specific character for the first in the license plate, that's a 0, 1 for each character. But it would be nice if there would be a way of just having the first one indicating sort of the license plate first character, and this value can be so A to Z, how many numbers that is, and then we can do that for each. And that would make it more compact instead of having, you know, how many he said above that we had when doing the license plate example. Anyone knows that if number of classes say up to 1 million labels, how to do multi-label classification? This is somehow the case in NLP. Not necessarily. I mean, in NLP, you're predicting sort of a word by word, and you have some vocabulary size, but it's never a million. You're just predicting one word. Given the translated, if we're using translation as an example, given the translated sentence so far, we're just predicting the next word, and that will just depend on the vocabulary size of the target language. So let's see. But I'm also interested in how to do 1 million. I mean, I don't see any examples of where you would do this, but I would also be interested in a general case. I feel like this BC with largest loss is a fine example, but perhaps there are some other ways. I want to use the multi-label classification, but in my project, the order of classes is crucial. For example, if it predicts class number 4 and 10, it is not equal to class 10 and 4. I don't know how to use BCE because both of the classes should be 1. Would you please advise regarding my issue? What would be my loss function is there any loss function which I can use in my problem? But in that example, the seems to be something like a sequence, and that's a where the sequence is important. Perhaps it's a sequence problem or something like that. All right. I have used the multi-label classification and find the self-cross entropy loss, I think. Yeah, all right. At least this gave an idea. I feel like this is a topic that it needs to be explored in more detail. All right. How can I do the operation the same as np.where? I think this exact, yeah, torch.where looks like it's in 0.4. What did it do again? Returns a tensor of elements selecting from either x or y depending on condition. Yeah. So we're looking at x or y, and we're doing some condition. If the condition is true, then we're returning the xi element. If it's not true, then we're returning the yi element. And you can use torch.where. Argmax with PyTorch, you can just use torch.argmax, or you can use torch.max, and that will be returned. You will have the max value, and then the second output will be the indices. But you can use torch.argmax. Yeah, torch.max returns the max values as well as indices, but you can also do torch.argmax. Yep, you can now do torch.argmax. And this is an error. Let's see if there's a question. Super module for Keras like. All right. How to transform variable into NumPy. Variables can't be transformed to NumPy because the wrappers are around tensors that save the operation history, and NumPy doesn't have such object. You can retrieve a tensor held by the variable using the .data attribute. Then this should work. Variable.data.numpy. Okay. Are there any more answers to this? And you need to do .cpu before you do it. All right. What is in place operation? Hi. Oh, I came across the term in place in the documentation. What does it mean? Hi, an in place operation is an operation that changes directly the content of a given tensor without making a copy. In place operations in PyTorch are always postfixed with an underscore, like .add underscore or .scatter underscore. Python operations like plus equals or times equals are also in place operations. Yeah. So the question then is really, should we use in place operations as a default? If we're doing something like x equals x plus y, should we then instead do x plus equals y for having that in place operation? So yeah, for example, x equals x plus y is not in place. This is in place. But I feel like this should also explain the pros and cons of doing it. Should it be used as a default? Should it not be used as a default? And so on. Which one is faster, in place or normal? That depends on what you mean by faster. It does the same amount of computation, so that does not change. But since there is less memory access, this can lead to speed up if your task is bound by memory bandwidth. All right, that's interesting. So if you're using Cuda and running the model on the GPU, you could use in place. All right. That answered what is in place. Let's move on. How to combine multiple criterions to a loss function. I'm building recursive neural nets, so I'll have a variable list of criterions. I want to sum them up and backpropagate error. All the errors are single float values and of same scale. So the total loss is the sum of individual losses. To understand this, I crystallized this problem. It's for another classification project. Oof. So what it does, he sums up the losses by sending it through a cross entropy or something like that for all of the examples that he has. You can optimize a variable number of losses without a problem. I've had an application like that, and I just use total loss is the sum of losses where losses is a list of all costs. Calling backward on that should do it. Note that you can't expect torch.sum to work with list. It's a method for tensors. As I pointed out above, you can use some Python built in. It will just call the plus operator on all the elements, effectively adding up all the losses into a single one. Iterating over a batch and summing up the losses should work too, but it is unnecessary since the criterions already support batch inputs. It probably doesn't work for you because criterions average the loss over the batch instead of summing them. This can be changed using the size average constructor argument. So if you have very large batches, your gradients will get multiplied by the batch size and will likely blow up your network. Just divide the loss by the batch size and it should be fine. But I mean, yeah, okay, so the gist is you can sum up the losses and loss.backward will know what to do. Is it possible to add losses of multiple types provided by torch.nn? So if you use cross entropy 2D and then cross entropy loss, is it possible to weigh the losses? Yeah, you should be able to do that, I think. You should be using F cross entropy or write your second and cross entropy loss and initialize the block and then call it on that input. Still, the question remains, can one do what asked with two different loss criteria? Doing that is fine. It would be, and then loss.backward. Yeah, and it seems to work. Okay, I want to sum multiple losses which are all the same loss function. And then he has criterion equals a mean squared error loss, and then criterion of A and label and criterion C of label, or the second. And then essentially here he's creating two different loss functions for the two cases. But I feel like they are, you could just use one, right? Both give you the same result. I'd say one is simpler. Yeah, that makes sense. And you can weigh the losses as well. You can multiply this with a scalar value and this with a scalar value. All right. So I feel like we've understood. I feel like this what is it called? This post feels like it's reiterating the same points in a way, but we can combine them by adding them together. So next question, how to turn a list of tensor to tensor. You would have to concatenate them, right? I have a list and there are many tensor in the list. I want to turn it to just a tensor. I use a for loop and concatenate the tensor, but it is very slow. Fair. If they're all the same size, then you can torch.unsqueeze them in dimension 0 and then torch.cat the result together. So he has an example of A, and so he appends tensors to this list. Then he does he initializes an empty tensor, and then he does torch.cat A and then out to that B1. So you can just call torch.cat instantly and then just say which on that list and then which one you want it to output. All right, so I mean that's feels like it's the answer. And this guy says he's been using stack. Right. But yeah, I feel like this this felt pretty easy. So I would use torch.cat and not do it in a for loop. All right, next question. Understanding how torch.nn.Module works. Feels like this can be a long question. I was reading through the tutorials, but I feel like I still don't quite understand how nn.Module works. Again, as a simple possible toy example for exploring the API, I tried to implement OLS regression. OLS regression. Ordinarily, okay. Essentially, I want to reproduce the results I get when I do it manually. Yeah, okay, so he implemented the mean squared error loss, or I guess ordinary least squares, and then here he's using MSE loss. This code is kind of unreadable, so I'm just gonna jump it. But for example, I have a smart, yeah, so I don't want to read his example. Felt kind of long. All right, I'm just gonna skip this question, but this seems like this goes into more on the variable versus parameter. But yeah, let's go on to the next. Model.train and model.eval versus model and model.eval. Okay. Is model.train the same as model for training? Yes, they are the same. By default, all the modules are initialized to train mode. Self-training equals true. Also be aware that some layers have different behavior during training, like batch memory dropout, so setting it matters. Also, as a rule of thumb for programming in general, try to explicitly state your intent and set model.train and model.eval when necessary. Yeah, all right. That was the answer. Can we use pre-trained word embedding for weight initialization in nn.embedding? You should be able to do that, I think. I want to use pre-trained word embeddings as initial. For example, in Keras, we pass a weight matrix as parameter to the embedding layer. Is there any similar way to do in PyTorch to do this? You can just assign the weight to the embedding layer. Yeah. So you initialize your embedding, you do embed.weight.data copy, and then you copy some pre-trained weight. And you, yeah. And you can also do embedding weight is nn.parameter of embeddings. And he approves and says they're both okay. All right, I think that answers the question. Next, loss.backward raises error. Yeah, let's skip that one. That wasn't the question really. What's the default initialization method for layers? We've had this question before, but we can go through it. And yeah, and exactly, it is. You can read the source code, but it's going to be depend on the layer. The linear one was that weird chiming initialize. I mean, not weird, but they did a torch.square root of 5, which was a bit confusing, but essentially it was chiming initialization. But yeah, you would have to check the specific implementations for linear, etc., to understand those. Graph visualization. Let's see. Yeah, you now have Tensor board. So what you would do for this one, you have Tensor board, so you can do visualization. There was another post where I showed this, but I can do it again. So if we go on my GitHub and we go to, let's see, what was it? Tensor board. We go to right here. We first create a writer, summary writer, and then we just do writer.addGraph. We have the model, and then we have the examples. We have images to device. Just 1 second. All right, sorry about that. I just had to get some water. I'll probably end up cutting that from the video, but if I don't, sorry, it was a long video. So then we're going to do writer.add graph, the model, and then images, and then we're just going to do .toDevice. Yeah. So essentially, you send in an example, and the add graph knows how it should visualize a model, but we do that in a single line. So it's pretty nice. That's how you visualize the graph. Moving on. Make sure the PyTorch uses GPU to compute. All right, how do we do that? Now I'm trying to run my network on the GPU. You would do model.toDevice, but torch.cuda set device 0. This is from 2017, so yeah, you can also do .cuda, but I think if you have a model, you can also do model.toCuda. I'm going to scroll down just to see, because I think there are more recent answers to this question, so they might better answer the question. Yeah, so this is what you would do is this. For example, you would set you would do device is a torch device CUDA if torch CUDA is available, else the CPU, and then you would do model.toDevice. Is there some sort of internal flag I can check to see if things are properly? All right, so first of all, this is how you would do it, all right? You would do device, and then you would do the model.toDevice. And then you might have, so the thing is, you might have missed something that should be on the GPU, but isn't, and you would probably get an error for that. But if you don't, is there some internal flag I can check to see if things are properly placed in the GPU? If some parameters are not located while they're expected, you'll get an error. Yeah, so that's exactly what I said. You will get an error if that happens. But to check all the parameters, you could run something like for p model of parameters, print p.device. Note that this only checks the parameters. You must ultimately use for buffers. And I don't know exactly what the difference is for buffers and parameters, but yeah, this seems like a good thing to do. I mean, practically you would never do this, right? You would just do model.toDevice, and then you would check is the GPU is it running on the GPU, and you just check your GPU load and your CPU load, and you see if you get something that's reasonable. And if you see that the if it's 0% on the GPU load at all times, then that's a red flag, and then you might do something like this. But I don't recommend doing this for every time you create a model, right? If you run your code and somewhere using tensors on GPU and CPU, you'll get an error. Yeah. So that's to make sure your model is using the GPU. So let's see. We have torch from NumPy not supports negative strides. Let's skip that one. BC loss with BC with logit loss. All right, let's do it. What is the advantage of using binary cross entropy with logit over the regular binary cross entropy? As you have described, the only difference is the As you described, the only difference is the included sigmoid activation in BC with logit loss. It's comparable to nn cross entropy loss and nn.LL loss. While the former uses nn log softmax activation internally, you would have to add it to the later. All right, so this one has the sigmoid inside it. But the BCE loss does not have sigmoid included. Similarly to the cross entropy loss, it first runs it through a softmax and then through what is it called? Negative log likelihood loss. But if you don't run it through the if you don't use cross entropy loss, you need to run it through softmax and then use this thing right here. So I guess, yeah, that's the difference. Would have to check in more detail on the documentation and stuff, but that seems to be a pretty good reply. Wait, isn't it? All right, let's see. I understand the difference in implementation. I don't understand the theoretical advantage of using BC with sigma versus without sigma. Sorry for not being clear enough. The sigmoid activation should be applied in both cases, while nn BC with largest loss will apply it internally for you. You should add it manually if you're using nn BCE loss. Sort of the same point. Isn't it the other way around? I thought BCE loss needs to receive the outputs of sigmoid, but the other will need the logits as input instead of outputs of sigmoid, since it will apply sigmoid internally. Okay, yeah, so he edited his post because now it seems to make sense. Anyways, that's the BC versus BC with logit. Let's now go back and let's see. Questions about, let's do this one. List of nn.Module in an nn.Module. I want to create an RNN-like module with a fixed number of time steps. The weight of each time step is not shared. All right, this is a bit more advanced for me, so I'm just going to skip that one. Questions about DataLoader and dataset. I run my DataLoader. We have some image folder, we use some transforms, we use and then we create a data set and then we DataLoader. But some images are corrupted. My temporary fix is modifying. All right. You can look at the default call it function if it handles none or not, or you can give a custom call it function to your DataLoader which will handle none. The DataLoader doesn't support recovery from errors in datasets because it will be too complex to add and keep the guarantee that it will always return the batches in the exact same order as the sampler generated. It is not even clear what's the behavior the user expects. Some people might want to be notified about the error, others don't. But I feel like you should probably then go through your data set, check which ones are corrupted, and fix them, and then so that your data set is you're not sending in corrupt data. That feels like the obvious solution here, instead of doing some changing the collate function. All right, and he created his example, or he created his own collate function. To solve this particular problem with corrupted images, you can just add 2 lines before your code. From pill input image file.load truncated images equals true. All right, I'm not familiar with this example where you have truncated images. I'm not really sure what that means. But yeah, I would need to read the, felt like I kind of just skimmed the post now. Maybe I'm getting a bit tired. All right, so we have the let's just look at the questions. Initialize hidden state, get value, understack pack padded sequence, and pad packed sequence. I'll take a break, and when I get back, we'll do when to initialize LSTM's hidden state. I'll be right back. Let's keep on answering some questions. So I was thinking now that I would just take the ones that I find interesting, and if I haven't seen sort of what they're asking for, or if the question if it's not a question, then I'm not gonna click it. So just the ones that are interesting. So this one is pretty interesting. When to initialize LSTM hidden state. All right. My questions might be too dumb to dump for advanced users. Sorry in advance. In the example tutorials like word language model or time sequence prediction, states of LSTM are initialized at each epoch. I tried to remove them and it still works the same. So when do we actually need to initialize the states of LSTM or RNN? Let's say I want to use different batch sizes in train. I want to use large batch size in train to speed up learning and small batch size in test time. Is it okay to do, or should I fix the batch size during training and validation? So I think, okay, so let's see the first question. Let me just share my thoughts first. So if you're gonna, I mean, the hiddens are used to share the previous time steps, right? And so if you would want to initialize it like this if you're gonna send it in to the RNN sort of for example, if you're sending in step by step, sort of time step by time step, so you're using a single RNN cell and then just reusing that cell, then you would want to keep track of the hidden. And you would want to initialize it first, and you would send it into the RNN cell, and then take the output hidden and then send that in again, and etc. But if you're just going to use it, if the hidden is not going to be used later on, then you don't need to initialize it, since it's going to be sort of internal to that RNN, and the RNN will by itself initialize the hidden, and it's going to just discard it since we're not using it anymore. Those are my my thoughts on that, but let's see what they say. Okay, so the first question, because otherwise it will reinitialize hidden layers to 0, which means it does not remember across time steps. It works, but performance won't be as good. And that's sort of similar to the way I was thinking. When you want to remember the previous time steps, that's when you would actually want to initialize the hidden and store those values and then send it in again for the next iteration or time step. And then the second question was something with regarding the batch size. It's okay to have different batch sizes for training and testing, but see if you can adjust the learning rate. All right. I am somewhat confused. Shouldn't RNNs retain the weights that were learned just like linear layers do? The language model examples initialize the weight even while evaluating the learned model. All right, so I haven't looked at the language model example, but RNNs retain the weights. That's internal to the RNN cell. At least this is how I view it. I might not be entirely correct, but this is what I believe to be the case. RNNs have the weights internal, and but of course, and so those weights are always going to be there, but you're changing the hidden depending on the input. So you want to have an hidden for the specific example, and if you want to remember what the RNN has learned, or not remember what it has learned, but sort of the representation of the previous time steps, then you need to keep track of the hidden. So that's the difference between the weights and the hidden, I think. The RNN retain the learned weights, but RNNs also have a hidden state that's not learned, but transferred between time step to time step. Thanks for the response. That's exactly what I thought initially, but then this snippet got me confused. All right, so all right, so I haven't looked into this example right here. This kind of confuses me as well. From what I understand, set of the parameters returns all of the model parameters, and then gets the data from it. But the part variable seems to set the weights to 0. All right. Also, since the code is iterating over parameters, shouldn't it be setting parameters one layer at a time? But here it seems that all model parameters are set to 0 at the same time. I'm sure I'm missing some major link here. No, it creates a new tensor with the same type as weight. It doesn't actually touch weight itself. All right. Yeah, so that's, I guess it's just that example. We don't have to look into that example specifically, but the overarching idea here is that you don't modify the weight. Why is that step needed and how does it help? Isn't this step supposed to change the hidden states? All right, so I'm not sure what his question was here. This function in hidden doesn't initialize weights. It creates, yeah, exactly. So you kind of have them separately. You have the weights, which are internal to the model, and those are never going to, they're going to change based on gradient descent and backpropagation. But you also have the hidden, which are specific to the states of the sequence. There's initial states in all RNNs to calculate hidden state at time t equals 1. You can check size of this hidden variable to confirm this. Did you mean to say that hidden states are not retained from one sequence to another if it's not explicitly handled? How can it not retain hidden states between time step within a sequence? Isn't this pretty essential for RNN to work in any setting? And I think it does if you're using the entire RNN. But for example, if you're using something like sequence to sequence and you want to keep track of the hiddens from the encoder, you want to initialize the hidden, you want to keep track of those, you want to send them into the decoder, and so you keep track of the hidden states. But they are of course used if you're using an RNN, then internally that's going to reuse the hidden for the time sequences. But there are cases where you want to actually keep it like a sequence to sequence scenario, or if you're doing a character level RNN, then you're essentially just sending into an RNN cell and with a for loop, and then you would have to keep track of the hidden states also. But yeah, so no one answered this question. Or one month later, the init hidden function sets the hidden variables to 0. So I don't understand your first point. So his first point. Yeah, so because the initialization by default, if it doesn't receive a hidden state, is going to be zeros. But if you want to keep track, so for example, let's say a sequence, for example, you need to have those hidden states memorized. If you don't, then it's going to just reinitialize it to 0, and it's not going to know anything about the source sentence if you're using it for translation, for example. All right, and then no one answered the questions. Yeah. I feel like we've answered this question. Let's go back. And this is not very interesting. Get value out of. All right, let's just check the answer. All right, so we have a variable, use variable.item. All right, simple enough, use variable.item. Understanding padded sequence and packed sequence. Yeah, I'm not going to go into that, but that's essentially, oh, okay, I pressed it, so I'm going to go into that. Let's just read this one. Yeah, but yeah, so, I mean, the essentials here are that I actually don't know the difference, but it's for padding examples in a batch. And no, rather you have padded examples within a batch, and then you want to send it into the RNN so it doesn't do unnecessary computation for the examples where the elements are padded. But yeah, let's go back. Print tensor type. All right, so this should be pretty easy. We're just gonna do tensor.type. So we do import torch once, a.type. Yep. The right way to do this is type tensor. All right, simple enough. Let's see this one. Data augmentation in PyTorch. There is something with PyTorch data augmentation I would like to understand. I used the following code to create a training data loader, and he used some random crop with some padding, random horizontal flip to tensor, and then he normalized with these values. Yeah, so he's expecting if he sends in one example, he's expecting to have one example for the random crop and one example for the random horizontal flip. I'm assuming. Yeah. However, the thing is here that these are applied sequentially. So it would first do this, it would then do the horizontal flip, it would then do the two tensor, and then it would do the normalize. So the fact that this is a random transformation, that's what essentially creates the data augmentation, because if you send it in multiple times, they are going to be different outcomes since this is random. And remember, if you have multiple randoms on top of each other, they're sort of stacked in a way, since this can have 2 outcomes, this can have 2 outcomes, so in total we can have 4 outcomes. And if you have more, that would augment the data, effectively augmenting the data if you send in this example many different times. But it doesn't augment it instantly, and you just get returned with 10 times the amount. But yeah, so he's asking, where are the augmented data? Where did they go? So let's see what they say. Hello, in any epoch, the data loader will apply a fresh set of random operations on the fly. So instead of showing the exact same items at every epoch, you're showing a variant that has been changed in a different way. So after 3 epochs, you would have seen 3 random variants of each item in the data set. Yeah. That said, I don't think your counting method works for estimating the number of samples in the augmented set. The flip will double the number of pictures, but the crop has many potential outcomes. Also, you would need to multiply the relative increases. One might also ask me whether the augmented samples fully count, but that's a different discussion. Yeah. So, I mean, if you do, let's say that you do a random rotation, and you say that it's between minus 45 and 45, let's say 45 degrees, then it could, in theory, be 1.112, and then it could be 1.113 for another epoch. But I mean, those are going to be very similar, but in theory, those are infinitely many augmented images, right? But yeah. But there's definitely a question of, do they really count? So in that way, it becomes more complicated to count how many augmented images you actually have. All right, the idea is according to every epoch, the data is augmented. I'm still puzzled with this. Does this mean that the data was transformed in every epoch? I think so, yeah. So how do we make 3 times data in every specific epoch? I don't think we... So effectively, if we run it for multiple times, we'll get different outcomes. But we can't get 3 times the data for just instantly. So it just means that the data is changed on the fly. The epoch size does not change. You just get randomly transformed samples every epoch. So the concept of a static data set becomes a bit more dynamic. Yeah. Perhaps you could also, I mean, it would also make sense if you had a static crop and you would, but I guess they haven't chosen to do it that way. And I think the way they do it also makes sense. But kind of need to readjust your mindset of how augmentation works, I think. I use transforms to do this, such as random crop, but how to double or many times the data set, just as 5 crop to 5 times bigger the data set. I'm so confused. Yeah, but so the point that's reiterated many times is that he wants to sort of specifically say how many times the bigger the data set is. But if it's random, if it's a random crop, it could be infinitely larger, right? But how effective those are, that's up to discussion, right? As the random rotation example of just a 0.01 difference in the degree, that's effectively the same image, but still it's not identical. All right. Well, you can see it this way. The new 1 epoch is in fact 5 consecutive old 1 epoch stacked together. All right. I felt that was a bit confusing as well. 1 epoch is in fact 5 consecutive old stack. I mean, yeah. Can you give an experiment on that? It's just hard to get this. Let n denote the size of the original data set. In ordinary augmentation, i.e. pre-computed and static, not on the fly, if we have 5 transformations, then the size of the augmented data is 5 times n, which means that each epoch, the number of iterations is also 5n. Now, if we augment the data on the fly with random transformations using PyTorch, then each epoch has the same number of iterations, n. If we concatenate 5 epochs consecutively to create a large epoch, or call it whatever you want, then the total number of iterations in this large epoch is 5 times n. Thus, it is roughly equivalent to static augmentation. Note that this large epoch is a valid epoch because there's no duplicate in the 5n iterations since the transformations are random. Yeah. I mean, you can definitely view it as sort of an equivalent way of doing static augmentation, but the difficulty is in calculating the how much larger the data set has become. Yeah. It's important to understand that the data loader only goes through the files and indexes files in the target labels. The actual loading of the images happens when the getItem function is called, which is basically when you enumerate the data loader. This is usually the line in the program which looks like for data and train loader. It is at this time that the transformations are randomly done. All right. All right, I'm just gonna scan and see if there are any things that we missed. All right, 3 months later, there's a new movement right now in data augmentation. I found it used most of the super resolution problem. For example, these lines in residual dense network, CVPR 2018, randomly extract 16 LR, not sure what LR means, RGB patches. We randomly augment the patches by flipping horizontally or vertically and rotating 90 degrees. All right. So if we use random crop to transform the training images, does it mean that the original image are never used in training? Is it only the transform that are fed in the optimization process? Yeah, I think so. But it could be the original image, right? If the random, for example, if we use a random crop and it just picks the exact original image, it doesn't crop it in. Well, I guess if you use a crop, then yeah, those would only be transformed images. Random crop assumes that the original image is larger, so you cannot feed the original as is. Yeah, and random horizontal flip will flip it with a given probability. All right, let's move on to another question. How to create a data loader with variable size input. So this is a problem. Oh, it's in Vision. You would need to have everything in the same, I think. I'd like to create data loader with different size input images, but I don't know how to do that. But so the network is specifically for, it needs to be the same size. You can't have different, then you would need to have two different networks, I think. Or so you could either resize them or you could pad them so that they are the same, but I think they all need to be the same. But let's see what the answers are. All the images in the tutorial are rescaled to 256 and randomly cropped to 224. I'd like to do another image classification task, and I want to keep the image the original size, and the batch size should be greater than 1. All right, I don't really understand. You need to write a custom collate fn and pass it to your data loader. So this would essentially be padding, I think. By default, Torch stacks the input image from a tensor of size, number of examples, channels, height, width. So for every image in the batch, must have the same height and width. In order to load a batch with variable size input, we have to use our own collate fn, which is used to pack a batch of images. Okay, but does that pad them? I think they need to be padded then. Yeah, I think for image classification, the input collate is a list with size, batch size. Each element is a tuple, where the first element is the input image, and the second element is the image label, which is simply an integer. Because the samples in a batch have different size, we can store these samples in a list and store the corresponding labels in torch.long tensor. Then we put the image list and the label tensor into a list and return the result. Here's a very simple snippet to demonstrate how to create a custom collate. Yeah, so here he's not doing anything. He's just converting it to a long tensor. But you would, feels like you would need to do some padding, otherwise it wouldn't work. Yeah, all right, so I'm gonna, so this guy right here uses a collate function and to do some padding, but these are for RNNs, so they are not for, but yeah, you would need to check and you would need to pad them so that they're all the same size, and that way you can just send them in and they will be padded on the fly. All right, next question, updating PyTorch. See how you do that. Recommendations, if you're new, I would recommend you would conda update PyTorch. Yeah. If there's anything new. Yeah. Yeah, actually, this is a good reminder. I have the PyTorch nightly version, but I should probably remember to do conda update PyTorch more often. All right. Next, training with half precision. I was wondering if anyone tried training on popular datasets, ImageNet, Cypher10, 100 with half precision, and with popular models, e.g. ResNet variants. It works, but you want to make sure that the batch normalization layers use float32 for accumulation, or you will have convergence issues. You can do something like model.half converts to half precision, and then go through, so for layer model.modules, if instance is batch norm, then do layer.float. One more thing here is that to do this, you actually need to have a, I'm pretty sure you need to have a 2000 series graphics card, otherwise this won't work. And again, this is from 2018, and in the PyTorch world, a lot of stuff changes. So as we've seen just from reading these posts today, this is great. Is there any documentation on where half precision can be used? For example, it doesn't seem like half precision computation is supported on the CPU, but I only discovered this by giving it a shot. All right, so people are having problem training on half precision with 16-bit floating point. We've developed a lightweight open source set of PyTorch tools to enable easier, more numerically stable mixed precision training. Let's check that out. NVIDIA Apex. A PyTorch extension tools for easy mixed. All right. All right, that seems pretty cool. So this does a lot of, so this kind of automates how you train on mixed precision. All right. Mixed precision means that the majority of the network uses floating point 16 arithmetic, reducing memory and storage bandwidth demands, and enabling tensor cores for gems and convolutions, while a small subset of operations are executed in floating point 32 for improved stability. All right, so some operations actually want to be in floating point 32. Highlights include amp. All right, we don't have to go into depth on that one. And they have a few examples on it, but I'm curious to see if things have changed. Yeah, and I've seen this as well. I've seen this PyTorch Lightning too. I'd say the easiest way to use and not make it is to use PyTorch Lightning with training use amp equals true. This will train your model using 16-bit. So this is another thing. So I've seen this as well. If we just go to PyTorch Lightning is nothing more than organized PyTorch code. Once you've organized it into a Lightning module, it automates most of the training for you. So what is PyTorch Lightning? Is it only for 16-bit or mixed precision? See, I mean, it should probably say right here. I mean, organizing my PyTorch code for what? The engineering code is all the code related. This thing, early stopping distribution over GPUs. Oh, okay, so it can be used for the distribution over multiple GPUs, 16-bit precision, etc. All right, that's cool. So we can, I wonder why that's not, if that makes it easier to distribute over multiple GPUs, then why isn't it internal to PyTorch? Because this is another library, right? PyTorch Lightning. The lightweight PyTorch wrapper for ML researchers, scalar models, write less boilerplate. All right, well, this seems interesting, but how flexible is it? All right, I'll need to check that in more detail, but anyways, training with half precision seems like there are some libraries you can use for it. We can use, I'm not sure, this thing right here, or if that's, maybe that's perhaps, didn't I see that guy on? No, okay. So maybe there are two different, you have the Apex and you have the PyTorch Lightning. I'm not sure, I'd need to check that in more detail. But that seems to be able to alleviate training on 16-bit. Thanks, Apex was very useful in our project. All right, so that's where I would go if I want to learn more about training on half precision. But again, I think I'm not sure, but I've read somewhere that you need to have a 2000 series GPU. Otherwise, it's not going to be able to train in half precision. So for me, I have a GTX 1060, which is not going to be able to train on the half precision, from my understanding. All right, let's move on. Runtime error, multi-target not supported. Select specific columns of each row in a torch tensor. Encounter the runtime error, one of the variables. All right, these are just errors. Loading huge data functionality, global average pooling. I'm not sure what global average pooling is. Log softmax versus softmax. We can check that. I'd assume that log softmax would give the same performance as nn.softmax, given that it is simply log on top, but it seems to provide much better results. Is there any explanation to this? I'm not sure if there is a definite answer to why this works better, but to provide some insight, it's worth noting that using the log likelihood is very common in statistics. Here are some references on the use of the log likelihood. One key point to notice is that depending on your loss function, this fundamentally changes the calculation. Let's consider a case where your true class is 1 and your model estimate the probability of the true class is 0.9. If your loss function is the L1, the value of the loss is 0.1. On the other hand, if you're using log likelihood, then the value is 0.105, assuming the natural logarithm. All right, now if we consider two cases using the standard likelihood akin to softmax, the error increases by a factor of 7 between the two examples. Using the log likelihood function akin to log softmax, the error increases by a factor of 11. The point is, even though log softmax and softmax are monotonic, their effect on the relative values of the loss function changes. Using the log softmax will punish bigger mistakes in likelihood space higher. All right, and that somehow lends to better. Could you explain a bit what you mean by performance? I meant the loss decreasing versus stagnating. Apologies, I should have been more clear. So yeah, it could be due to numerical stability reasons. Yeah. So the only difference between these two is that one does e raised to and then divides by the sum of e raised to the normalization. The other one uses log takes the it takes the log of that, and then we can simplify it by taking the log of the numerator, subtract it with the log of the denominator. And that should be more numerically stable since you don't have a division. Okay. All right. If you use cross entropy, you should pass raw logits to enter cross entropy loss, since the function itself applies f.log softmax and log likelihood loss. If you pass log probabilities, your loss function won't work as intended. All right. Yeah, okay, so I think this answers the question, at least log softmax versus softmax. I don't think we need to continue. Why do we have 3D input tensors in LSTM? Sorry in advance if this is a silly question, but I'm getting my feet wet with LSTMs and learning PyTorch at the same time. So I'm confused about how nn.LSTM ingests its inputs. So it seems like the input for an LSTM is a 3-dimensional vector, but I cannot understand why. Yeah, so you would have a batch, and each batch would have a time step, and then you would have features for that time step. So if we, for example, have a batch, let's say we just have a single example in our batch. So this would be 1. Let's say we have 10 words in our batch. So that would be 10 here. And then each word, those, or let's say we have, 10 words. Each of those 10 words are mapped to a feature, which is connected to a vocabulary size. that's how we know which word it corresponds to. But let's see, if I have a single time series of length 10,000, but use mini batches of say length 50 and have no feature inputs other than the series itself, would this translate it to a question mark times 50 times 1 tensor? Then you would have 10,000 here, right? If you have time series of length 10,000, that if you have time series of length 10,000, that should probably be 10,000 here then. Except that in this case, I'm assuming the time series just have a value associated with it. Let's see, my interpretation might be wrong. The mini batch dimension refers to the number of sequences you want to process in parallel. So if you divide a time series of length 10,000 into chunks of length 50, oh, okay, yeah, I was wrong. Yeah, you have 10,000 and you divide it into chunks of length 50, your input would be 50 time steps by 200 the batch size by 1 features. Yeah, that makes sense. That's very helpful. Thanks for the time to answer. In terms of performance, are there any best practices in the relationship between time steps and batch size? High versus low, low versus high, etc. Large batches with fewer time steps, faster. Small batches with better generalization and accuracy. All right. All right. Yeah, I think what they said in the beginning of the post was pretty good. So that's why we have 3D input tensors in LSTMs, and that's the example for time series. And also we talked a little bit about the general case where you would have some vocabulary size, and then the number of features would be equal to the length of the vocabulary. Yeah. All right, let's see. This I was confused about this before. I saw this in a previous post. What is the difference between BC with logit loss and multi-label soft margin loss? I think there's no difference between BC with logit loss and multi-label soft. Yeah, okay. You're right, both loss functions seem to return the same loss values. All right. So, no difference? All right, I'm gonna skip that one. That would need to set it to learn more. Oh no, we need to scroll down now. I shouldn't have updated. Let's see. All right, simple L2 regularization. This you would just do this in the optimizer. You just do weight decay equals, and then you just set the value. The L2 on the parameter of the model is already included in most optimizers, and you could control with the weight decay parameters as can be seen. Yeah, so you would just do. Yeah, I mean, you wouldn't have to worry about the implementation of how to implement it, because it's going to be done. Let's see. I mean, for you. So you would just specify. Oh, okay. Sorry, I was confused. But yeah, you would just do weight decay, and that would be L2 regularization. If you want L1, you would have to do that manually. So they've added it as there is an optimization as it's often used. And I never use L1 instead of L2, so. But that might not mean that there might be use cases of L1 instead of L2, but I feel it's rare that people even use well, not rare, but dropout and so on are perhaps more efficient ways of doing regularization, and also batch norm and those kinds of stuff sort of decrease the need for L2 regularization as well. But yeah, let's go to another equivalent of np.ReShape. And this is, I can answer this, I think. You would do torch.view, but you also have torch.ReShape now. So you could use torch.ReShape. But yeah, I think the view method would be the right tool, and that would resize it. Is it, from your knowledge, is it more or less similar to ReShape? A caveat is that it has to be contiguous, but that matches NumPy as far as I know. Yeah, so this is a difference, and I talked about this in a video I did on tensor operations, which is that view doesn't create a copy, but the memory needs to be contiguous. So I'm no expert on that, but I showed a couple of examples where you would need to do contiguous, and where ReShape, if you use torch.ReShape, it's going to automatically create a copy, but it might be less efficient than view. But yeah, let's see if this is, I'm just going to scroll down because there might be newer answers. Yeah. So now they say, I think our reshape method is now available in Torch version 0.4.0. That's awesome. And all right, about the Torch nn utils clip grad norm. Let's see what they say. I'm trying to understand what this function does. I know it's used to prevent exploding gradients in a model, and I understand what the norm of a vector is, and I'm guessing that this function clips the norm of a vector to a specific maximum value, but I would like to know how this value presents the exploding gradient problem and what exactly it does to the model parameters. Help would be greatly appreciated. All right. In some cases, you may find that each layer of your net amplifies the gradient it receives. This causes a problem because the lower layers of networks get huge gradients, and their update will be far too large to allow the model to learn anything. This function clips the norm of the gradients by scaling the gradients down by the same amount in order to reduce the norm to an acceptable level. In practice, this places a limit on the size of the parameter update. But how does it do it? So it computes the norm, and then it multiplies by 1 over the norm, or? I understand now. So since the norm is the distance of a vector from the origin, you're forcing the gradient not to go too far from the position it was the last time. Did I get that right? I think it is more true to say that you're forcing the gradients to be reasonably small, which means that the parameter updates will not push the parameters too far from the previous values. So I mean, this is clear in the way that we are, of course, inhibiting the gradients to grow too large, but exactly how we're enabling that is the question. Are we multiplying by 1 over the norm, or rather dividing by the norm for all the parameter values or the gradient values for a specific block, or for example for specific module weights, or how? Yeah, and then is it similar to decreasing the learning rate, only selectively small gradients? So now the question is more, this question is more about gradient clipping in general and how it works, but I would like to see the details of how it does it. My previous answer assumed that lower layers would receive during the back. This is not the case. Clip grad is applied after the entire backward pass. So you call loss.backwards, and then you would do gradient clipping, and then you optimizer. All right. I mean, yeah. Yeah. Oh, did the same mistake. Let's go down again. All right. Balance sampling between classes with Torch Vision DataLoader. All right, that might be interesting. I'm trying to find a way to make a balanced sampling using image folder and DataLoader with imbalanced dataset. I suppose that I should build a new sampler. I'm not sure if I'm missing something. Is there an already implemented way of doing it? You should take a look at how to prevent overfitting. Weighted random sampler. All right. All right, so you get some weights and you use you check what the class weight should be, and I guess you use weighted random sampler so that you sample with a larger probability from specific classes, and then you use that in the data loader, and then you send in a sampler. That is I guess clear. Yeah. Yeah, and then they're looking at the specific and he has a specific example that they're looking at, so we're more interested in the overall idea of how to do it rather than the specific details of how he did it. So we're just gonna skip this. So it seems that they're using the same method. I just want to see if there's newer ways that they're doing it. Shouldn't it be weight per class is 1 over float count? Right. Yeah, but we would need to check the weighted random sampler to see exactly how that works. I mean, we could probably do that. Weighted random sampler PyTorch docs and weighted random sampler samples elements from with given probabilities. So you just input okay. So you have given probabilities, but then they're not probabilities. If you have these weights with given probabilities weights, sequence of weights not necessarily summing up to 1. All right, but I guess you could always normalize this with so that they are probabilities, but I'm assuming this would sample from class, the second class, with larger probability than the rest, and yeah, all right. All right, that seemed to be a way to do it. And yeah. RNN module weights are not part of a single contiguous chunk of memory. All right, that seems to be an error. Input is not contiguous. All right, we can do that. Runtime error, input is not contiguous. What does contiguous mean? What does this error occur? That means it's not, when you're using view, it's not contiguous in memory. It means that your tensor is not a single block of memory, but a block with holes. View can be used with view can only be used with contiguous, so you just need to call dot contiguous before. You can find some details about memory layout. Yeah, I need to do that as well. I have a very shallow understanding of the memory layout in general of these things. I just understand what to do, not exactly the underlying reason why we do it. I mean, the abstract concept is, I guess, simple in it's how it's stored in memory, but there are a bunch of follow-up questions in, how do they store things in memory, and how are tensors stored in memory. But I guess the fundamental idea is that when you have matrices, they aren't actually a block of memory. They're actually a contiguous, or they're a vector with just pointers, and that creates the matrix, or multi-dimensional arrays or whatever. And it seems to be that the contiguous is important for this view operation. Although if you call .reshape, it will create a copy if it's not contiguous. So you could use that, or you could use .contiguous and then .view. But I think there was a good example. I think I've read this one before. Actually, no, okay, I haven't. Yeah, so you can read for more examples of what contiguous means. But essentially, if you do something like transpose, that's not going to be a contiguous operation. So if you use y is x.transpose, you would have to do y.contiguous, and then if you want to do .view and let's say -1, you want to flatten the entire tensor, then you would need to do contiguous in that case. All right. How to use the backward functions for multiple losses. I feel like we've seen this in a sort of variant in different posts, but let's look at this one too. I'm playing with the DCGAN code in PyTorch examples, replacing error_d_real.backward and error_d_fake.backward. So we get an error for the discriminator, and we get an error for the all right. I need to just remember what I did when I did this. Let's go to my GitHub. And let's go to machine learning. Let's do DCGAN. So we have the net D, we have net G, we have two different optimizers. We do zero grad, we do loss D. Yeah, okay. So we do the loss D of the discriminator for the real image and then the fake image. Yeah, that makes sense, because we send in one through the discriminator, and we send one through the generator, and both of them generate a loss. Wait, that's for, yeah, okay. I think I remember this, yeah. we do that by doing the detach so that it doesn't influence the graph in any way, because we're using the discriminator when, or rather the generator when training the discriminator. So we separate it into two parts: train the discriminator and train the generator. Anyways, that wasn't the question. So we have RD real and RD fake, but RD backward is not equal to RD real backwards. Okay, I feel like this is a bit hard to read. Perhaps someone can make an just explain the idea behind it. What exactly happens on calling backward multiple times? Does it calculate the gradients twice with respect to the same weights? I think you can only call it once, if I remember correctly. Let's see. I imagine the area that is drawn from trying to backprop variables that belong to different graph structures. I feel like they could have done a lot simpler of an example than multiple loss in the GAN case. I mean, the point that's trying to be illustrated here is, I think, simpler than needing to bring up GANs. All right, this is a long post, but to try to clear this up, indeed, you have to think about the mathematical function here. Loss is the criterion of the net D plus the criterion of net D with the fake one. Yeah, and the fake one is created by the generator. Spelling out the chain rule for the gradient with respect to the parameters. All right, I don't want to do that. Note how the gradient with the parameters net is evaluated at two different points. Yeah, all right. So we're gonna use we need to distribute the gradient, and we use it at two different points on the real and the fake one. The way backpropping is to evaluate the gradients at the locations of the last forward pass. In theory, you could also copy the network, make the parameters shared, and then just add the loss to achieve the same. Then the backprop at real will go through one copy and the one at fake through the other. Yeah, I feel a bit too tired to understand this example. Wait up. Perhaps I should watch my own video on GANs. I feel like I explained this. I remember knowing about this, but you could also do keep graph equals true. And this is something that sort of confuses me, so I should probably look this up. If we do loss backward PyTorch retain graph, and yeah, okay, yeah, I've read this and this post, so if I think about it, I should probably understand it. because when we do loss.backwards, we then we can't call loss.backwards again unless we have keep graph equals true, since we've already computed the gradients. So without keep graph equals true, PyTorch can throw away the process bits information from forward, and will give an error meaning. Yeah, because this is sort of part of the dynamic computational graph. If we do loss.backwards, then we're telling PyTorch that we've completed the forward pass of the computational graph. We've now done the backward, and if we don't have keep graph equals true, there's really no point in saving those in memory, so it's going to discard them. And if we call loss.backward again, forward info is gone. I think calling backward once on error derail and error defect should be the same as calling it twice separately. What did I do? I called it twice. The problem mainly attributes to using the same labeled tensor for real and fake data. If we're creating two labeled tensors, the problem should be resolved. Nevertheless, calling backward twice is recommended as a good save. This is not correct. PyTorch will not override previous values. Being in the same model parameters or not is not related to how the dynamical graph is built. It will be different links in the graph. The variables saved for backward passes will be stored differently. So here's a simple example. Linear, we fill the weight with zeros, and the bias, we have a variable backward one loss only. Okay, and then we backward the other loss only, loss 2. And if we backward the two losses together, all right, I think this is a bit advanced for me, perhaps. This feels like it's a little bit complicated. PyTorch will not override previous values. Being the same model parameter or not is not related to how the dynamical graph is built. It will be different links in the graph. The way backward propagation works is to evaluate the gradients at the locations of the last forward pass. In theory, you could also copy the network, make the parameters shared, and just add the loss. Shame. Then the back prop at real would go through one. Yeah. So I feel like, yeah. Yeah, this is a bit, I need to read about GANs again to really understand the example that they have here. I feel like this was a bit waste of time. Yeah. But calling them separately or adding them together and then calling doesn't seem to be the same thing. But I really think so I think, yeah, let's just go away from this one. I feel like it would take a lot of time just to study the example given rather than the concept. But yeah. Contiguous versus non-contiguous tensor. So this is sort of, we've seen this in other posts, but we can see, and this one I've read before, but we can read this. So it's a flag indicating if the memory is contiguously stored or not. Let's see an example how we can get a non-contiguous tensor. So let's say we have a range 12.view43, and then we print x and we print x.stride. So we have 0, 1, 2, 3, 4, 5, etc. And we have 3, 1. As you can see, the tensor has a desired shape. The strides are also interesting in this case. They basically tell us how many steps we skip in memory to move to the next position along a certain axis. If we look at the strides, we see that we would have to skip 3 values to go to the new row, while only 1 value to go to the next column. That makes sense so far. The values are stored sequentially in memory, i.e. the memory cell should hold to the data as 0, 1, 2, 3. Yeah. So I mean, this is how it's stored in memory. This, you can sort of see that jumping 1 row is 3 steps, and that's the value here is exactly 3 steps corresponding to the original tensor. But now if we transpose the tensor, so we do 0, 3, 6, 9, and we do 1, 3. Now if we look, so 3 steps right here, that's not going to be, that's going to be, corresponding to 9 skips in the original tensor. But let's see. The print statement of the tensor yields that the desired transposed view of x. However, the strides are now swapped. In order to go to the next row, we only have to skip 1 value, while 3 to move to the next column. This makes sense if we recall the memory layout of the tensor. In order to move to the next column, e.g. from 0 to 3, we would have to skip 3 values. Yeah, so moving 1 step here corresponds to moving 3 steps in the original. So the tensor is non-contiguous. That's not really a problem for us, except that some operation won't work. For example, if we try to get a flattened view, we will get runtime, so we need to call contiguous before the view call. Now the memory layout is contiguous. Once again, have a look at the strides. The strides are a little bit confusing. Here we have 3 and 1. So for how many steps we skip in memory to move to the next position along a certain axis? Yeah. Yeah, that makes sense. Yeah. I mean, here we're moving, if you're moving 1 in the column, okay, 1 in the column, that corresponds to taking 3 steps, but here we just take 1 step, so the strides don't match. That makes sense, yeah. That being said, now the memory layout is contiguous once again. Have a look at the strides. and the view works just fine. I'm not completely sure, but I assume that the contiguous call copies the memory to make it continuous again. That being said, continuous array are necessary for some vectorized instructions to work. Also, generally, they have some performance advantages, as the model access pattern on modern CPUs will apparently be used in an optimal way, but I'm not really an expert on this topic, so take this last with a grain of salt. All right, this was a great explanation. So that's contiguous versus non-contiguous tensor. And next, check gradient flow in network. All right, is there an easy way to check that the gradient flow is proper in the network? Perhaps you could use TensorBoard. You could plot the gradient, the weights, and see if they I don't know, look right. And grad checks if checks a single function All right, so there's it can find, you can find not nans, not a number for the gradients. You can do this with TensorBoard. Yeah, this is how it would look in TensorBoard. For complete, I don't recommend TensorBoard for many reasons. Sure, it's easy, but it's a bit limited. But if you want these style graphs, all right. So they seem to be. I mean, I've never come across scenarios where I want to use this, but I can definitely see that TensorBoard might be limited in some way. All right, but yeah, for my use cases, TensorBoard is fine, but perhaps there might be more complicated scenarios that I'm not aware of. Passing the weight to cross entropy loss correctly. I just wanted to ask how the mechanism of passing the weight to cross entropy loss works. Currently, I have a list of class labels that are 0 to 10. I created, oh yeah, okay. Yeah, so this is you can sort of say, let's say we have MNIST, and perhaps you don't prioritize zeros as much, something like that. And then you could use something like he's doing and say that we're prioritizing finding ones, twos, threes, etc. Higher than zeros. And then you would send that to your cross entropy loss with the weight argument. All right, what's his question? The reason I'm asking is that I would be much more comfortable passing a dictionary weight to the loss function instead of a list, so that I'm sure the weights are mapped to proper classes. All right. Your interpretation is correct. That is how class weights will work with cross entropy loss. All right. I guess no one, he answered this. I mean, that's, I'm not sure why you would want a dictionary if that's how the function is implemented, then it should work as intended. But yeah, so there haven't been that many discussions. Well, yeah, and then yeah, we don't have to go in depth on this, but yeah, he pretty much explained it in his original post, that you send in some weights for how much you're prioritizing each class, and then you do a flow tensor of that and you send that to your cross entropy loss. All right, torch.nograd. We've seen a lot of questions on this, but it's always good to see it from a different perspective. All right, and yeah, so it doesn't. They just wanted it to be part of the documentation at that time, which I think it is now. But essentially, you would do with torch.nograd, and all of the subsequent operations you do included with that after that with torch.nograd are going to be set. You know, all those operations are going to be requires grad equals false. So it's very very good to have if you're doing something like you know, evaluating the model in some way, then checking the test set. You wouldn't want to compute the gradients for that. Solve. What is the correct way to implement custom loss function? I think we've seen this, right? Yeah, but this is a bit advanced for me, and I covered. I mean, I read another post about this, where the most important thing is that if you want to use Autograd, you would do everything using variables and tensors and those operations inside of PyTorch, and then Autograd can keep track of those. And if you don't, you would need to have a forward and a backward yeah. But I think in the future I might spend a day and just try to understand this in more depth. But I think for the purpose of this sort of video, of just reading posts and trying to get a high level understanding, I think we've done that, and I think we've come to the conclusion that this requires more time than this video. The difference between LSTM and LSTMCell function. So I think I can answer this in that the LSTMCell is used multiple times in LSTM. So the LSTM will be general in the way that you don't have to implement a for loop and send it through the LSTMCell multiple times. But so here we have some time steps. Here we have the nn.Cell, and we have them for multiple layers. So yeah, this is the cell. Yeah. LSTMCell is more flexible, and you need less code with LSTM. All right, so this is the output, these are the cells, and these are the input. Yeah. And using RNNs, and you can specify the number of layers and so on, it will reuse this cell for multiple layers and also for multiple time steps. That's my interpretation of it, at least. How to keep the shape of input and output same when dilation conv. Okay, I don't even know what dilation conv is, so let's skip that one. What's the difference between torch.nn.Functional and torch.nn? So this was in another post as well, but they are in both, but torch.nn is built on top of nn.Functional, and nn.Functional includes all things that doesn't have any parameters, so they are just functions. Let's say dropout, for example, it doesn't have any. Let's say ReLU. It's included in the functional and it's included in the nn. But if a module like ReLU doesn't impact, doesn't change when you're in model.evaluate, if you're in evaluation mode, or when you're training, like ReLU doesn't, then you would use the standard way of using it is torch nn functional. Or that's the general guideline that we saw in a previous post, and I think it was Adam is his name that mentioned that. But for dropout, for example, you would have that would differ depending on if you're in training or if you're testing the model. So if you are using dropout, you would obviously not use dropout if you're in an evaluation mode of your model, but you would also do rescaling. So the dropout operator or dropout layer will work very different. And if that's the case, you want to use it in the nn module rather than the functional. So that's the guidelines. And they also said in that post that the functional or the nn module is built on top of the functional. So there are, well, it's very minimal, but there's some overhead when using the nn module. So if there's something like ReLU, perhaps it's best to use torch nn functional. No efficiency difference. The activation, dropout, etc. modules in torch nn are provided primarily to make it easy to use these operations in an nn.Sequential container. Otherwise, it's simplest to use the functional form for any operations that don't have trainable or configurable parameters. Yeah, and I think, but he should also mention here, I think, the dropout, etc. That's different. If you use f.dropout, you need to specify that if the model is in training or not. All right, but that was all, and they covered this in another post. So, why does the clamp function exist? Interesting question. But I mean, first of all, ReLU is clamp, right? It's just a general. This is just a general case, and clamp could also be used for gradient clipping, for example. You wouldn't want the gradients to go outside a specific interval, and then the clamp function might be useful. But I mean, they probably just have ReLU as an implementation of clamp, but they have it as the ReLU name because it's just such a common operation to use. But it didn't make much sense. Why do we need such a weird thing? TensorFlow doesn't clamp anything during matrix. Why does PyTorch? Clamp means 0 is exactly ReLU. Oh, I see. So there is no ReLU function. We just use clamp. I was very confused because I was trying to implement linear regression and there was a random clamp command in most examples I've seen, which was confusing to me. Of course, there is ReLU is in PyTorch is torch nn functional ReLU. So import as f.ReLU. Yeah. Or to clip the weight values in Wasserstein. I'm not sure what Wasserstein is. Yeah. There are definitely use cases where you want to use clamp. So the clamp exists because it's useful. Simple way to inverse transform normalization. Yeah, I've had this actually. If you use normalization, you would have to, I mean, you can mathematically just check and reuse the normalization layer, and then that would work, but it requires you to do some computations by hand, essentially, to figure out by which values you should normalize again. But perhaps there's a simple way of doing it. So we send in a mean, we send in a standard deviation, and now we want to get it back. And this was an example where I was using a NST, so neural style transfer, and I was normalizing, which screwed up the visuals of the image. And then when done after neural style transfer, I wanted to convert them back so that the colors are sort of looks good. And yeah, that was where I was encountered this problem. See, did you find any solution? Image generating looks very dark, but yeah, you could just use normalize again. You would just need to do some calculations for it. Yeah, this feels like it's a bit more. I would rather just use normalize again and compute the values for it. But yeah, that feels a bit more. Yeah, so you would compute this formula, and you would just check what are the values that I need to use to do normalization again. But I feel like if we had I feel it would make more, I mean, if we want to make things as abstract as possible, there should be a denormalization. And then we just send in the exact same values, and then I think that would make for more readable code because the values would be exactly the same. If we're using a formula like this, then the values are different, and that might, when the reader is going through some code, they might be wondering where these numbers come from, and then they would have to figure out the formula for where they actually come from, and that would just waste some time. But yeah, that's how you do normalization anyways. Or inverse the normalization. All right, next up, how do we append to a tensor? I think you should just be able to do append. All right, so you can use torch.cat. I mean, that makes sense. So torch.cat is super efficient and basically bandwidth bound. It's not time. So torch.cat is what we should use. But I think if I remember correctly, I've seen torch.append. That just might be me though. All right, so I haven't seen that. Seems like. Yeah. use torch.cat for appending to a tensor. What are the equivalent of TensorFlow sigmoid cross entropy with logit in PyTorch? Yeah, cross entropy. Oh, okay. No. KLD loss. I've never seen that before. PyTorch pullback labeler divergence loss. Okay, so it's similar to this, the negative log likelihood. It's a difference. We're computing. Yeah, I would need to spend some time to understand exactly how that works. All right. Next, we're going to look at some examples of how to use batch norm, or look at that post. I'm going to take a break and I'll come back. I guess for you, it's just going to be a second, but for me, it's going to be 10 minutes. All right, let's continue with these questions. Example of how to use batch norm. So I'm thinking, what exact size should I give the batch norm layer if I wanted to apply to a CNN? Well, I think that's what you want to do. Batch norm, you don't have to do anything. You just initialize it with the number of channels, and then you just run it through. So for example, you did like this. You specify the number of channels, batch norm of 20, and then you just send it through. One thing is that you want to ReLU after your max pool. You have to specify how many feature channels will your input have, because that's the number of batch norm parameters. Batch and spatial dimensions don't matter. Batch norm will only update the running average in training mode. So if you want the model to keep updating them in test time, you have to keep batch norm modules in the training mode. Yeah. About ReLU max pool, if you think about it for a moment, both ReLU and max pool are equivalent operations, with the second option being 37.5% more efficient. ReLU and max pool. Yeah, them. Yeah, if you do max pool first, but they are all okay, so they're actually equivalent. Those are equivalent operations. I mean, that sort of makes sense. So you would want to do max pool, then ReLU. Oh no, okay. ReLU and then max pool. Let's see, they do ReLU and then they do max pool. That's more efficient. I was thinking the opposite, since if we do a max pool, we're going to, especially using if we strive to, we're gonna have the number of values. So then when we do ReLU, we're gonna apply the ReLU on less values. All right, let's keep going. For the ReLU max pool, I agree with this. In this case, they are equivalent. However, in the more general case of an arbitrary activation function, they will not necessarily be considered a ReLU function that is flipped and exists on the second and fourth. All right. So that it's not a general thing, it's only leveraging a property of the max operator. Yeah, I guess if you send in ReLU, if you do ReLU and then do the max pool, the elements are going to be the same, since ReLU doesn't change the max value. And or if you do max and then ReLU, yeah, okay. Yeah, I understand that it's not the same, but I'm a little bit confused why it's more efficient. But also the example showed, yeah, my thinking is that you should use max pool and then ReLU, because then you're essentially halving the numbers, and then ReLU will be applied on less values. What do you do during test time? How do you set for props so it doesn't update different weights? Do you want to freeze the running averages? You do .eval. How to keep the batch more in evaluation mode during training? You can set freeze batch norm by setting requires grad to false if you want to do it during training. Oh, setting requires grad only freezes the parameters, but not the case for the moving averages. I need to freeze them all. You need to set the batch norm layers to evaluation mode. I have a pre-trained model whose parameters are available as CSV files. This model has a batch norm layer which has got weight, bias, mean, and variance parameters. I want to copy these parameters to layers of similar model I have created in PyTorch. But the batch norm layer in PyTorch has only two parameters, namely weight and bias. How do I deal with mean and variance during eval? All of these are used. All right, but we do model.eval, but that also changes the dropout. If you own, I mean, I can't see really why you would want to do this, but if you only want to use the batch norm, do the batch norm, but not the dropouts. Yeah, all right, let's just skip that. Also, one thing of how to use batch norm, you might be interested how we would see. Let's say we take VDG, how we would use the batch norm with ReLU. And how you would do that is you would define your comp layer, you would run it through the batch norm, and then you would do ReLU. That's the way that it's intended to be used. And if you think about it, you would want to compute the average the moving averages with the batch norm, and then use the ReLU on top of that, because if you use the ReLU on top of that, that might ruin the moving averages. All right, but what happens if we put batch norm in evaluation mode? Does it use mean rev of the whole data set for the evaluation? And during eval, the running estimate will be used, which were updated during training using the batch. You can see these stats using batch norm running mean and batch norm running variance. Since these running estimates do not depend on the batch size anymore, you're fine using single samples during validation and testing. Yeah. All right, so what could be, so examples of how to use batch norm is you initialize it with the number of channels that's output from the previous comp layer. You first run it through the comp layer, you run it through the batch norm, and then you would do it ReLU. And there was some examples previously where you would do max pool and ReLU, and then you could do it in opposite order, but that doesn't really have anything to do with the original question, I guess. And the original question you would, I feel we've covered the original question, so let's go back, and not that much back. So we need to scroll down. All right, and now let's see. Inferring shape, we have flatten operator. Yeah, and I was kind of thinking that way. So instead of using view -1 320, yeah, and this is normally how I do it too. I just use x.size 0 for the batch, and then -1 to have those just flatten the rest of the layers. You could also use x.shape of 0. Yeah. All right. Which device is model tensor stored on? And we've covered this. They should just use type of tensor. But this is how you would convert it to the GPU or CPU. But to check where it is, you can do myTensor.getDevice. But you could also do type of tensor. So I mean, let's see, what is this question actually? To work efficiently, I need to know which device it's currently using, CPU or GPU. So you could use, what was it? You could use get device, myTensor.get device. But I feel like you should also be able to just do type. And also doing, you know, .to device on the model. Should also make sure that it's on the, GPU. You could also do it like this, yeah. Is Cuda. Yeah, and this is sort of how you would do it in the normal way. You would use device equals Cuda if Cuda is available, else CPU, and then you would do model.to device, and then that would make sure that it's on the GPU. But you could check it with this, and you could also do, I think you could also do type of tensor, and get device, I guess, also works. Yeah. And also if you have tensors, you can do .to device. And all right. You could also print a device of one parameter by doing next of model parameters and then .device. All right. But get device seems, sorry for scrolling so much, but this also makes sense to me. All right, let's see if we find some interesting questions. All right, how to speed up the DataLoader. Let's see. How I want to know how to speed up the DataLoader. I'm using torch with number of works to 8. The log shows that DataLoader takes at least 50% of the training process. I want to speed it up by reducing. I analyze the time for the DataLoader get item. Shows that reading image takes most of the time. I read 3 images in this section. I use the code for dataset image.open and convert to RGB. Therefore, I tried how to speed up the loading. I saved the images as strings with pickle in IMDb. Then I load them back. I found that doesn't speed up. Maybe pickle.loads still costs too much. Now I have no idea how to speed up. Any hint will be useful. A database is good optimization when your data is huge text file, but for images stored in individual files, it is probably overkill. Another point is to consider that pickle might be able to save or load PyTorch tensors. As you say, the image decoding seems to take most of the time, so I would suggest writing a small script that loads each image file into a torch.tensor and then use torch.save to save the result back into a file name. All right, I mean, that's seems like a good idea perhaps. If the loading of the image takes a lot of time, then you could load image, save the tensor, and then just load the tensor instead. And then you would want to modify your loader to load the image file instead. All right, in my experience, I would first build an HD5 with all your images, which you can build easily following the H5PY. During training, build a class inheriting from which returns your images. All right. Okay, so that's interesting. You can use HDF5 with your images. Got it. Once I save preprocessing as a PT format, it will load the tensor directly. How can I do random crop and resize? Yeah, this is gonna be difficult. You can't. I hadn't thought of that problem. I can think of two approaches, but I can't tell you which will work the fastest. Convert each image into .bmp format instead of .jpeg. Then use your original loader to load the .bmp, which will decompress much faster than JPEG. Use torch and .pil image, which I think should run pretty fast. All right. All right, so using HDF5 seems to have some issues when using several workers. I often use one worker because my networks are computationally heavy and I'm not limited by DataLoader. Perhaps you should try other approaches like ZAR. All right, which are designed to be thread safe. I'm not sure if the problem is same as like mine, but I have a problem when reading very big files, 3K by 3K. This is your example. This is my advice. Can you divide images to smaller subregion, for example, 1K versus 1K? If yes, just make some crops of images to make it smaller than reading speed. Yeah, so if you use smaller images, then it's going to be faster. You can use JPEG for PY library dedicated to encode big JPEG files much faster than PIL. All right. So you can use another library which is faster to encode the files than the PIL library. The fastest available option, which I found, is using JPEG for Python library created with OpenCV data augmentation, so no PIL image. It still feels a little bit complicated. There should be a simpler way if you really want to optimize it. And also, why isn't PIL fast enough is also another question that feels a bit weird. After reading some code, I find that it does not work like Cafe, which prefetches next batch data during when the GPUs are working. I found a blog which tries to do this. I will try it. After I read the blog, I made a mistake which the DataLoader tries to prefetch the next batch data, but I find that it cannot make full use of CPUs. It showed that it only used 60% of ability of the CPU. And the blog showed that the data pre-processing takes like 80% of the time. Actually, if it could fully achieve its target, made full use of CPUs and the disk is fast enough, it should be near 0%, not 18. All right. Have you finally fixed this annoying problem? I have the same issue when I set number is greater to 0. No, I don't fix this bug. Now write another process that prepares data on the fly when the GPUs are running. But isn't that what the DataLoader does? All right. Check out potential solution to the HDF5 DataLoader concurrency issues. For anyone reading, NVIDIA DALI is a great solution. What is NVIDIA DALI? A library containing both highly optimized building blocks and an execution engine for data preprocessing in deep learning applications. Let's check that out. All right, that seems interesting. I was running into the same problem with the PyTorch DataLoader. I couldn't seem to get about 250 images per second. On a Google Cloud instance with 12 cores and a V100, I could get over 2,000 images per second with DALL-E. However, in cases where the DataLoader isn't the bottleneck, I found that DALL-E would impact performance by 5 to 10%. So if you find that the DataLoader is the bottleneck, then using DALL-E seems like a good choice. Let's see. I mean, we have 10 posts left, so perhaps there are improvements, because this is in 2019. So about 1.5 years ago. And DALL-E also has CPU, meaning no GPU performance hit. All right. Were you able to speed up your data? Did you try preparing the data while GPUs are running? I just found this thread a few days ago and implemented NVIDIA DALL-E to load my data while doing some transfer learning with AlexNet on an Amazon ABS, whatever. I don't know what this. Let's check that. Probably know what it stands for. Amazon Web Services. Okay. P2X large 8 Tesla K80 GPUs. Using DALL-E speeds up my epoch time from 480 seconds per epoch to 10 seconds per epoch. No need for any code that explicitly prepares data while the GPUs are running. One important thing to note is that if you're using DALL-E data load from an external source, you have your image class grouped by folder. You have to manually reset the data loader using loader name.reset. So this is I would need to spend a lot more time just checking how DALL-E works and set up the data set loading and all of that. But this is sort of the overview of just the interesting idea that there might be become a problem that we want to speed up the data loader. And then the question is, how do we do that efficiently? And so now we're just sort of getting a few ideas of how to do it, not exactly, step by step how to do it, because that would be a tutorial video where there's probably 2 days spent just figuring out the best way to use DALL-E. Now it's more, DALL-E exists. But anyways, you have to manually reset the data loader using loader name.reset at the end of every training epoch. That's not how the PyTorch data loader works, so it took me a while to realize what was going on here. The only irritating thing I've found about DALL-E is that there's no immediately obvious way to me to convert pixel values from uint with a 0 to 255 range to float with a 0 to 1 range, which is needed to transfer learning. Dividing by 255 within a pipeline runs into data type mismatch. All right. I also meet with this problem. Do you have solved it? I want to train Resin 15 ImageNet. Did you try the NVIDIA DALL-E? I'm facing the similar problem. However, I'm interested in knowing how to make my data loader efficient. Ideally, I want to read multiple temporal blocks for a video, perform transformations like random crop, rescale, extract i3D features for them, concatenate them in a tensor, and return with other information like text embedding for question and multiple answers. For now, I am pre-processing my videos and extracting features beforehand, which does not allow me to use multiple random crops and not a good way. The video frames are 60 gigabyte size in total. Any tips? I wrote the code of prefetching and I confirmed that it improved the performance of DataLoader. My code is based on implementation here. Quickly see what that is. What are we looking at? What was the apex for again? Yeah, that was the mixed precision thing. All right. Or if you run the program on your local machine, I highly recommend buying NVMe drive. This investment completely solves the problem of slow image loading. Huh. That's interesting. All right. But DALL-E seems to be the way to go. All right. All right, so those are some ideas of how to speed up the DataLoader. Torch.repeat and torch.expand, which to use? Backprop wise, they will give the exact same result. The difference is that if the original dimension you want to expand is of size 1, you can use torch.expand to do it without using extra memory. If the dimension you want to expand is of size more than 1, then you actually want to repeat what is at that dimension, and then you should use torch.repeat. If we'll use extra memory, there's no way around that. All right. I have one vector and one 2D vector. Now I want to expand embed 1. All right. It's actually torch repeat. Search for it. Number of times to repeat this tensor along each dimension. Okay. And torch.expand. Returns a new view of self-where with single dimension expanded to a larger size. All right, so if you can't use torch.expand, that's better. If you use torch.repeat, then it's going to require extra memory, but there's no way around that since you want to repeat it. So when expanding a dimension of size 1, torch.expand should be used instead of torch.repeat. Okay. Okay, and he has a self-containing, he has an example here. All right. Conclusion, use expand if possible and repeat if you can't. Cuda out of memory. All right, so this is an error I've encountered many times, and most of the times, 99% of the times, is because you're loading a model that's too large, or you're training a model that's too large for your GPU memory. But it could also be, so it could also be that you're caching intermediate results and they prevent the graph from being freed. Yeah, we don't want to read through his entire thing here, but he's probably storing them in lists, something like that. And by doing that, he's storing the intermediate results, which can't be freed by the garbage collector, so that they are still taking up CUDA memory. If you know you're not going to use the intermediate, it's safer to keep references to tensors only. What do you mean by keeping reference to tensors only? When you do this, self.output all OP, OP is a list of variables, i.e. wrappers around tensors that also keep the history. And that history is what you're never going to use, and it'll only end up consuming memory. If you do that, okay, so instead of referencing variables, yeah, because those variables are gonna have an history data, and that's not going to be cleared since you're now having variables that are referencing those. So you're gonna have something that reference those tensor variables. If you instead do o.data, but I think you shouldn't do this. We'll see what they say, but if I remember correctly, you should do o.item, something like that. You'll only say the tensor values. Use Volta if you're going to run in inference mode. This will save a lot of memory. I'm starting to get the hang of variables work in PyTorch. Thanks. I'll start freeing some variables and let you know. Try a recommendation that made the process super fast, but it prevented me from backpropagating because the resulting loss is not a variable type, but a float type. I'm struggling to understand why it's running out of memory with 12 gigabytes. I'm thinking there's a bug in PyTorch. Yeah, I'd be skeptical. It's like saying, like, when you've done a math problem and you're like, must be something wrong with the book, but most of the time you're just doing it wrong. I mean, I have no idea what he's doing wrong, but all right. When I run htop, it's only taking up 2 gigabytes. Somehow there's something triggering the errors. I was running the other CPU version with a large data set, and this came out. There's not enough memory. Try to allocate by new RAM. Buy new RAM at. It should be funny if this was a link, just so you can go and buy more RAM. This is weird considering how I have more than 60 gigabytes of RAM. It means that the allocation has failed. You didn't have enough free RAM at that moment. Since you're running low even on CPU memory, it doesn't seem surprising for me that it also fails on the GPU. If you think there's a bug, it would be very helpful if you could isolate the minimal portion of the code that would allow us to reproduce the error. This is a self-contained script where you can run. It works with a small number of hidden states, but once it reaches 1,000, it gets problematic. Why do you think it should work with a history size of 10,000? There requires a lot of stuff to keep around. You can't expect a framework to work with arbitrarily large inputs, and that sounds like that could raise an out-of-memory error. Yeah, another paper implements such a way which requires X number of hidden states. Read these notes to be more efficient. Autograd mechanics. Just know how Autograd works. All right. Freezing layers. How Autograd encodes the history and plays operations. Multi-threaded. I haven't actually read this one. I should read this. Yeah, all right. I haven't read that one. But did he say inference here? Inference. No, I didn't mention that. Oh, did he mention volatile? No. All right. I'm having a similar, 2 years later. Bam, let's just scroll down. All right, but he did something, and you need to do accuracy.append lost value.detach, because otherwise you're saving the complete computational graph for, okay, so if you're just saving the loss value, you're saving the complete computational graph for every sample, which causes the out of memory. But yeah, so 1, you're loading too large of a model. 2, you have intermediate variables that you're not that you're storing somehow that are just not getting freed up. And yeah, those are sort of the scenarios that I can see. But I'm no expert on this. All right. How to do element-wise multiplication? Or actually, are there any recommended methods to clone a model? How about copy.dcopy of model? Yeah, seems like a reasonable approach. Are there any other ways? You need to use deep copy. New model is copy.deepcopy of model. Okay, so that doesn't work. Seems in the later versions, but pickle works. Can't, okay. All right. All right. I mean, copy.deep copy of model, but if it doesn't work for some reason, try pickle, and if the instance app, okay, you can convert them to a list. All right, but it seems deep copy model should perhaps work. How to do element-wise multiplication of two vectors? Yeah, you can do A star B, but yeah, and you can do or torch.mol. No, that doesn't give the dot product. Torch.dot gives the dot product. Yeah, you must have made some other mistakes. Yeah, that's how you do it. All right, how to perform identical transforms on both image and target. Semantic segment and edge detection are 2D images. One must perform the same transform. A simple search on Google will give you this. So I'm not really that, I haven't done image segmentation. So I'm kind of don't have that much experience on it. So, but perhaps we can understand how they solved it anyways. Or I guess just if they solved it. All right, let's see what they said in the thread. Okay, so they have on the tutorial, they have a way of doing transform for both the data and the target. The question hasn't been answered. The provided reference don't show the ideal practice to identical for both input and segmentation image. Alternatively to the functions from the tutorial, you could use Torch Vision's functional API. Here's a small example. So you have some transforms in your custom data set, and you just make sure that you do the same operations. Yep. Makes sense. But what is TF? Torch Vision functional API. Okay. I haven't imported that one, but we can see how we do that. PyTorch. import torch vision.transforms.functional as TF. Torch vision functional. Yeah. And you would do it in this way. And you would just do whatever transforms you want. Makes sense. What is TF in your code? Torch vision.transforms.functional. Yeah, but it also seems that you can do from the custom dataset tutorial, there's also a way to do it identically. Perhaps we can check that as well. We can here. Same. All right, let's just do it. Our dataset will take an optional transform. I feel like it's definitely a special case. So does it talk about that? For both data and target. Target. All right, it might take too long to read through this. I was thinking maybe we could just skim and see. It talks about doing the same. All right, observe below how these can be applied both in the image and the landmarks. All right, so he does a separate class. You send in a sample, and you would have them both, and you would do all of the transformations. Essentially, he created his own transforms, and you would send in, yeah. And you would send, if self.transform, you would send them through of this sample, and the ones he used are built so that they work on a sample rather than a single image. Essentially, you have to do you have to do custom transforms as well. Yeah. That's interesting. So, but I think those give some pretty good ideas on how to do it. So let's just continue. Random seed initialization. I have a problem regarding a large variation in the results I get. By running my model multiple times, the exact same architecture and training gives anywhere from 91.5 to 93.4 accuracy on image classification. The problem is I don't know how to use the torch.random to get the better results. Yeah, so this is one thing. You can't just, to get reproducible results, you can't just set the manual seed of the torch. If you're using NumPy, you're going to have to do that as well. If you're using random, PyTorch random, you would have to set that as well. But you can't just use that. You also need to set manual seed for torch.CUDA. So perhaps they mention it. So torch.manual seed, and you would also need to torch.backends CUDA deterministic. And I guess if I've seen one other of this CUDA and deterministic, but perhaps I think this is related to them finding algorithms that are optimized to your PC or your specifications on your computer. But you can set it to deterministic. Torch CUDA manual seed. If I remember, you also need to send in some seed for your data loader so that you load the exact same images. Yeah, remember that NumPy should be seeded as well. But we can go to the documentations. I think they have a better answer. So you need to do torch.manual seed, both CPU and CUDA. Then you got to do deterministic equals true. You need to do CUDA.benchmark equals false. Oh, okay, yeah. The benchmark is for the specific to your device. And then the deterministic is just, okay, so that has to do with the algorithms that are behind the optimization, I think. There might be stochastic, what is it called? Like algorithms that are based on randomness that on average perform better than deterministic algorithms. And if you're using NumPy, you should also use NumPy random seed. And you should also use random seed for Python. And honestly, I think this was too few. There should be more, I think. That's a good start. So manual seed, set the random seed of NumPy, set random seed, set torch.manual. If you're using a GPU, set CUDA manual seed all, CUDA enabled. Okay, I'm not sure what this does. And then CUDA benchmark, false, deterministic, true. So if you use these are going to let you have reproducible results. Also in the DataLoader, I set number of workers equal to 0. Yeah, exactly. So here you would need to do init fn, NumPy random seed, manual seed, and then worker init fn, you send in that as well. All right, so this is a pretty good answer right here. I think if you use that, you're gonna get pretty much exact results. Num workers equals 0 and torch backend CUDA enabled false are the real thing that works. All right, so num workers equals 0 is also one thing. Yeah, and all of these are the things that he mentioned above. Setting the data loader like the following. Yeah, where you need to specify the worker init and you need to specify the number of workers to 0. Yep. Clear and concise answers. All right, let's see these. PyTorch coding conventions. Hello, I am new to PyTorch and I'm looking for some PyTorch coding conventions or best practices. PyTorch is fantastic to allow you a lot of freedom. Yeah, definitely, but it can sometimes be challenging to find something in someone else's code when they've done a completely different way of coding with PyTorch. Yeah, this is one thing I kind of agree with. PyTorch sort of gives you too much freedom. They give you maybe 5 different ways of doing one single thing, and they could all be equivalent, or perhaps one is a bit faster. If you really know the details of how it's implemented, you can know that one of them is a little bit more efficient. But anyways, what I wanted to say is that it feels sometimes like there's maybe 5 different ways of doing it, and if they could restrict, but I guess they wouldn't want to do that because there might be use cases that I'm not aware of. But it just feels like there should be one good way to do it, and that's the way to do it. And then the other ways sort of should be I don't know, removed maybe, or discouraged. But anyways, there might also be some best practice to ensure your code can run as fast as possible. I'm thinking about something similar to serialization semantics, but describing more straightforward cases such as which context should one create a separate module. The goal is that anyone who knows the coding conventions can easily find what they're looking for in the code and extend it in a way other people are able to understand it quickly too. Yeah. Thanks for... Oh, okay, so he had a semantics. Oh. Best practices. Yeah, save. Load state dictionary. Yeah. Save. All right, but I mean, this was all right. This was the reproducibility. Yeah, all right. I feel like these sort of things are I mean, I kind of understand the questions, like the question in that is there sort of a coding convention of how you should do things? I mean, let's just take the example of, should you use nn.ReLU or should you use the functional package? Should you use f.ReLU or should you use nn.ReLU? I've seen people use both, but there should be sort of a coding convention in how you, maybe there is. I mean, that's what he's asking for. Anyways, so I feel this sort of answer, I don't know. I feel like this is like low-key rude. Like he's asking a question, and if you don't have anything good to say, then don't answer. Thank you for your answer, but it doesn't answer my question. I found something closer to what I'm looking for here. All right. Best practices of PyTorch. Move other tabs. This can actually be interesting. So this is not an official style guide for PyTorch. This document summarizes best practice for more than a year experience with deep learning using the PyTorch framework. Note that the learning we can share. Yeah, I mean, this is a great idea. All right, we recommend using Python 3.6. All right, naming lower with under, classes cap words, class DataLoader, constant caps with under. I don't do this actually. I don't know why. I don't like caps, but this wasn't really what I was thinking, but this is I guess a good idea too. Variables lower with under, methods lower with under. Yeah, all right. IDEs, we recommend using Visual Studio or PyCharm. Visual Code provides syntax highlighting and autocomplete in a relatively lightweight editor. PyCharm has lots of advanced features for working with remote clusters. You can set up PyCharm to work with a remote machine. I've never done these things, so, but. All right, our recommended workflow is start with a Jupyter notebook, explore the data and the models, build your classes inside a notebook, move your code to Python scripts, train deploy on a server. Libraries, you have Torch, basic framework for working with neural networks, creating tensors, networks, and training them using Torch Vision. Well, this has vision data sets and stuff like that. And they're also used for data preprocessing, augmentation, post-processing. Pill, loading image and storing them, NumPy, TQDM progress bar. I haven't used that, but that would be interesting. Torch summary display network, its parameter and sizes at each layer. Tensor board, yeah. Don't put layers and models into the same file. A best practice is to separate the final networks into a separate file, networks.py. Keep the layer losses up in respective function losses up. Okay. The finished model composed of one or multiple networks should be referenced in a file with its name. The main routine, respective the train, should only import from the file having the model's name. Building a neural network in PyTorch. A network is using nn.Module. A simple network in PyTorch. Yeah. Yeah, this is very clean. I mean, this is even better than that actually makes a lot of sense. When I did my implementation on ResNet, I followed the PyTorch how they had done it, but I think that's a lot better actually. Since here, let's see, with the block right here, we're doing identity x.clone here, but this makes more sense. I think we have this self-com block right there instead of doing this. So I think or well, it's actually, I would need to spend some more time, but I think using it in this way makes more sense. Just felt like this could be a more clean way of doing it. Yeah. All right, and custom loss function, even if PyTorch has a lot of standard loss function, you can create your own. Yeah, and just use tensor operations, basically, for loops or stuff like that, from my understanding, and then Autograd will be able to keep track of it. But even if you use for loops, maybe you I'm not sure. I need to actually investigate that more. And then TQDM for the progress bar. Training on multiple. Don't use .data, use .item. How to keep my experience reproducible. But this we just saw a post on this. This is not enough. You should do more than this. Yeah, you need to do these things. You just set the Cuda seeds and all those as well. Oh, that's interesting. So you're using Cuda benchmark equals true is faster. Wonder why I'm not using that. How to improve training inference speed. On NVIDIA GPUs, you can add the following line at the beginning of your code. This will allow the code to optimize your graph. However, if you change the network input output tensor size, the graph will be optimized each time change occurs. This can lead to very slow and out of memory errors. Only said if your output always have the same shape. Okay. That's interesting. All right. That was some interesting stuff. Let's see if there's more. I don't think there are some documents, but if you go Python, I recommend to follow the PEP8 style. Don't use Autograd if not necessary. Use with torch.grad if possible. Only push tensors to GPU if they're actually needed. Try avoid loops over tensor dimensions. Slow things down. Try to free graphs as soon as possible. Alright, a couple of PyTorch specific items I disagree with. In the top 2 below, my list would be something if you need to use torch.grad somewhere where it isn't because you're evaluating something that's written for training, you should ask yourself if you're doing it wrong. Yeah. Be mindful of loops over tensor dimension. It's a convention to avoid these, but there are quite a few legitimate cases for them in PyTorch. I have a half-written section for loops discussing them somewhere. That's interesting. Using item and detach for keeping around is generally a good idea, but be careful not to ruin your graph. If you write for reuse, functional module split of PyTorch has turned out to be a good idea. Use functional for stuff without state, unless you have a quick and dirty sequential. Don't use deprecated stuff. .data, tensor, .type. Oh, okay, you can't use .type? Alright. Use the documented PyTorch interfaces if you can. Benchmark your step if you think its performance is critical. Don't forget Cuda needs synchronizing. The JIT will speed up chains of pointwise ops a lot. Yeah, I can figure that out, but all right, so we can check JIT for PyTorch. Torch script is a way to create serializable and optimizable models from PyTorch code. I need to figure it out more. I need to figure out a bit more about JIT. I've known that I want to do it for a long time, but yeah. All right, that was a detour, but that was interesting. All right. Accessing weights of a specific module in nn.Sequential. So if you have nn.Sequential, yeah, you can just do model2.layer and then 0 of that weight. All right, interesting. So he did self.layer is nn.Sequential, and you can just just use model and then model and then .layer, because that's the self.layer that he used, and then you can just index for the specific one that you want and then .weight. So that was pretty nice. Should ReLU sigma be called in the init method? And so this is, yeah. I mean, we've sort of touched on this if you watched the previous posts, but this has been touched on multiple different posts. But yeah, so the question is, should you do it like this? But if you do it like this, you should probably define it, right? Self.ReLU is nn.ReLU here, and you can reuse it. Yeah. Since nn.ReLU is a class, you have to instantiate it first. This can be done in an init method. Or if you would like in the forward, you need to do nn.ReLU and then call it. But yeah, you would create an instance in the init function. Alternative, if you don't want to create an instance because it's stateless, you could directly use the functional API in forward. And I think sort of our general guideline that we saw in a different post is that you should use f.ReLU, but for things that depend on the model state, if it's in testing or evaluation or training mode, like dropout, batch norm, you want to initiate those with the nn and not with the f, with the functional. Let me repeat the question differently. What is the PyTorch idiomatic way to use ReLU and why? I think the answer is to use f.ReLU. The why part is important. I'd like to hear a full answer. Yeah, so we saw the guideline on the other post that Adam, I don't remember his name full, but his name was is Adam, and he said, if I remember correctly, he said that if you're not using stuff that doesn't depend on the state of the model, then use the functional. If not, like dropout, etc., use nn dropout for those. Yeah, my personal preference is to use the functional API in the forward for stateless, e.g. f.ReLU, since nn.ReLU doesn't store any parameters, so it's not really necessary to define it in a module way. However, there is one exception when I prefer the module, and that's when I know I will try out different activation functions in the forward pass. So instead of changing the f.ReLU to another, I use a definition like and just switch self.act for another module. I think it just comes down to preference, since I think neither. Yeah, I mean, this makes sense. If you're going to use different ones, you would definitely want to, since you're going to be reusing it multiple times, you don't want to change all of them. That would just be unnecessary time. It just comes down to your preference. I don't think, I think neither of both approaches is bad in any ways. All right, my point isn't about coding style per se, but it's more about the correct PyTorch semantics. All right, we don't have to read all of that. Let me try to boil it down to the standard and possible change this approach. In the standard use case, you're writing some kind of model with some layers. The layers hold most likely some parameters which should be trained, and then conv would be an example. On the other hand, On the other side, some layers don't have any trainable parameters like nn.Maxpool. However, usually also these are created in the init. Other layers don't have parameters and can be seen as simple functions instead of a proper layer, at least in my opinion, like nn.ReLU. In your forward method, you're creating the logic of your forward and thus also the backward pass. In a very simple use case, you would just call all created layers one by one, passing the output of one layer to the other. However, since the computational graph is created dynamically, you also create some crazy forward passes, e.g. using a random number to select a repetition of some layers, split your input into different parts and call different submodules with each part. Use some statistics of your input to select a specific part of your model. You're not bound to any convention during this as long as... Alright. For me, this is the most beautiful part of PyTorch. Basically, you can let your imagination flow without worrying too much about some limited API which only calls layers in a sequential manner. And this is also the reason to break some of the conventions I've mentioned before. Think about a specific use case where you would like to use a comp layer, but for whatever reason you need to access and maybe manipulate its weights often. The first approach of creating the layer in init and applying it in the forward would certainly work. However, the weight access might be a bit cumbersome. So how about we just store the filter weights in nn parameters in init and just use the functional API in the forward? Would that work? Sure. Since you've properly registered the filter weights in init, they will be trained as long as they're used somewhere in the computation during your forward pass. As you can see, they're somewhat advanced use cases, and I wouldn't say they're breaking some kind of PyTorch semantics. Using the functional API is totally advanced for advanced use cases. I would not recommend you use the function for every layer from now on. It's much easier to use nn modules in most use cases. Have a look at implementation of torch vision models. You will see all kinds of different coding styles depending on the complexity of the problem. While simple models might be implemented using nn.Sequential blocks and just calling them forward, other models will be implemented in a different manner using more functional calls, for example inception. Since it's a bit more complicated to split and merge the activations as well as getting the AUX loss. To sum it up, the auxiliary loss. To sum it up, my 2 cents are: use whatever feels good and easy for you. Although there are some standard approaches for most use cases, I have to say that even working with PyTorch for a while now, I probably changed the one or other coding style every few weeks because I certainly feel the coding logic is easier to follow using this approach. If you ask 10 developers to implement Inception, you probably get 10 different but all beautiful and useful implementations. I mean, that's a good response. There was few stuff here that I didn't really understand. Right, so I think this part right here. Think about a specific use case where you would like to use a comp layer, but for whatever reason you need to access and maybe manipulate its weights often. The first approach of creating the layer in init and applying it in forward would certainly work. Yeah. Alright, just something to think about. How to clear some GPU memory. Let's see. Yeah, you can use del. So you have something like this, and you can use del. But I wonder if this still works on the newer PyTorch. All right, I think we've touched on this area on multiple posts as well. So this is definitely something that. All right, so in newest PyTorch, you can use torch.cuda.empty cache to clear the cache memory. And I've also seen this setting volatile to volatile equals true, then I think it should. All right, so whatever, you shouldn't use Cuda empty cache. What should you do? All right, it feels like this isn't super clear. There should be some tutorial on how to clear GPU memory, I feel. But yeah. So I guess you could try doing this. You could also try using volatile. So I've seen this before. They've mentioned this as well, but here they don't actually talk about it. So people referenced this. All right. Perhaps you can't use volatile anymore because I can't see it. But torch Cuda empty cache is one way. But yeah, you need to remove unwanted references to variables. That's the first thing. And then empty cache should work. Let's see the memory management stuff. So calling empty cache releases all unused cached memory from PyTorch. All right. Cuda semantics. Yeah, this is pretty good. All right. We've touched on that on multiple, but yeah, that's one thing I've seen multiple times. All right. Runtime error, expected object of scalar type long, but got scalar type float when using cross entropy loss. Let's see. All right, so he's using nn linear and he's sending it to cross entropy, but it wants long, but got float. And I think that's the target values. They just need to be they need to be long. So he should just do dot long. But let's see. The output layer should have the number of classes as out features. Currently, your output layer only returns one neuron, which corresponds to class 0. For a binary use case, this should work. And he has cross entropy loss. And yeah, the target right here is dtype equals torch.long. So target should be of type torch.long. Try to fix the shapes and call target.long. That should make that should also be quite simple, but you could also initialize it like this and initialize it at long as long. Yeah. I fixed the problem of screening the target tensor and passing float as dtype. All right. How to add a L2 regularization term in my loss function. You would do weight decay on your optimizer. You can check that real quick. Set weight decay parameter to a non-zero in your optimizer. Yep. The PyTorch blog, a tour of PyTorch internals, is out of date. how to know more about the PyTorch internal. And this is something I really want to learn more about. So this is interesting to me. I'm starting to read the source code of PyTorch recently, but I'm totally lost. The tutorial part 1 introduced the tensor type, but disappeared. All right, so sorry for the post being out. Currently, I don't think there's a good guide on this topic, especially since we're in the middle of a big refactoring. We have something once PyTorch 1.0 is out. May I ask why you want to read the source code? Hi, I'm also interested in reading the source code. As a C++ CUDA newbie, I've also find it's hard to start digging into the code. The reasons are mainly because I want to understand deeper about PyTorch. Yeah, and that's the reason why I want to read more about but I think also that I would like to just understand PyTorch on the deeper level, and then, you know, as one becomes better and sees things they want to improve, be able to contribute. But to be able to contribute, you know, you actually have to understand the stuff. So, I mean, I guess there are multiple reasons why you would want to understand the PyTorch internals. But there should be a way to get people so that they can understand the PyTorch internals. Hopefully they have a guide on it. For a very quick and high-level description, Tensor implemented in the C++ 8.10, which also includes some old code. All right. So they have tensor operations implemented in that one. I'm not sure if, yeah. Just interesting to just see what that is. Yeah, this is not very... Okay, here you have some text, but this should... Oh, okay. Now I recognize stuff. Okay, so we can do... Sure. Alright, anyways. Tensor operations are implemented in the C++ library called 8.10. We are rewriting those for PyTorch 1.0. To connect 8.10 with Python, we have a lot of C++ code living under implementing things like Autograd.jit. What more? D-type device layout objects, in particular for Autograd, all right. All right. I have also made available a slide deck with some details about PyTorch internals. All right, that might be interesting to take a look at. Internal architecture tour. Yeah. Could also be interesting to take a look at. The slide deck says currently unavailable. All right. Tour of PyTorch Intern is a great article. Yeah, I need to spend some time to learn this. But anybody's looking for a new blog post, here's one. Yeah, I've seen this one. This is a new one. That's great. All right, this was the one I was thinking about when they said in the beginning, and this is great. So I think I'm going to read this one. Not now, but I'm going to go through this one and try to understand the, is there a part 2? All right, awesome. So if you want to learn about PyTorch internals, you should read this blog. It seems like this is I've seen people talk about this one on a different from different fronts, and I've written this so that I should read it, but I feel like I have a lot of basics that I need to cover, and this might be a bit advanced for me even at this. So perhaps I need to, but I'm definitely going to read this at some point. All right. All right. Output layer, no softmax. No softmax, because you don't have that because cross entropy loss. Because cross entropy, yeah. Upon digging into detail, the models are trained with cross entropy loss, which has softmax built in. Yeah. So that's why you don't have a softmax in the output layer, because it's already going through a softmax when you send it to cross entropy loss. Cross entropy loss is essentially softmax loss and then negative log likelihood. How can I do element-wise batch matrix multiplication? I have 2 tensors. I want to compute the element-wise batch matrix whose dimension will be 16 by 300. All right, you can just do, yeah, you can just use the asterisk, and then BMM would do batch matrix multiplication. But that wouldn't do it, yeah. That would do it element-wise for the first batch, with the first batch of the other one, and so on. But let's see, what is batch element-wise multiplication? But isn't that what this does? This is basically what torch.mul do. You may safely use it. Yeah. Yeah, you can also use it just with the asterisks. Yeah, all right. That's how you do it. How to give PyTorch layer a name. I want to give PyTorch layer a name so that I can easily select them. Right now I'm selecting them based on index. Yeah, but you would just do self-dub my name and then linear. All right. What's the problem with this approach? The only thing is when using nn.ModuleList and you want to give a name to each module inside the list, but I agree it's probably not worth to implement a possibly problematic naming system for this case. Yeah. All right. So if you're using ModuleList and you want to sort of name the blocks inside or the modules inside of the module list, All right, there doesn't seem to be a way to name. You would use self.layer name, and that's you would get it by using model dot and then calling that that self conv layer or whatever layer you define. Yeah. So yeah, that makes sense. You can't. How to prevent overfitting. How do you prevent overfitting when your dataset is not that large? My data consists of 110 classes with a total of 20k images. I've tried data augmentation. Yeah, so overfitting, just here are my thoughts. You would use regularization, and that would mean L2, dropout, data augmentation. Yeah, those are my thoughts. Add weight decay, reduce the size of your network, initialize the first layer with pre-trained weights from ImageNet. If you have class imbalance, use a weighted sampler so that you see all classes with equal probability. Yep. All right. This is a long time ago too. I mean, wait, is this PyTorch 0.1.10? And this is in April 2017? Man, things really are developing quite fast. I mean, this is 3 years ago. Pretty cool. Yeah. Get more data. Well, yeah. You need to use data augmentation or some regularization techniques. I mean, data augmentation is essentially a regularization technique. So L2 dropout, data augmentation, and in some cases the model. So changing the architecture. So if you disregard data augmentation, don't use L2 dropout, and let's say you're classifying images, but you're using fully connected neural network. Just by changing to a convolutional neural network, that will instantly improve the generalization of the network. So sometimes the architecture can also be a big problem. Yeah. And yeah, use a weighted random sampler so that you can get the you can sort of weight. Well, I talked about this in a previous post, but this was you can weight the so that it sees some classes more often than others. Yeah. All right. What is the difference between nn.ReLU and nn.ReLU in place? I implemented GANs using both nn.ReLU and nn.ReLU in place. Seems that it saved very small amount of memory. What is the purpose of using in place equals true? Is the behavior different in backpropagation? In place true means it will modify the input directly without allocating any additional output. It can sometimes slightly decrease the memory usage, but may not always be a valid operation because the original input is destroyed. However, if you don't see an error, it means that your use case is valid. I mean, that was a pretty good. All right, no error, good. So you should use I think you should use it as a default. So it's saves on some compute. Yeah, but yeah, so use it by default, and it's it's not creating a copy, so it's doing the operation directly on the input tensor. When number of workers is greater, there's a bug in the data loader. I don't think this should be an error. I'm just going to skip this one. Model.Cuda takes a long time. Even first model calling takes minutes. Oh, that's a very long time. I've noticed that it can take a bit longer, but not minutes. Well, where there's a problem with binary packet we've shipping, they only appear on certain GPU architectures. Would you mind sharing what's your GPU? I believe this has already been fixed, or reinstall might help you. Yeah, but this can take a bit longer. So if model.cuda takes a long time for you, it can take some time, but it shouldn't take minutes. And yeah, all right, it shouldn't. Feels like these are on the old versions of PyTorch. But yeah, this shouldn't be a problem in the newer ones. What is num layers in RNN module? That's essentially the height, right? We would, num layers is just RNN, it's just stacking RNNs on top of each other. So you get a hidden from each layer, and you get an output, and that output is then sent as input to the next RNN, which is on top of the previous one. So you would have something that looks like this. You would have some input, I guess some start token. You would have some input here, or you would have some embeddings. You would send it in. You would send this to an RNN. Yeah, I guess this would be the embedding. This would be the RNN cell. You would compute something, you would get some hidden state, you would send this to the next. You would also get some output, and that would be to the next layer of the RNN. Yeah. Yeah. How to convert a float tensor to a long tensor? You would just do, you wouldn't do this no more. You would do dot long. So let's, yeah, tensor.long doesn't change. So you could do tensor equals tensor.long. Early stopping in PyTorch. All right, torch sample provides an example. But there exists a early stoppage. There is an early stoppage in PyTorch. There should be. Maybe there's not. So torch sample gives an example, but I also feel like there should be. You could also, I mean, keep track of it. You could just check what is the accuracy, and then you would just save it manually like this. But yeah. PyTorch 1.3 wheels for Raspberry Pi. All right, so he's created. Oh, okay. I'm just gonna cancel that. All right, but that's how you can install PyTorch on. It says. See, install PyTorch on Raspberry Pi. Seems to be a guide. Because I feel like I want to use the latest. Yeah, compile it from source. So there's no official package for Raspberry Pi. But you can use precompiled wheel package uploaded by some of the most helpful souls out there. And that's exactly what we saw on the forum. Yep. All right. How to calculate the determinant of a variable. Yeah, you could use NumPy and use linalg.determinant, but I think you can now use, I think they cover it. These are old posts, but I do think they do cover it. Yep, you can use torch.determinant. How to print the current learning rate of the Atom optimizer. Yeah, you can do for parameter group, even optimize the parameter groups. You can print parameter group of the learning rate. But perhaps there's an easier way too. All right. How to normalize tensor to 0 mean and 1 invariance. You would check what you could use normalize. So to tensor, you have your RGB pixels and they are 0 to 255 in range. To tensor will divide by 255. Then you would compute the mean for each of those. After you have to tensor, you would check what is the mean of each of the RGB channels. You would then subtract with the mean, and you would also calculate the standard deviation for each channel. And you would then, so you would subtract the mean, you would divide the standard deviation. And that's exactly what normalize do for you. And then that would make it 0 mean and 0 yeah, I guess so they're the same. Standard deviation 1, and then the variance is also 1. How to convert an array to tensor? Well, you can just do torch from NumPy. Torch from NumPy, and if you want to make it to NumPy, you can just do tensor.numpy. And then, you could do, so if you do, you can use torch from NumPy and then send in the num array here. And if you want to do the opposite, you do tensor and then dot numpy like this. So this would be tensor and then dot numpy. What is nn.embedding exactly doing? So you would, so if you have a vocabulary, right? And so you sort of have a index value for each word in the vocabulary. Now, if you just have an index, that doesn't really tell us much about the word. If I say the word apple, you immediately know sort of what I'm talking about relatively to other things. So if I talk about apples, then it would be more logical for me to speak about oranges related to apples rather than talking about airplanes, because apples is a fruit, so that there are things that are related to that word and there are things that are less related. And so if we use an embedding, actually, I don't know why I'm talking about this, to be honest. Now, I'm talking about what embedding is, but I can just as well keep going and then we can talk about what an embedding is exactly doing. So for each word index, you would have a mapped vector for that specific word, so that it would kind of tell us relative to other things, so that it would give us a value of how much is this word a fruit, how much is this word an airplane, how much is this word yada yada yada. We can have sort of a fixed dimension. Obviously it wouldn't actually learn how much this is an apple, but you kind of get the point that having a vector could share more information about the word than simply having an index value. And that's what embedding is for. Now what nn embedding does, it just creates this matrix where we have a column vector for each of the indices that we have in our vocabulary. And then the dimension of it would just be the dimension, the embedding dimension that we choose. So let's say that we pick 300, then we would have 300 by vocabulary size. And all it does is it's a simple lookup table from indices to vector. Yeah. And you can initialize them in different ways, word to vec and glove vectors and so on. There are different methods of calculating or creating the embeddings. Yeah. Confusion matrix. I did fully connected neural network for 4 class classifications. How is it possible to calculate a confusion matrix? You could use scikit-learn implementation, or you could do the confusion matrix manually. I think doing manually is simpler. Let's see. Yeah. To calculate, you need the class predictions. Currently, it looks like so you would need the output. You do the predictions. You do the target, and then you can about confusion matrix here. All right, I guess he's then using some implementation of scikit-learn. All right, I would actually want to see how to do that, but you could use scikit-learn, I guess. How to customize an activation function. Yeah, I think you would just create a function. Yeah, if you can write it using torch mat operations, you don't need to do anything else than to implement it. And that's all you need to do. Modify resonant or VGG for single channel grayscale. I think I've actually done this when I made implementation on VGG from scratch or resonant. I made it so that you can choose the channels, and it should be quite easy. Well, we can also look at it. Yeah, so here, instead of having 3, you would just choose 1 if you have a grayscale. Yeah, and that's all you would modify. But yeah, he says, and I'm afraid there is no fine tune. You would be training from scratch. But you don't have to actually do that. You could load the entire model, and then you could just modify this specific one so that everything else is pre-trained, but this specific layer is not. So you could just replace this layer with the nn.Conv2d, and yeah, so I won't go into that again, but we've seen different posts on how to do that more in depth. Dropout for RNNs. So I think this is quite easy. We can scroll down, but there's in the later versions, there are, what? All right, so this is a very old post, but you can, I'm going to show you how you can do it. You can do to my GitHub. We can do, let's see if we go here. All right, but anyways, you can send in on the nn.GRU or the RNN, there's an argument dropout, so we can do nn RNN PyTorch here. Then you have dropout as an argument, so you can just, it's default 0, but you can just set the drop rate. Python IDE for PyTorch. Personal opinion, I've used Sublime for ages. All right, I highly recommend PyCharm. +1 for PyCharm, I use it every day. Emacs. So, I mean, people use all sorts of stuff. I find Vim best. Yeah, I can sort of see that. So I'm no expert at all in these things, but I've tried to learn more about it, and Vim seems to be a good choice. I like the fact that it's very minimalistic in that you just have a text editor, and in that way you're not really confined to having this it's a very expensive to run IDE, and not something that you can run if you're working with on a remote server. So for me, I really like the idea of Vim, and I think that learning Vim can be beneficial. But I feel like this, so I feel like, I don't know if that's really the case, but I feel like it's more of an advanced thing, and sometimes I wonder if it's even worth to learn. So I feel like if you're a developer, then yeah, you should learn some advanced text editor because it could save you time. But if you're still working on basic things, as I feel I'm still working on very basic things, I feel long-term learning Vim can be beneficial, but I don't think it's gonna make or break whatever I'm doing. So it's a beneficial thing. It's a small thing that makes everything nicer. But yeah, I also use I use Vim inside of PyCharm right now, so. Yeah, how to print a model after loading it. You can do print model. Simple enough. Yeah. So can't convert Cuda Tensor to NumPy. So you need to do, if you have it on a GPU, you need to do tensor.cpu and then .NumPy. Oh. Detach CPU clone. All right. I don't think you should. But yeah, you could use .detach. I don't think the clone is not necessary. Yeah, you could .detach.cpu.numpy. That's how you make it so you have numpy. I think the important thing here is dot. I'm not sure if detach is that. I wonder if just using this is enough, but detach is good so that it doesn't. It's not being tracked in the graph, so that you have unnecessary things laying around. All right, torch utils that data random split. How do you use it? Well, you would let's see. Yeah, here's how you do it. You would send in the data set, and then you would do train and validation length. You could do something like this. The percentage times the length of the train set, and then validation is the rest. I feel like he had an answer on this, so. All right, so where's the random split? Okay, yeah, so you would implement, yeah, of course, you would import that, and then you would just use it in that way. Length, you would have an array, you would send in the percentages of what you want, and then you would just do random split. Yep. That should work. How to get the best learning rate automatically. I don't think there is. I'm sure that if you find such a function, you easily get the best paper award at NeurIPS. This is an active area of research as no solution exists, unfortunately. Questions aren't that good anymore, I feel. Maybe we can do .views, and we can just check which are the most viewed topics. Yeah, concatenate torch tensor along a specific, you can just do torch.cat, and you can specify the dimension, how you want to concatenate them along. How to swap axes, you can do .permute, and that would swap the axis. Check out the docs on that one, or my PyTorch tensor tutorial. You kind of specify the dimension that you want them to be at, and yeah, if you, for example, do transpose, that's a special case of the permute function where you just swap two axes. Now, how do I know the current version of PyTorch? You can do print torch dot underscore underscore version underscore underscore. How to print the shape of a tensor inside? You can just do print shape, right? Yeah, you can do size or you can do shape. Yeah. How to change the default device of GPU? So you can directly specify the visible devices. Environment variable, not in the Python script. And you can specify the GPU ID. You can also do, if you do device equals Cuda, you can do Cuda and then maybe someone's going to talk about it, but you can do Cuda and then Cuda 0, something like sort of like a Cuda and then 0. You can set the GPU number here. So you would do something like device torch. Cuda 0 if torch.cuda is available and CPU and that stuff. You can also do torch Cuda set device. That would also be interesting. I don't have multiple GPUs, so I don't have that much experience with this, but I've just seen other people do this. And this is how you would run it then? But it doesn't work. You can also do it this way. That's interesting. I think I've shown this before, how to update Conda, but let's just see if I take Conda. We take this, Conda, activate deep learning. You just Conda update. Okay, Conda. Can't you do Conda update PyTorch? Yeah. So you could do the full impact will be downloaded. So where's PyTorch? Right. How to update PyTorch nightly. That's how to install it. Conda. Okay, so this will update Conda, but not PyTorch. All right. Yeah. All right. So, I mean, it feels like doing. Does this work? Let's see, where is PyTorch? There it is. Channel, PyTorch nightly. But you should be able to just do conda update PyTorch. I think that's how it works. I was just surprised that there's no update there on PyTorch. But let's just do yes then. All right, that was kind of confusing. Anyways. Honestly feels like we've gone through pretty much every of the most common questions. How can I do the operation the same as np.where? Wait, haven't we looked at this question exactly? But yeah, you can use torch.where. Torch.where looks like in 0.4. No. All right. I'm gonna take a break here after 2.5 hours and go to bed, and then I really want this video to be 10 hours long because I think that would look pretty good on the YouTube. So I'll probably try to find some more interesting questions for like 1.5 hours or something tomorrow. So for you, see you in 1 second. I'll go to bed. All right, we are back. And I got my coffee, my morning coffee. Nobody cares about that. We want to see more questions. What is the recommended way to reassign update values in a variable or tensor? Wait. Yeah, this was the question. Why is the following w.data equals w.data minus the learning rate times w.data grad.data? I mean, this is an old way. I don't think you should never do it that like this. Maybe, I'm not sure. Would be interesting to see the more recent responses and what they say. Or should we do w? Oh, okay, so we just do w equals w minus the learning rate times its grad. And they say that the difference from doing minus equals and raise this a little bit. Yeah, so the difference from doing that when doing minus equals is that this will be in place. And we've seen that on other posts as well, that they say that. And let's see. Param.data equals param.data minus learning rate times param.grad.data. In the first case, the operation is put in place, so the Python object is still the same, while in the second one, you create a new object. All right. It says, I guess it's a little bit sad that just using W doesn't work, but because it looks like mathematics. And I think this might work now. But also you shouldn't do w.data. If you were to do w equals w minus learning rate times w.grad, you would still store the history of the computations for the update, which is not normally what you want to do. This is something from Python, not specific to PyTorch. The same is present in NumPy. Yeah, and so by doing it that way with w equals, you'd be storing the history of the computations. I'm not sure why that is, but yeah, obviously your computation graph will then grow bigger, and that wouldn't be good. All right. Should be some tutorials. He mentioned some tutorials. I actually got it from the official tutorials. And then he updates it. So with torch.nograd, with torch.nograd, he does gradient descent, but he does it manually. So for param and model parameters, param minus equals learning rate times param grad. Yeah. All right. So it seems like you can't do it directly. Oh no, I need to scroll down. All right. What I'm gonna do is I'm gonna open them in a new tab, and I think that one is pretty interesting. PyTorch no longer supports a GPU because it's too old. All right. So he installed the new Cuda version, and he has GeForce GTX 950M. But it's of Cuda capability 5.0. PyTorch no longer supports a GPU because it's too old. To reduce the size of the precombined binaries that were going out of hand, we had to remove some of the old GPU architecture that are used by a minority of people. Well, that makes sense. You can still use it by compiling from source, and it will work as before. Okay. Hi, but I installed PyTorch 0.3.0 and everything worked without this error. This deprecation is new from 0.3.1. Alright, so we're back in time. So what do you do if your GPU is too old? So just compiling from source and it will work as before. But you just need to make sure that you have older CUDA. Does that mean that PyTorch doesn't support my GPU from 0.3.1, which is the first version which prints this warning, that it won't support it going forward? What does this usually mean? Also, what kind of operation should I expect to not work? From 0.3.1 CUDA capability 5 will not be included in the pre-packaged binary release, so alters will not work. You will be able to get PyTorch to work with such architecture by compiling from source, so all operations will work. Well, let's say for my GPU with PyTorch, but he just said that you can compile it from source and it would work. Yes, that would be 0.3, but that means that you will be missing a lot of bug fix. Compiling from source should be pretty straightforward if you already have Cuda installed. Let me know if you need help with that. So even for this version, I should just ignore the warning message of a too old GPU. Are you getting a warning? Compiling current master will give you as a writing what is going to become a 0.4 in the future. If you want to keep stable release, you can check out. Yeah. And there's also one. By the way, you don't have to install it from source. You can simply do Python install and then the link to some. And you could also try that, but I mean, yeah, this is a very long time ago. I feel like there's no need. There should be no reason why you need to use 0.3.0. I mean, now is PyTorch 1.6. But yeah, previous versions. So there are a lot of. Oh. Okay. There's a lot of posts left, so let's see what they say. NVIDIA Quadro cards. On popular demand, we're bringing back 5.0 support in the next release. Thank you. You will notice from here that NVIDIA actually had inaccurate documentation of the compute capability. So the support is much appreciated, especially since there weren't many laptops available with higher compute capabilities. Sorry, what should we compile from source to get PyTorch working with an old GPU? Yeah, this has been solved. You can install this, but it also seems like you can install an older CUDA version and then just install the latest PyTorch, from my understanding. For others compiling from source but still getting the warning, it might be working anyway. I'm getting the warning, but the GPU is still being used despite the warning being displayed. Again, this was after compiling from source. So I found GPU GTX 680, which is of Cuda capability 3.0. PyTorch no longer supports the GPU because it is too old. I thought building from source should avoid this. Did I do something wrong? And how he did, he cloned the PyTorch. I think you can just do PyTorch nightly as well. That would bring up the oh, okay. I'm sorry. Okay. This is how you would compile from source then. Yeah. Yeah, I don't have too much experience with this, but it seems like you can clone PyTorch. You can check out to some branch. Let's see. So here there should be branch. Oh, okay. All right, so you would clone, you would check out to a specific branch, and there would be branches. Let's see. Here. And here you would have a bunch of, oh, there's a bunch of branches. Makes sense. And I guess somewhere around here, you have the ones. The old ones, seems like. And then you can just clone it. You can check out that branch. You can build, install, git submodule, update, cmake, and then setup. All right. Hi, that should only be a warning so that it does not prevent from using it. That being said, newer function might not work if they use newer features. You can, so I mean, the gist is that if you have a GPU that is not supported, it might not be worth your while to sort of compile from source and perhaps run into a bunch of problems in the future that feels like a waste of time. And also, if you're using that old of a GPU, and then it's not going to be that fast, right? So you're not going to be training any large models. So you're essentially using it for educational purposes. And if you are using it for that, then I mean, you could just use smaller batch size and so on, and run on the CPU. Although it might not be that simple. It might actually be use cases where, you know, yeah, I don't know, it might be difficult. All right. And then there's a question, how to install Python version on Windows? Oh, okay. And then PyTorch, he wants to know that how can I know sort of a table which PyTorch, the CUDA version it supports or not. And he needs to choose for PyTorch 0.8.0. And they don't have such a table. And also, they went from 0.4.1 to 1.0 directly. And then I want to use Quadro 2000. And then they said it's a very old card. I think we dropped support for a very long time ago. Yep. Then the post is sort of about something else. All right. That's it. Let's move on. Runtime error, could error device side assert trigger. Oh no. Ugh. So dumb. Ah. Yeah. Put in my code here and it says with their runtime could error device side assert triggered. The first thing is to try to run on the CPU. CPU code has more checks, it would possibly return a better error message. All right. I mean, so if you get an error for device header assert triggered and you get a weird error, then you should try to run it on the CPU and hopefully you get a better error. If the CPU code runs without error, then run the same thing with Cuda launch blocking 1 to get a proper error message and stack trace. All right. The code works fine on the CPU, but fails to run on the GPU. And there's a single entire post on this. Debugging Cuda device side assert in PyTorch. The beautiful thing of PyTorch immediate execution is you can actually debug your programs. Sometimes, however, the asynchronous nature of Cuda execution makes it hard. Here's a little trick to debug your All right, let's see. So when you run a PyTorch program using CUDA operations, the program that usually doesn't wait until the computation finishes, but continues to throw instructions at the GPU until it actually needs a result, e.g. to evaluate using .item or CPU or printing. While this behavior is key to blazing performance of PyTorch programs, there's a downside. When a CUDA operation fails, your program has long gone on to do other stuff. The usual symptom is that you get a very non-descriptive error. Yeah, we've all been part of that, or had that experience. Error at more or less random place somewhere after the instruction. The triggered error typically looks like this. So it does some operations, it does something, and then it prints. And then on that one, runtime could error device side assert triggered. Well, that is hard to understand. I'm sure printing my results is a legitimate course of action. So device side assert means I just know that something went wrong somewhere. So, all right. So here's the faulty program. So they have activations, they have labels, and then you use cross entropy. So where's the error? One option in debugging is to move things to the CPU, but often we use libraries or have complex things where that isn't an option. So what now? If we could only get a good traceback, we should find the problem in no time. This is how to get a good traceback. You can launch a program with environment variable Cuda launch blocking set to 1. But as you can see, I like to use Jupyter for most of my work, so this is not as easy as one would like. But then you can do import OS environment Cuda launch blocking equals to 1. And with this addition, we get a better traceback. All right, so then we actually get the traceback, seeing where does it go wrong. And so we actually see that it's in the loss function, and that makes sense. I wonder what's wrong here though. Here's the cross entropy. He has a cross entropy. He has random. Torch range. Perhaps these values, no? Wonder what went wrong. Alright, so apparently it doesn't like what we pass it. In fact, our activation has a batch times 3, so we'll allow for 3 categories. Oh. Okay, so there's an out of bounds indexing. The best part is it also works for non-trivial examples. Now, if we only recover the non-GPU bits, yeah. All right. Use Cuda launch blocking. Let's see what they say more. I'm also getting error in the CPU. You should read this post. And there's a... Well, yeah, I think that post was pretty good. You can just scroll through this post. All right. The reason why you met this problem because your target labels include minus values such as -1. Yeah. So it seems that you can get this error when you're doing out of, I believe it's called out of bounds indexing, so that you're indexing things that you're trying to index things that doesn't. The reason why you met this is because your target labels include minus values. Yeah, and that you can't index that. All right, let's see. Why is PyTorch giving me a hard time with float, long, and double tensor? I have an LSTM model where I have to cast data in float tensor because pre-processed data is long. And okay, the pre-processed data is long, but he has to convert it to float. And since the problem is a classification, I use cross-entropy loss, and then the target should be long. But cross-entropy doesn't take a float tensor. So once again, I need to cast it into a long tensor. But then I have log self-max forward is not implemented for type torch.long tensor. Why is it so difficult? Why does the framework not convert the requisite type since all the 3 types are same except in how much memory they are stored? All right, so he says try the following. Loss, output, and the variable is long. And yeah, I think this is how the outputs are floats, but the variables should be long. When there's a type mismatch like this, there might be some misunderstanding around what the functions do. For example, if there is a reason why cross-entropy thinks long tensor and float tensor, long tensor target float tensor inputs. Yeah, and that's that makes sense. I mean, that's how cross-entropy. That's how it should work. These should be long since they're going to be integer. Well, actually, why isn't it? All right, so I don't know why it's not integer and why it needs to be long tensor, but or I mean rather, long tensor is int 64, but why is it needed to be in 64 and not? Why can't it be in 32-bit? But I'm probably just missing some basic understanding there. But at least, you know, there's fundamental understanding of why it's not float. I mean, it's supposed to index. So the target are sort of supposed to be indexing in the input for the node that is correct, and seeing how far or close it is to being I don't want to go into that too much, but yeah, it makes sense why it should be long, and the input are just logits, meaning they just have score values, because it's run through softmax and then log likelihood. And yeah, that works. I would like to still see if there's a solution to this conversion problem. It is somewhat annoying. Is it going to be implemented to do the conversion automatically, or is the reason not to do it? The reason not to do it is that it's something there's a misunderstanding around what the functions do. Let's say I don't know what the indexing operation does. Tensor of scalar. If I pass through a float scalar and it gets converted to an int scalar, the operation will work and will return something. However, I may have missed. Maybe I assumed the indexing operation does addition. So it's tensor scalar is tensor plus scalar. Then my code would run and I would have, usually there's a good reason behind some function only taking long time, some function only taking float types. If you see something you think shouldn't have these restrictions, please let us know with a forum post or an issue. And this makes sense, right? Because if you can expect different behaviors, or rather, if it's doing operations that you don't expect and that shouldn't mathematically work, then I feel that people are gonna just be lost. So if you're sending in stuff that isn't how the function works, then you should get an error. And so the thing is really that, if I get these types of errors, it's because I don't understand how the function works or stuff like that. It's not because the function should do that type of conversion automatically, because it's good that the function is warning me that I'm using it incorrectly. I'm all for throwing an error when the types don't logically work, but for example, half, float, double, automatic conversion as an option would be nice. Alright, so when you have floats but you have them in different bits, and this, you could have an argument for this, I feel like, because here the understanding of what the function does is still there, since they're all floats, but it's not of the correct. It's not double, which would be needed for some operation maybe. And same for long, byte, short, int. These are only different types because of efficiency. Yeah. And there's no reason cross entropy shouldn't work with a byte tensor. It's also super frustrating to work in 16-bit precision, because so many of the built-in functions either don't work or are slow using half precision floats. We agree with you, and we're looking into implementing this functionality. A proposer for typecasting can be found. All right. Hopefully they did it. Let's see. Module.children versus module.modules. I was trying to remove the last layer, fully connected, of Resident 18 to create something like this. Alright. And as it turns out, this did not work. And he found another post, and I've seen this too. What's the difference between the two? So not using modules here, using children instead. All right. That modules also returns pre-trained model as one of the elements. So nn.Sequential, nn.Linear, and ReLU dot modules is sequential of linear ReLU. But if you do children, you get just a list of linear and then ReLU. All right. All right. What's the intended use for modules? If you want to recursively iterate over your modules, then you want to use modules. For example, we have sequential, we have nn linear, ReLU, and we have a sequential inside the sequential. Calling m.children will return linear, ReLU, and then sequential of these, which means it does not go inside the second sequential and does not print individually sigmoid. On the other hand, m.modules recursively walks into all modules into the network. So if you do, right, this was .children, and if we do .modules, it's gonna have all of them for us. All right, recursively walks into all modules. All right. Yep. Oh, let's go back. All right, tensor.view is misleading. How reading documentation for tensor.view? It seems like it could be used to swap two dimensions in a tensor. All right, so in the documentation, they say that it can be used to swap, but that's not how you would. To swap, you would use permute. All right, so he has some tensor 1, 2, 3, 4, and wait, are these all? Yeah, these are all. So these are 4-dimensional tensor with 1, 2, 3, 4 elements. Then he wants to swap the second and third dimension using split and stack. All right, so he can use, I mean, you could also do permute instead of split and stack, right? But all right, he does it here, and he can swap it. But then if you swap second and they're using tensor.view, it still has the same shape, but they're not the same. And I mean, maybe you could say that what it's doing then is that it's just taking one element from this one, moving it over, and then making this 3 and this 2. Not necessarily swapping, but just in that way making the most convenient way to reshape. But let's see. It's a bit tricky for me to explain it in words, but it does not directly swap the two, but it rearranges the value so that it adheres to the new dimension. Maybe the easiest way to explain would be an analogy like transpose. Yeah, and I'm thinking maybe just when it does this, it's just taking one element from this, rather than actually swapping. All right, but then if we do a.view 3 and 2, so here he has 2 by 3. And so yeah, if he does transpose on this, he would expect 1 4 and then 2 5 3 6, right? That would be the case if we take the transpose of this. But when he does a.view, he gets 1 2 3 4 5 6. So essentially, it's making the most convenient way to reshape it, and the most convenient way is I guess how it would be stored in memory. And these two would be, so these two, and these two. Yeah, exactly. Or maybe think of it as creating a new, and I think tensor.view is a very common way of making mistakes, and incorrectly using view as a way to swap axes. Because view doesn't swap, it just reshapes in the most convenient way. And you sort of need to make sure that the most convenient way perhaps is exactly what you want. Maybe think of it as creating a new empty tensor with the new dimension specified with view, and then gradually filling it in order using the original values. So reshape from NumPy is the same as view from torch. That is correct. View is maybe a bit more clear because it's just changing the view onto that array, not how it's laid in memory. All right. Let's move on. What is the difference between tensors and variables in PyTorch? I was looking that there are variables and then there are tensors. And I think tensor is sort of the fundamental, and then variables sort of include tensors and a track of some sort of history of the tensor. So variables use tensors. That's my understanding. Though I don't quite understand why we need two structures that do essentially what looks to me the same thing. I think variables sort of keep track of the maybe it's the same. Let's see what he says. Variable API is nearly the same as regular tensor API, with the exception of a couple in-place methods that would override inputs required for gradient computation. In no case, the tensors can be safely replaced with variables, and the code will remain to work just fine. As far as I can tell from reading the docs, variables are part of the Autograd package, thus they can perform gradient computation and stuff. The only clear distinction to me seems to have torch tensor as placeholders for data, but variables can already sort of do that by setting the required grad equals false. Requires grad false to false. Thus, it just seems very odd. All right. Think of tensors and variables as the same thing. Variables are just wrappers for tensors, so you can now easily autocompute the gradients. So if tensor was Batman, a variable would be Batman, but with his utility belt on. All right. Batman can do the job, but if he has his utility belt, he's got cool gadgets to use. I like the metaphor. Torch tensors are actually the data. Variables wrap tensors and construct a chain of operations between the tensors so that the gradients can flow back. So for example, if you create A and then add 1 to get B, there's now a link stored between A and B in the creator property of B. Then when you call .backward on B, the gradient back propagates via the function in B creator into A. Tensors don't have the concepts of gradients, creator, etc. They purely store data and handle operations like adding, multiplying, and stuff. But why is it not possible to forward a tensor through a sequential model? Only variable works for me. That's because we don't write the code for tensors, we wrote it for variable. Alright. Why is it not possible to forward a tensor through sequential? Alright. The variable class is a wrapper over tensors that supports nearly all operations defined on tensor. PyTorch requires that the input tensor needs to be forward propagated, has to be wrapped in a variable. This facilitates back propagation. Alright. But as of now, the variable API has been deprecated. Yeah, because this I was a little bit confused over this because I haven't encountered variables, and I was like, am I missing something? Because I know what variables are, and I've seen people, because I've seen a lot of posts about them now, but I haven't actually used variables. So it seems like variables are deprecated, and they now, you can just do requires grad to true on tensors. All right. So there was a difference. Variables were wrappers for tensors, but that's no longer the case. Tensors are now tensors, and they will be tracked through Autograd if you have the requires grad equals true. Save a tensor to file. I think you should just be able to use torch.save. Yeah, torch.save tensor and then file.pt, and then torch.load file.pt. What's the difference between nn.ReLU versus f.ReLU? And we haven't covered this specifically, but pretty much, well, we can just see what is the difference. nn.ReLU creates an nn module which you can add to an nn.Sequential model, and then functional ReLU, and then it's just a functional API to the ReLU function, so that you can add it in your forward method yourself. Generally speaking, it might depend on your coding style if you prefer modules for the activations or the functional calls. Personally, I prefer the module approach if the activation has the internal state. Yeah, and this is the guideline that we've seen on other posts, and I'm sort of reiterating now if someone clicked on this specific question, because essentially, you have nn modules, and they are sort of built on top of the functional package. So functional is sort of the core where it has all of these operations, but let's say that we have ReLU, then it really doesn't matter if you use the nn module, but then we would need to initiate it first in the init function and then just call it in the forward. If you use the functional, you can call it in the forward directly. Now, the tricky thing is when you use things that depend on the internal state, meaning that, rather, it matters if the thing we're using has an internal state, which means that it depends on the model being in evaluation mode or being in training mode. So things like dropout depend on which the model is in evaluation or training, because it needs to drop the dropout, not have dropout, and then it also does some rescaling. And similarly for backnorm, it doesn't keep track of running averages anymore. So if you have that, so you have dropout, you would use the nn module. Now, to make things more complex, you can also use the functional, but then you would need to specify. So you would do an argument in f.dropout, you would do training equals self.training. So it seems like the guideline is use nn modules if you like it, but more specifically use it if things has an internal state, otherwise use the functional. How to use collate fn. We've seen this used, but maybe we can try to understand how it works. So an example that helps understanding what it does. You can use your own call to process the list of samples to form a batch. The batch argument is a list with all your samples, and so essentially this is used for creating well, it's used maybe for many different things, but an example is when using sequence models, you can use the call it fn function to pad your sequences so that they're all equal length. You can do that if you create a custom data loader. And yeah, we've seen this, but yeah, you would create your collate, you would do stuff, and you would return the data and the target inside it, and then in the data loader, you just use collate fn is my collate, and I'm not sure why it's called collate. Customized collation, e.g. padding sequential data to max length of a batch. Yeah, and there are examples of how to use that. Yeah, so you first get a list of tuples. Yeah, you get something from your get item in your data set. Then it runs through your collate fn. Yeah, so there are examples here of him doing collate fn. Yeah. All right. So if you want to know exactly how to use it, then I would go to this, and I would go to this thread, which we looked at, but not in that much detail, but you would just do something like this, but you would need to do some padding and stuff. And I think there are more examples. There are people discussing it on this one. They have collate fn pad, and then they sort of check. They get the length, and then they pad them, and then they compute some mask, which I guess is optional. But yeah. Let's see. This might be interesting. Calculating accuracy for the current mini batch. So it's that one. How do I calculate the accuracy for the current mini batch in my training? And this should be pretty simple, since you're computing the scores. You would just need to take the argmax of those if you're using well, because this, I guess it depends a little bit. But if we have a simple like MNIST or something like that, then you can just take the argmax, you can just compare it with your targets, and you just calculate the accuracy that way. That would be the accuracy for your mini batch, and then you could use that to sort of have a running accuracy over your epoch. Although, and then you could use something fancy like a accuracy bar or something like that to sort of see what the accuracy is. And I think this is what Keras does, because if you actually just want to compute it if you compute the accuracy on the test set, then that's going to be quite expensive. So you're going to have to do a forward propagation. Although you're not doing the backward prop, but it's still going to be quite expensive just doing the forward prop. So with that, you know, you would well, where was I going with this? So yeah, if you want a running training accuracy, you would do it. You could do it just using your training data and not do any unnecessary computation. But it won't be an exact accuracy, because it will fluctuate from batch to batch. But you will get an average. Although the accuracy in the beginning of let's say you're just the first epoch of training, the accuracy is going to be awful, and then in the end it's going to be a lot better. All right, but yeah, correct, you can do targets equal and then outputs and then sum. Yeah, and that's how you would do it. I mean, just for example, I have you would essentially do the check accuracy function, but you can remove a lot of its computation since the forward has already been done. But yeah, but I think that answers the question. So yeah, you can do something. Yeah, you take the argmax, you then sum it, and then you would divide by the total number in the batch. And there's a guy that did it in just one line. I mean 2 lines. Yeah, I mean that's how you would do it. Let's continue. Could I downgrade PyTorch, or should I do something more after upgrading? I don't think it's a problem of the newer version. You probably have very tight limits on the amount of shared memory in your system. Probably deadlocking everything. Sure, or you're trying to load every very large image or videos. If you wish to downgrade, you can install, because you can install previous versions. All right, but you can just install previous ones. Why do we use .pow2 and not ***2? And they are equivalent, I think. I always use ***2 and I have not run into problems, and I would expect it to roughly have the same performance too. For operators, Python needs to figure out whose special function it should call. I suspect that people coming from other languages might not be used to the convenience of a power operator. Yeah, and it's element wise. Yeah, but so it just calls pow, so they're equivalent. How the hook works, I've been wondering about. I was reading the docs and I'm confused about how the hook works. Here are some questions in my mind. Does PyTorch maintain a... Yeah, I don't want to go into this in depth because, yeah, I was also wondering if, since we don't use variables, does that change how the hooks are used? But yeah, and I also feel like I would need a tutorial or something like that to understand it. How to delete PyTorch objects correctly from memory. Delete test. Cuda memory is not freed up. Is there a clean way to delete a Python object from a Cuda memory? Hi, it's because the Cuda backend uses a caching allocator. That means that the memory is freed, but not returned to the device. If after running del test you allocate more memory, you would see that the memory use will stay exactly the same. It did not reallocate memory, but reused the one that had been freed when you ran del test. So if you run del, then it's going to remove it, but it's not going to give it back to the device. All right. PyTorch model running in Android. I have made a simple image using, now I want an Android app. My question is, how can I implement PyTorch model in Android? And I think this is these are old ones. You wouldn't have to do this, but now you can actually do it now. And see, there should probably be some newer posts on this. I'm surprised that there are not more actually top threads about this. Yeah, I know there are definitely newer ways. So Android, PyTorch. You can go here, and here they have sort of tutorials. They have an Hello World app, and they have sort of an example, and then they have they tell you how to use the model, you would need to use git.trace, and then you would save that. Yeah, you would use Android Studio, and then you would, yeah, I'm no expert on this, but there are tutorials here that kind of show you step by step how to build, how to do development on Android with PyTorch. Volatile now has no effect. Use with torch.grad instead. So in the, you can set volatile. All right. So variables and tensor merge in version 0.4. So then you can just use torch.grad instead of volatile. if you're using with third-order explicit saying you don't want to calculate gradients, so loss.backward won't work. Usually you use it for the validation test set. If you need to call loss.backward, you shouldn't use it. Yeah. Print a verbose version of a tensor. If you print a tensor to const, it prints a truncated shortened version. Is there a way to print the verbose option for the tensor? You could use torch.set print option threshold 5000 to set the threshold higher. See the documentation. So here we have print option, precision. You can see precision. You can see threshold. All right. Ideal way, torch.set print option profile full, print tensor name, print set option default. All right. Could someone explain batch first equals true in LSTM? This is just how the data is structured. So you would have, normally you would have the time, you would have 3 dimensions for your tensor. You would have your time step, you would have your batch size, and then you would have the features. So we looked at this in a previous post, but sort of the time step, saying that let's say we have 10, mini batch of 1, and we have 10 time steps, where each time step we have a word, and so we have an associated feature size of length of the vocabulary. So let's say our length of vocabulary is 100, and we have 10 words, and we have an example of 1. Then the size would be 10, 1, and 100. But you're just swapping. If you have batch first, that means you have the batch on the first dimension, so you would have 1. But let's see. If you input data of shape sequence length, batch size, features, then you don't need batch first equals true. And your LSTM will give output shape sequence length, batch size, hidden size. If your input is of shape batch size, sequence length, features, then you need batch first equals true, and your LSTM will give output of shape batch size, sequence length, hidden size. And I think that's the answer. Yeah. Is it possible to use PyTorch without GPU support? Yes. PyTorch can be used without GPU, solely on the CPU, and there's a command on PyTorch. When you install it, you can choose here if you don't have Cuda, it's going to be CPU only version. Please help me understand installation for Cuda on Linux. And I think on the newer versions, you don't have to do anything. You just, it's going to install Cuda automatically for you if you just use the PyTorch installation command. At least that worked for me. So we can see the newer posts. Yeah. But yeah, you would just install the package as we looked at and choose the Cuda version, and then that would work. Tensor mat logical operations any and all. Any and all functions are defined on bytensors. So you can do, and they are basically, you know, if you have true or false. If you do .any on a tensor with true or false, which is what .byte does, it's gonna, if any are true, it's gonna return 1, and if you do .all, it needs to be so that all of them are true for it to return true. So that was a quick question. Best practices for maximum GPU utilization. However, the related post about best practice for using a GPU, and this question is different. I am tuning my batch size such that the largest batch uses 90% of GPU memory. Thus, some batches will use close to 90%. This wasn't really what I was expecting. This comes from yeah, I'm gonna skip this one. This wasn't that good about the best practices for GPU utilization. Yep. All right, so I think this is now 10 hours of reading through the PyTorch forum, and I feel like some of the questions are starting to get repetitive, and I feel like we've gone through a lot of questions. I've learned a lot, and I've particularly learned sort of what my limitations are and what I need to learn more about. And what to say. But yeah, so yeah, I just want to say thank you for watching the video. I mean, you probably didn't watch the entire thing, but you clicked on the video, so thank you for clicking on the video at least. And yeah, hope to see you in another video, and like the video if you want to share. Like the video if you want more of these kinds of videos. All right, see ya.